Now, with the core basics and the foundation about React and its most important features out of the way and applied to our course project, we're gonna take the next step in this module. We're gonna have a look at 3 very important concepts which you need to know as a React developer. And that will be effects, reducers, and context. Now, these features are a little bit more advanced, which does not mean that they're difficult. This just means you need to know the other concepts first, which is why we are now diving into those concepts here. And with those features, you will be able to make a huge step forward towards more complex React applications. Now, in this module, we will therefore take a closer look at what effects are and how you can work with so-called side effects, which is what effects means, but more on that in a second. We'll have a look at how we can manage more complex state in our components with reducers. And we will explore app-wide, or at least component-wide state, so the state that affects multiple components, with a concept called context, which is built into React to make sharing state and state updates across components easier. A lot of important features that are included here, so let's not waste any time and let's dive right in. So what is an effect, also called a side effect? And I will use these terms interchangeably. So when I say effect, I mean side effect and the other way around. But what is that? Well, let's not forget that our components in the React app and our React app as a whole, and also especially the React library itself, has one main job: to render the UI, to react to our user input, to re-render the UI when it's needed. That is what we focused on thus far. With state and events and all of that, the main job was to bring something onto the screen and to make sure that the user may interact with that something and that what's shown on the screen may change based on certain events, for example, based on a button click or some text being entered. So therefore, that's the main job of React and of our application. We want to evaluate and render the JSX code and the DOM. We want to manage state and props to make sure that every component has the data it needs and that we reflect the user input correctly. We want to react to user events as mentioned. And of course, React is there to also re-evaluate our components and their JSX code and manipulate the real DOM as needed. So that's all baked into React with the tools and features we learned thus far and which we will dive into throughout this course, of course. So something like the use state hook, props, and so on. That's the main job. And if we have a look at a React component, this is a component from this module's project, which I'll dive into in a second. Then we learned that a component is just a function, therefore it's executed top to bottom, and everything in that function in the end deals with bringing something onto the screen and or with reacting to user input, to clicks, and so on. So that's what this function is all about. We may use state in there, we may have other functions in there, which for example are triggered upon a button press and so on. But everything we have in this component function is concerned with bringing something onto the screen. Now, therefore, side effects are everything else that might be happening in your application. And a good example here is sending a HTTP request or storing something in browser storage, in local storage, for example. But you could also think about timers or intervals which you set in your code. These are all tasks which you of course often have to consider in your application. For example, a lot of web applications need to send HTTP requests to backend servers, but these tasks are all not related to bringing something onto the screen, at least not directly. Of course, you might be sending a HTTP request to then draw something onto the screen once you got the response, but sending the request itself and handling potential errors and so on, That's not something you need React for. That's not something React cares about. That's not what React is there for. It's not something that is related to drawing something onto the screen directly or anything like that. So these are therefore tasks which must happen outside of the normal component evaluation. So outside of your normal component function. Because you must not forget that this function, this app function, for example, is re-executed by React automatically whenever, for example, the state in this component function changes. Whenever this isLoggedIn state would change here, this entire function reruns, and React then basically checks what the new result of this function execution, so the new JSX code, looks like, and if, compared to the previous result, it should go to the real DOM and make some changes there. And we'll dive deeper into how exactly React works under the hood in a separate section, but this is what you learned thus far, and this is what React does. Now, since this is what's happening, if we would send a HTTP request, for example, directly here, then we would send this request whenever this function reruns. So for example, whenever this state changes. And that might sometimes be what you want, but definitely not always. And if in response to your HTTP request, you, for example, eventually change some state, you would even create an infinite loop. Because you would send a request whenever the function reruns, and in response to the request, you change some state which triggers this function again. So therefore, such side effects should not go directly into this component function, because that would most likely create bugs, infinite loops, or simply send too many HTTP requests, to stick with that example. Therefore, we'll have a better tool for handling side effects, and that's a special React hook which we can use, the useEffect hook. The useEffect hook is simply another built-in hook. So another function you can run inside of your component function that will do something special. The useEffect hook is called with two arguments, with two parameters. The first argument is a function that should be executed after every component evaluation if the specified dependencies changed. And the specified dependencies are the second argument that you pass in. That's an array full of dependencies, and you will see how these dependencies look like throughout this module. So an array full of dependencies, and whenever such a dependency changes, that first function will rerun. And therefore, in that first function, you can put any side effect code, and that code will then only execute when the dependencies specified by you changed, and not when the component re-renders. So only when your dependencies changed. Now let's have a look at that in action, and for that I prepared a little project which we're also going to have a look at. So attached you find this project here. You can simply download it, extract it, run npm install inside of it, and then npm start, and you will see this page on localhost 3000. Now that's a very simple dummy app where you can enter any credentials of your choice. That's not a real authentication screen yet. For the moment it's just a dummy screen. As long as you have a valid email address and a password that is at least 7 characters long, you can click the login button and you're on this dummy welcome screen. These links won't do anything, but the logout button will take you back. So it's a very simple dummy app. At the moment, there is no real authentication logic. We'll dive into that in a separate module. But it is a good enough example to practice the useEffect hook and side effects therefore, and also the other core concepts of this module. So what's up with this useEffect hook now? Well, what could be a good side effect here? Sure, we could send a HTTP request to a backend server, which validates our email and password. But at the moment we have no such server, so therefore I want to do something else. At the moment when I log in with any dummy credentials, which are an email and at least 7 characters long for the password, if I click login, I am logged in this dummy mode, But if you reload this page here, you always lose this login status. And that is probably not something you want. Now, in reality, you would, of course, once you log in, send a request to the backend and get back some login data. For example, some token which identifies this user as authenticated. Again, more on that in the authentication module. But you want to make sure that this user is authenticated status is also still there once you reload the page. At the moment, we lose this because in the app.js file, where I manage this simple isLoggedIn state, it's just managed as some React state. And therefore, it's just, in the end, managed in some JavaScript variable behind the scenes by React. Now, the nature of that is that when you reload your application, your entire React script restarts, and all variables from the last execution are lost. That's how the web and scripts and the browser works. This is nothing React specific. Now, since we lose all the data when this restarts, it would be nice to store it somewhere where it persists the reload. And even better than that, we also want to make sure that whenever this app does start, we check if the data was persisted. And if it is, we log the user in automatically so that the user doesn't need to re-enter the details. And that's where we can use useEffect. Now let's start with storing the data. Here in the logged-in handler, I set isLoggedIn to true. And that's where I want to store that piece of information in the browser storage. Now the browser has multiple storages we can use. The most common storage for this would be cookies or local storage. And since it's particularly easy to work with, we will use local storage. So that's a storage mechanism built into the browser, totally independent of React. Here in the login handler, we could therefore run local storage. This is a global object which is available in the browser. Set item, and then give the item any identifier of our choice, like for example, is logged in. But that's totally up to you. It should just be a string though. And the second argument should also be a string which you store. And for example, that could be 1 to signal that this is that the user is logged in. 0 could stand for not logged in. Of course, you could also have some identifier like this. This is totally up to you. I will work with 1 and 0. So we can set this item here. And if I do this and I save everything, if I do log in again here, I can open up the developer tools thereafter. And there open the application tab or the application part. There you'll find the storage section with the local storage. And if you expand this, you'll find your host, and there you should now find this key value pair. That's stemming from this line. So that's how we can store data. Now we can do this here in the function because it is a function that executes only when the user clicks the button, which is rare enough and which is exactly when we want to store something. So that's now a use case where we don't need useEffect necessarily. But how about the scenario that the app restarts because the user left the page and comes back, or simply because we reload the page? Then we want to check if in local storage we have that key value pair. Now, when the app restarts, this app component function runs again. Now, therefore, here, of course, in this function, we could reach out to local storage, call getItem and search for isLoggedIn, and this will return the item stored there. So that's the stored user logged in information. That's a super long name. Obviously, I just want to make it clear what's in there. You would typically use a shorter name, of course. And we could check if the stored user logged in information is equal to 1. And if it is equal to 1, we could call set isLoggedIn and set this to true. So that we set the user to logged in even without this function being triggered. And it would trigger upon pressing the login button normally, just because we know that the user is logged in. And of course, we should do that after calling useState. So we could do that. But the huge disadvantage with that approach is that we would create an infinite loop. because we check for this being stored. If it is stored, we set this to true. And whenever we call a state setting function, this component function re-executes. And therefore, this would run again, would find 1, would set it again, and so on. That's what I explained earlier. So we need useEffect here, because that allows us to control when this runs. Hence, from React, besides useState, we import useEffect like this. And then here, we can simply call useEffect, just like this. And now we pass those 2 arguments you saw on the slide to it. The first argument is a function, for example here, an anonymous arrow function. Doesn't have to be an anonymous arrow function, but often you use just such a function. The second argument is an array of dependencies. Now I'll come back to those dependencies later. For the moment, let's just write it like this. In this function, we can now run this code here, which we don't want to run directly in the component function. Because now this function here is executed by React, and it is executed after, important, after every component re-evaluation. So whenever this component function ran, thereafter, this will run. And if you then update the state in here, the component will run again. But it will not just run after every component evaluation, but only if the dependencies here changed. Now, when the app starts for the first time, that will be the case. If this component function runs for the very first time because your app just started, then the dependencies are considered to have changed because you had, well, no dependencies before, you could say. But once it ran for the first time, for example, with this setup here, we have no dependencies, but therefore, of course, they also didn't change compared to the first execution cycle. So therefore, this anonymous function here would indeed only run once when the app starts, because thereafter, well, the dependencies never change because this here specifically has no dependencies. And in this scenario, that's exactly what we want. We want to run this code once, and that's when our app starts up. So therefore here we should have exactly the behavior we want. Once the app started, this code runs. Here we update the state, and as you learned, this triggers this component function to run again. Now therefore this all runs again, this JSX code is evaluated and the DOM is updated accordingly, but thereafter the effect would run again, but only if our dependencies also changed. And that's not the case here, as I explained. So therefore, this should only run once. And hence, if we save that, and I reload here, you see I'm logged in. I don't end up on the authentication screen, but in the logged in state. And the reason for it is that we have this stored. Now, if I clear that manually by selecting it and deleting it, if I now reload, you see I'm back here. Because this code still ran, but of course it didn't find the logged in information. If I do log in again, so that this is stored, you will see we're back to the behavior from before. If I reload, I end up on this page. So that's useEffect, and that's one scenario where it shines a lot. This data fetching is a side effect. It's not directly related to the UI. Of course, the result is, but not the data storage access itself. And we want to run it as a side effect with useEffect in this case to avoid an infinite loop and to make sure that this code, which potentially could also be performance intensive, does not run for every component re-render cycle, but only if we want it to run. Now let's refine our data storage example here by also making sure that when we click the logout button, we again reach out to local storage and we remove the is logged in key there, simply to clear it from there so that we don't have to clear it manually by selecting it here. So we saw useEffect in action here in the scenario with no dependencies. Now, often you need dependencies because you don't just want to run this effect function once when the app starts up, but indeed after every component re-evaluation if a certain dependency changed. And an example can be found in the login component. That's the component where I actually render this form here, this form here. That's being rendered here. And as you see, there is actually some validation built in. If I click in here and I click out, you, for example, see this is marked as red. And also the button is only enabled if I have entered something valid in both inputs here, right? So otherwise the button is disabled. So we got some validation, and currently the validation works such that for every keystroke on the email field, this email change handler runs, and it sets the form as valid if the email contains an @ symbol and the entered password was correct. And we get the same for the password change handler. And I also got the validate email handlers, where I set email and password as valid whenever the inputs blur, so whenever they lose focus, so that they also are marked as invalid if I just click in there, enter nothing, and click somewhere else. Now, where could we use effect here? Well, for example, to restructure our validation logic here. Instead of having essentially the same logic, just, well, swapped basically, in the email and the password change handler, we could use effect to have one place where we mark the form as valid or invalid with one logic, which should trigger whenever either the email or the password changed. And that's where we will need an extra dependency. So therefore here, we can again import useEffect, and then here after our state definitions, we can call useEffect and pass this first function to it, and have our array of dependencies. Now in this first function, I will call setFormIsValid, but of course I will not use the event target value, but I will check if the entered email includes the @ symbol and the entered password is longer than 6 characters. Now, like this would only run once, and that's when this component first is rendered. So therefore, if I remove that logic from the password and the email change handler, you will see that I can reload this and I can type in there, and my form, well, this button never gets enabled. And the reason for that is simply that this effect only ran once, as I said, when the component rendered for the first time. Now, that was the right behavior in the app component with our login state. It's definitely the wrong behavior here, though. We want to re-evaluate this and rerun this form validation state setting function for every keystroke in email and password change handler. Now, we could remove the dependencies array. Now, don't save this because this would crash your page. This would make sure that this runs whenever this component was re-evaluated. Therefore, effectively, in this case, it's the same as if we would have moved this code directly here into the component function itself. Because now, without any dependencies, this code reruns whenever the component was re-rendered, and since we set state in here, this would trigger a re-render cycle itself, hence we would have an infinite loop. So saying nothing about the dependencies is not what we want, but no dependencies is also not what we want. Then it would only run once. Well, indeed, there is a simple rule. You add as dependencies what you're using in your side effect function. So in this case, we are using the setFormIsValid function, we are using entered email, and we are using entered password. Includes and trim are only called on those entered email and entered password fields then. So we have setFormIsValid, entered email, and entered password. These are our 3 things we're using here. So therefore, here between these brackets, you would add setFormIsValid, entered email, and entered password, just like this. Important for setFormIsValid, you of course don't execute it. That would add the result of this function execution as a dependency. But instead you add it like this to add a pointer at this function, so that you essentially add the function itself as a dependency. And this tells React that after every login component function execution, it will rerun this effect function, but only if either setFormIsValid or entered email or entered password changed in the last component re-render cycle. If neither of the three changed, this effect function will not rerun. Now actually, you can also omit setForm is valid because those state updating functions by default are ensured by React to never change. So these functions will always be the same across re-render cycles, so you can omit them. Entered email and entered password could have changed, of course. To be precise, with every keystroke, one of them will change. So if we now save this, and we try this again, you see the login button still enables and disables. And the reason for that is that now this effect function reruns whenever entered email or entered password changed. So that's another scenario where useEffect shines. It helps us make sure that we have one code in one place instead of, as before, in multiple places, which reruns whenever one of the dependencies changed. And that's also something where you use useEffect. So it's not just for when a component was created for the first time, but it's equally common to use it to rerun logic when certain data, typically some state or some props, changed. Now, one aspect that could be confusing here is that, of course, now inside of this useEffect example, we're not working with local storage, we're not sending a HTTP request, we're not setting a timer or anything like that. Instead, we are updating the React state. And that could be confusing if you recall that slide from earlier where I had a slightly different separation. So to clear that confusion, you must not forget that it's called useEffect, and it has one main job. It's there to handle side effects. And often, side effects are HTTP requests and so on. But it's also a side effect if we listen to every keystroke and save that entered data, as we're doing it in the email change handler, for example, and we then want to trigger another action in response to that. So checking and updating that form validity in response to a keystroke in the email or password field, that is also something you could call a side effect. It's a side effect of the user entering data. So that's why this should not confuse you. useEffect in general is a super important hook that helps you deal with code that should be executed in response to something. And something could be the component being loaded, it could be the email address being updated, it could be anything. Whenever you have an action that should be executed in response to some other action, that is a side effect. And that is where useEffect is able to help you. That's just a little addition I want to make here. Now there is one last important thing you need to know about useEffect or about the built-in features of useEffect. We learned about this effect function, we learned about the dependencies with the scenario that we have no dependencies with an empty array or that we have some dependencies. Now sometimes you also have an effect that needs to do some cleanup work. And that sounds very abstract, so let me give you a more concrete example. Let's say here, we're executing this function essentially on every keystroke. This is what happens here. I can prove this to you. If I console log this, checking form validity, you will see, if we go back here to the console, with every keystroke, this runs. Now that's not a problem here. This function execution is fairly fast. But what you do in this function, that might be a problem. Here we are updating some state. This might already not be ideal. Now I'll be honest, for this simple state update it won't be a problem, but of course it means that it triggers another function component execution and that React again needs to check whether it needs to change something in the DOM. So even that might not be something you really want to do for every keystroke. Now imagine you would do something more complex, like for example, send a HTTP request to some backend where you check if a username is already in use. You don't want to do that with every keystroke, because if you do, that means you're going to be sending a lot of requests. And I don't know about you, but that might be a lot of unnecessary network traffic. So that's something you might want to avoid. And as I said, even this year, this state updating is something you might not want to do on every keystroke. Instead, something you might want to do is that you collect a certain amount of keystrokes, or you simply wait for a pause of a certain time duration after a keystroke, and only if the pause is long enough, you go ahead and do your thing. So for example here, whilst the user is actively typing, I might not want to check if it's a valid email address. I care about when the user stopped typing. So for example here, when I type and then I stop for, let's say, 500 milliseconds or longer, then I want to check, okay, the user seems to be done, let's see if it's valid. That's something we might want to do, and the same for the password. Now that's a technique which is called debouncing. We want to debounce the user input. We want to make sure we're not doing something with it on every keystroke, but once the user made a pause during typing. And with useEffect, that's actually easy to implement. We can use setTimeout, which is a function built into the browser, to wait for example, 500 milliseconds until we execute some function. Now, in this function, we might want to check our form validity, or to update our form validity. Now we would only do this after 500 milliseconds. Now, if I move my console log in here, you will see that this alone doesn't do much. The only result is that we don't see the output immediately, but with a slight delay of 500 milliseconds. Which makes sense because for every keystroke, we're now setting a timer, and after 500 milliseconds we do this. Well, the trick is that we actually save the timer, and for the next keystroke, we clear it, so that we only have one ongoing timer at a time. And only the last timer will therefore complete. And as long as the user keeps on typing, we always clear all other timers. And therefore, we'll only have one timer that completes, and that completes after 500 milliseconds, which is the delay the user has to issue a new keystroke to clear this timer. Now that might sound complex to implement, but useEffect makes that very easy actually. In the useEffect function, so the function you pass as a first argument, you can do something we haven't done before. You can return something. Now the something you return here has to be one specific thing. It needs to be a function itself. So here you can also return a function. For example, an anonymous arrow function. But it could also be a named function, just as for all the places where I'm using anonymous functions. So we are returning this anonymous arrow function here. That's a so-called cleanup function. This will run as a cleanup process before useEffect executes this function the next time. So, to make it clear when this runs, whenever this useEffect function runs, before it runs, except for the very first time when it runs, this cleanup function will run. And in addition, the cleanup function will run whenever the component you're specifying the effect in unmounts from the DOM, so whenever the component is reused. So the cleanup function runs before every new side effect function execution and before the component is removed, and it does not run before the first side effect function execution. But thereafter it will run before every next side effect function execution. So we can simply console log cleanup here to get a feeling for when it runs. If I reload this page, you see checking for validity ran. So this code ran clearly, our main side effect function code, but we don't see the cleanup call. We don't see the cleanup log because of what I said. It does not run before the very first side effect execution. But if I then type here just one character, you see cleanup runs immediately, and then the code inside of this side effect function, inside of this function here, this code here executed. So that's how cleanup runs. It runs before every new side effect function execution. So with this in mind, we can use the fact that setTimeout actually returns a handler, let's say, or actually an identifier for the timer that was set. And we can use this identifier to clear this timer with the built-in clear timeout function, which is built into the browser. So this has nothing to do with effects or with React. This is built into the browser. Now I don't want to run it here. I want to run it in my cleanup function instead. There I call clear timeout and pass the identifier of this timeout to it. And this makes sure that whenever the cleanup function runs, I clear the timer that was set before this cleanup function ran, so in the last side effect function execution, so that when the next side effect execution is due, we are able to set a new timer. So we clear the last timer before we set a new one. That's what's happening here. And again, if the order is not clear to you, have a look at those console log statements, this one, and see in which order they execute. So therefore now if I reload, we see checking for invalidity. And now if I type here, cleanup, and then again checking for invalidity. But now here if I type a lot very quickly, you see a lot of cleanups, but you only see one checking for invalidity. Again, let me show this to you. If I clear this, and now again, if I type quickly, only one checking for invalidity. And that means that this code in here only ran once for all those keystrokes. And that's what I mentioned earlier. If we would be sending an HTTP request here, we would have now only sent once instead of a dozen HTTP requests. And that's an improvement. And of course, also a nice example for this cleanup function and when it matters and how it works. And of course, needless to say that our forum here still works as before, just with a slight delay, which you of course can control. You can lower this number here, fine-tune it to your needs. But this is a great example for the cleanup function and how it works. UseEffect, besides useState, is the most important React hook you have, so you need to understand it. Therefore, I again want to make it clear at which point of time, which part of UseEffect kicks in and executes. And for this again here in the login component, I'll add a new UseEffect call where I only add this first argument. So for the moment, no second argument. And in there, we can log effect running. Now, at the moment, we have no information about the dependencies. We just have this first argument. And this is a valid way of using it, though you will rarely use UseEffect like this. The reason for this is that if I reload, you see it runs when the component first mounts. So when this login component is rendered for the first time. But then also for every state update. For example, if I click in here and click out of there, we see effect running. For every keystroke, we see effect running. So this really now runs for every time this component function reruns. Because you learned this effect function runs after every component render cycle. Not before it and not during it, but after it, including the first time this component was mounted. Now, this changes once we add an empty array. Now, this function here only executes for the first time this component was mounted and rendered, but not thereafter, not for any subsequent re-render cycle. So we see effect running here, but for the keystrokes, we don't see it. Now, if I log in, we also don't see it again. So it really only ran once. Alternatively, we add a dependency like entered email or entered password. Now this function here reruns whenever the component was re-evaluated and this state in this case here changed. So if I now log out and reload, we see effect running for the first time this was mounted. But now for keystrokes in the email, nothing changes. For keystrokes in password, we see effect running though, because the password is a dependency. We also have the cleanup function, which we can return. This cleanup function runs before this state function as a whole runs, but not before the first time it runs. So here I will again log effect cleanup, save this. We see only effect running here for the first render cycle. For the email, nothing happens. That's a different cleanup log. This is coming from our other effect. So effect cleanup did not print yet. But once I start typing in the password, we see effect cleanup being triggered, and it triggers before the effect function runs. Now, if we had an empty array here, so no dependencies, we learned that we only see effect running once, and the cleanup function in this case would run when the component is removed. So in this case, for example, when I log in and the component is removed from the DOM, we see effect cleanup. So that's how useEffect works and how the different parts of it are related and when they execute. Really important to understand this. So if it's not 100% clear at this point, definitely go through those last lectures again to make sure it is clear. Now we just learned about useEffect, which I mentioned would be the most important React hook besides useState. Are you ready for the next React hook, useReducer? Now useReducer is another built-in hook, and it will help us with state management. So it's a bit like useState, but actually with more capabilities and especially useful for more complex state. Because sometimes you have more complex state, for example, multiple states that kind of belong together, that are managing the same thing, just different aspects of it. Or you have multiple states that kind of change together or are related. In such cases, useState and the state you get from there often becomes hard or error-prone to use and manage. And it's easy then to write bad or inefficient or potentially buggy code, which is, of course, never what we want. useReducer is then an alternative to useState, so it's a replacement if you need a more powerful state management. Now, this does not mean that you should always use useReducer, because it's more powerful, so it's always better, right? No, because it's also a bit more complex to use, it requires a bit more setup. So for a lot of scenarios, for the majority, I would argue, you probably use useState. But there are cases where the extra work of getting useReducer to work is just worth it. That's all very abstract. What would be a concrete example? We can again go back to the good old login.js file here. Here, you see, I'm managing a couple of state snapshots, and you might be able to spot some related state here. We manage the entered email and the entered password, but then we also manage the fact or the question, the response to the question, whether the email or the password is valid, and we manage the overall form validity. So you could argue that overall, this is all one big state that describes the overall form state. The inputs are part of that. Or you at least treat every input as one entity and one state, which simply has two aspects: the value the user entered and the validity of that input. And it becomes clear that we have some work to do and some redundancy if we consider the fact that we're setting the overall form validity by checking the validity of email and password when we're doing the exact same thing here for our two validate handlers. Now we could rewrite this in various ways and, for example, use our email is valid and password is valid states here in this useEffect and just use those two states to confirm whether the overall form is valid, and that would work. But nonetheless, we at least have these two states, the entered email in this example and the validity of the email, that clearly kind of belong together and which we therefore might want to manage together. In addition, I want to come back to something which we don't have anymore because we're using useEffect, but what we had before. If I comment out useEffect here, before you might remember that inside of email change handler and password change handler, we had a slightly different code. We had this code here essentially, not just in the email change handler, but also in the password change handler, where we checked the other entered value and the entered value for this handler with event target value, and we would derive the form validity from that. Now, this approach also worked, but we had some code reusage, which is why the effect was a better result. But let's say for whatever reason you don't want to take that route to use effect. In that case, you would have another problem, and I'm just going back to the solution to show you this problem, which you can have in some apps and in some use cases. Here, we are updating some state, the form validity state, based on two other states. Now, what did you learn about updating the state based on some older state? You want to use the function form, right? Now, this doesn't work here, however, because that's only true if your next state update depends on the previous state snapshot of the same state. But here, we depend on two other state snapshots of different state, of the entered email and the entered password, not on the last state snapshot of the form validity. So therefore here actually we're doing something which you normally shouldn't do. Because of the way React schedules state updates, this code here could actually, in rare cases, but it could actually lead to the scenario where this runs before, for example, password state update was processed. So therefore entered password, when this code runs, might not contain the latest entered password, because of how React schedules state updates. That's what I preached before and why I urged you to use the function form. But again, it's not available here because we're depending on two other states and not the last snapshot of this form validity state. This is another scenario where you could use useReducer. So it's a good use case, a good replacement of use state when you have state that belongs together, like here with the entered value and the validity of the value, and or if you have state updates that depend on other state. And actually, we don't even have to go back to this code. We already violate this rule of using the function form if a state update depends on an older state here in our validate email and validate password handlers. There we are calling set email is valid and set password is valid to set new states for this email is valid and password is valid state. These are our two states which we're setting there. Now, how are we setting these states? Well, by having a look at another state and calling a method on it. So we're having a look at the entered email state, which is a different state. This is our entered email state. It's a different state than our email is valid state. Sure, they are related. They both change because of what the user entered. But technically, these are two different states, two different variables. And we are deriving our new email is valid state by looking at another state. And that is something we should not do. It works in most cases, but in some scenarios it could not work because maybe some state update for entered email wasn't processed in time. And then we would try to update email is valid based on some outdated entered email state. So we should use the function form here, but again, just as with set form is valid, we can't, because with the function form of our state updating function here, we only get the latest state for that state which we're setting here. So we would get the latest email is valid state, not the latest entered email state if we use the function form here. So that's why this is not an option. And therefore here we are already violating this rule, which I told you to, well, not violate. And that is a scenario where useReducer is always a good choice. If you update a state which depends on another state, then merging this into one state could be a good idea. And you can do that without useReducer as well. You could simply manage an email state, which is an object with the value and the valid being part of the same object. You could do that with use state. But in such cases, when your state becomes more complex, bigger, and combines multiple related states, use reducer can also be worth a closer look. And that's why we'll dive into it in the next lecture. So with that, we know when we might want to use reducer. How does it work though? It looks like this, and that's quite a bit of code. So let's have a look at this step by step. Use reducer, just like use state, always returns an array with exactly 2 values, and therefore you can use array destructuring, as we did it with use state, to pull out these values and store them in separate constants. Now the 2 values you're getting are the latest state snapshot, because it is a state management mechanism like use state, so of course you get your state snapshot. But you also get a function that allows you to update that state snapshot. So that's kind of the same as for use state, though the state updating function will work differently. Instead of just setting a new state value, you will dispatch an action. And that action will be consumed by the first argument you pass to use reducer, a so-called reducer function. So this is a function which gets the latest state snapshot automatically, because this function will be called by React, and it gets the action that was dispatched, because React will call this reducer function whenever a new action is dispatched. So then it gets the last state snapshot managed by React, and it gets the action that was dispatched that triggered this reducer function execution. Now, the reducer function then also should do one important thing. It should return a new updated state. So it's a bit like the function form of the use state hook, but an extended version of that, you could say, because of that action thing, which you'll see in action, no pun intended, in a second. In addition, you can also set some initial state and also an initial function that should run to set the initial state in case your initial state is a bit more complex and, for example, the result of, let's say, a HTTP request or anything like that. We'll ignore that for now. So that's use reducer in theory. Let's see it in action. Now, I did mention that we could use reducer here to combine our entered values and validities for the email and the password, and that we could also use it to manage the overall form state with it. So we could either manage one big form state that includes everything or multiple smaller states. Both would work, both would be fine, but to keep things simple here, we will simply start by managing our email state with use reducer. And there the goal is to combine the value and the validity into one state managed by use reducer. First of all, we need to import use reducer here. And we then call it, for example, here. And use reducer, as you learned, returns an array with exactly 2 elements, and we can use array destructuring to pull those elements out of it. Now I'm going to use reducer for my email and my password separately. You could also merge this all into one big reducer. And here we therefore get back, let's say, the email state and our dispatch function. I'll name it dispatch email. These names are up to you, of course. Then I mentioned that use reducer as a first argument takes a function. Here again, I'm using an anonymous function, though we actually could also outsource this into a separate named function, maybe to make this easier to read. And I'll name this email reducer. And I'll store my function, my arrow function, in this constant so that I can point at email reducer here. Now please note that I created this reducer function outside of the component function. And I did so because inside of this reducer function, we won't need any data that's generated inside of the component function. So this reducer function can be created outside of the scope of this component function because it doesn't need to interact with anything defined inside of the component function. All the data which will be required and used inside of the reducer function will be passed into this function when it's executed by React automatically. So that's why we can define it outside of the component function here. Now this reducer function receives two arguments, two parameters, our last state snapshot and the action that was dispatched. And you'll see what this action is in just a second. And we should return a new state. Now here our state could be an object where we have the value, which is initially an empty string, and let's say the isValid field, which initially is false, for example. That also could be our initial state here, which is the second argument we pass to useReducer. Value and isValid to false. That's the initial state we set here for our email state snapshot. Now the email state is therefore what we can use in our code. For example here, where I want the entered email. Now that's email state.value, because that's where we're going to store the entered value. We don't have the code for that yet, but soon we will. So that's where we could access this. Also here, email state.value includes add. But actually keep in mind that we have the isValid field in there. And we're going to add code that changes it eventually soon. So instead of revalidating here, we could also just check if email state isValid is true. And therefore we can simplify this here. Email state is valid. And if we scroll down further here in the submit handler, here we want to forward the value. So that would be email state.value. And in the JSX code, of course, instead of email is valid, we have email state is valid. And here, where I pass the value back into the input, we have email state.value. And that should be the different places where I'm using my email states. With that, entered email and email is valid should now be gray because we're not using them anywhere in our code anymore. So we can remove these two use state calls here, and I will comment them out so that we still see this alternative, but we're not using it anymore. But we're not done with the reducer. Right now, it always returns this state, which of course is not what we want. Instead, we need to dispatch an action eventually. We need to dispatch it here, for example, when we want to update the value, or here when we want to update the validity. Now let's start with the value. Here we now update this by calling dispatch email, and we pass to it a so-called action. Now it's totally up to you what this action is. It can be a string identifier, something like new email value. It could be a number, but often it will be an object which has some field that holds some identifier. Often the field is then named type, and that could be something like user input, for example. Now it doesn't have to be all caps, that's just a convention you see a lot. So a string all caps with some clearly understandable identifier. And then we also can add an extra payload to this action. Again, I'm saying you can because it's up to you. But here, since we want to save what the user entered, we of course, it would make sense to add some payload. So for example, a val field that holds the event target value. So now that's our action. It's this object with a type field that describes what happened and extra payload, in this case, the value the user entered. So this now will trigger this function here to execute because that's the reducer function we passed to useReducer. Now here we can handle this action, for example, with an if statement. We can check if action.type is equal to user input. Keep in mind, what we dispatch as an action will be an object because that's what we set it to here. And this object happens to have a type field, so I can check for action.type here and check if the value stored in that type field is that string with the content user input. And if that's the case, we could say, now then I don't want to return this empty state snapshot, Instead, I want to return a state snapshot for my email where the value is action.val. That's the payload we appended to our action. And maybe we also want to update the validity here if we're already added. Simply by, for example, checking if action valid, and then the same logic as down there, includes the @ symbol for this very trivial validation. So here I'm then updating both the value and is valid whenever I receive this user input action. And for any other action that might reach this reducer, this default state will be returned. Now, we also need to dispatch an action here on the validate email handler. So instead of setting the email as valid here, I can dispatch email again pass in an object. You should be consistent. Your actions should always have the same structure so that your code where you, for example, try to access a type property does not suddenly fail. So once you decided for an action structure, you want to stick to it. Therefore, here I again dispatch an object with a type field. Now here it's, for example, input blur, because the input lost focus, it was blurred. And we don't need to add a value here necessarily, because all we care about here is that the input lost focus. There is no extra data that needs to be added. So here we have a simpler action, so still an object, still with a type property, but without a value. The fact that the val is missing does not matter, because this line here, where we try to access the value, will not run for action of type input blur, because we only run this if the action type is user input. Instead, I will check if the action type is input blur, and if it is, I want to return a new snapshot, a new state value for my email state. But now the value, of course, should be the value we had before. I don't want to reset this to be empty because the input could blur after the user entered something. I don't want to lose that. So therefore, I'll use my last state snapshot, which I get here. And this is guaranteed to be the absolute last state snapshot. React gives us this state snapshot and it makes sure that it's the latest one. So here we can safely access state.value, for example, to access the last value that was entered for the email. And for the validity, we can therefore check if state value is valid by again repeating our validity check here. And of course, you could also refactor this check into a function, but I don't want to make this overly complicated. So with this, we now have this extra action. And as a result, if I log out here, you see initially it's blurred, which makes sense actually, because my initial value for is valid is false. If I set this to undefined or to null instead, you'll see it's not treated as invalid. It's not treated as if it was blurred from the beginning on. But if I click in there, it is. And if I then start typing, I'm getting an error. Cannot read property includes of undefined. And what could be causing that? Well, it looks like we're having problems running this code here, because that clearly has to be the action that triggered. And that's simply because here I'm checking action valid. Of course, it should be action val. So the value I'm retrieving here. So a simple typo here, my mistake. Let's reload. Now I can type here, and that all seems to work. And overall, this works as before. Without the debouncing, because I commented out that code, but the general form validation works. Now with the help of useReducer. And this allows us to group this email state together and manage it in one place. It's a little bit more setup up here, but on the other hand, the code in the component then is simpler, because there we only need to dispatch and not do any validation or anything like that. So here's a task for you now. Take this, attach to find the finished code snapshot, and do the same for the password. So, were you successful? Let's do the same for the password. Of course, it should be fairly trivial. We create our password reducer, which is an anonymous function that gets the last state and the action. And yeah, well, we can't just copy this, can we? We can copy this in here. The validation code needs to change because for the password, I'm checking the length. So I want to copy this code down there and use this here and here. The action names can be the same. But now, of course, we also need to call useReducer again here. Now for the password reducer. And what we get back, therefore, is the password state and the dispatch password function. We also want to set an initial state, which can be the same one as here for the email, of course. Just this object with no value and a null is valid state. And now we simply have to update the code accordingly. Set form is valid. Here I'm not interested in the entered password, but instead, now that we do validation in here, I only want to access my password state, and there the is valid prop. And when the password changes, I want to call dispatch password, pass an object where I have the user input type and the val field, which is the event target value. And here, when the password field blurs, I also have dispatch password, and the type is just input blur. And here I'm not caring about the entered password, but the password state and there the value entered by the user. And then we can go down. And for the password field here, we have password state is valid in our check. And we feed back the password state value into the input field. And if I go up, we see we use nothing here. So we can comment out these two use state calls. And with that, again, if we give this a try, this all should work just fine. And it does. Now that wasn't too difficult, hopefully. It's again the same what we did for email reducer. And of course, you might see potential here for using just one reducer function instead of two, because it's almost the same. The validation logic is different though, so that's definitely refactorable, but takes a little bit more work, which is why I'm not going to do it here. But generally, it's not too far off. And in addition, and that's the thing that matters more to me here, the form validity, of course, also is a bit related to the input validity, because the inputs are part of the overall form. So the code we have here is still not optimal, because we still derive the form validity off of our state, which is still not what we want, due to the reasons I explained earlier with React scheduling the state updates. So we might still refer to an old state here that does not change just because the state is coming from a useReducer. Set form is valid, like this still is not optimal. And in addition, having our state that is split like this, even though it technically belongs together, is also not something you might want. Now, whether you want this or not is up to you, but the fact that this is not optimal is a fact. So for this, let's comment this out again, and let's go back to the use effect solution, which actually is a nice solution. So we can go back to this and just update it accordingly. Here we have the email state, and there simply is valid instead of doing validation here. And the same for the password. We have the password state is valid, just like this. And hence here we care about the email state and the password state. And this would now be a fine way of calling set form is valid, because since it's now inside of an effect, we still refer to our state snapshots, but this effect is guaranteed to rerun whenever these states change, and therefore ultimately it will run with the latest state values. So this actually is now an okay way of updating a state based on our state, because with use effect, we're guaranteed that this will run for every state update React performs, which was not the case before, where maybe the code ran too early. useEffect only runs after state updates, so here this is okay. Now still here we have a problem though, which is why I'm showing this to you. This now will run accordingly and correctly, and hence here, indeed, if I enter something here, eventually this unlocks and works. But the problem we'll have here is that this effect runs too often. This will run whenever the email or the password state changed. Now that includes cases where maybe just the value changed, which might not be what we want. We actually only care about the validity here. Now it turns out that we update the validity now whenever the value changes as well. But of course, if, for example, the input was valid already and we then add an extra character to the password, it doesn't really change. It was valid before. With the extra character, it's still valid. So here, for example, if I have a password that is valid, if I add one more character, it's still valid. Nonetheless, our effect re-executed here. Now that's something we might want to avoid, and it re-executes at the moment because our dependency is the entire email and password state, not just the validity part of it, which is actually the part we're interested in. Here we can use a technique which you need to know, which is why I'm showing it to you. We can use object destructuring, so the same as array destructuring, just with objects, to pull out certain properties of objects. For example, from email state, we can extract isValid and store it in a new constant of the same name. And we can do the same for the password state, but since I'm already using isValid in this constant now, we can use a variation of the object destructuring syntax. We can add a colon here, which now won't assign a value because we're not creating an object here. We're using it on the left side of the equal sign. This is simply the syntax for object destructuring. And with the object, we now assign an alias to the extracted value, to the extracted property. So we're pulling out the isValid property, but we're storing it in a constant which actually could be named email isValid. And the same here for the password. We're pulling out the isValid property, but we can store it in, let's say, a password isValid constant. So this is an alias assignment. This is not a value assignment. It's an alias assignment because it's part of this object destructuring syntax, which is the syntax you're automatically using if you're using those curly braces on the left side of the equal sign. And now we have the email and password isValid constants, which we can use here as our dependencies and as our values. Your dependencies should be matched by your values and the other way around. So email is valid and password is valid. Now the advantage is that since now I'm pulling out the isValid state here, whenever just the value changes and the validity did not change, this effect will not rerun. And you can see this. If I enter something here, of course, in the beginning it will run. But once the password is valid, if I type one extra character, you don't see an additional checking for invalidity output. This is especially clear if I clean this. You see, I can type a lot of characters. This never checks again because the validity did not change. Of course, that's not the case if I make it too short. So I wanted to show this because this is an important concept to further optimize useEffect and to avoid unnecessary effect execution. Not just when using it with useReducer, but for example also when doing so. Another use case could be if you have props as a dependency for your effect. You don't want to rerun the effect whenever props change, you only want to do so when some props change, for example. With object destructuring, you can get there. So that's a little step back here to useEffect, but an important one. An equally important concept, of course, was useReducer though. So now that we learned about useReducer, let me again sum up when you should use useState and when it might be an idea to use useReducer. Now, generally, you will know when you need useReducer. That might not be the greatest rule of all times, but you will see when you need useReducer, for example, because using useState becomes too cumbersome, you find yourself dealing with a lot of kind of related state snapshots which still are kind of independent, and you start updating them together in a way that just doesn't work out, then you want to consider using useReducer. Now, to still give you a couple of ideas when to use useState versus useReducer, useState is your main state management tool. Typically, you start with useState, and often it's all you need. It's great for independent pieces of state and data. It's great for simple state, you could say. It's great if state updates are easy and limited to a few kinds of updates. So if you don't have a lot of different cases that will change a state, and especially if you don't have, let's say, an object as a state or anything like that. Now, if you do have an object as a state or a more complex state, useReducer might be interesting because in general, useReducer is great if you need more power. And with more power, I simply mean that you can write such a reducer function that can contain more complex state updating logic, where you always are guaranteed to work with the latest state snapshot, and where you can move that potentially more complex logic out of your component function body into a separate reducer function. So also to restructure code, that might be interesting. You should especially consider useReducer if you're dealing with related data with state that is made up of related pieces of state. So when you, for example, have a scenario as we had it with our form input state. And in general, useReducer can be helpful if you have more complex state updates, if you have different cases, different actions that can change a state, cases like this. Now, there is no hard rule, and there, as always in programming, is no clear wrong or right. You can certainly also handle cases where useReducer would be good with just useState, especially when combining that with useEffect. But sometimes using useReducer just might be more elegant or simpler. On the other hand, you should absolutely not always use useReducer, because often that will be overkill. If you have just a simple state that just switches between two different values, for example, using useReducer might be overkill. And that's it for useReducer. Now, you could absolutely also use useReducer to manage the form state as a whole with useReducer instead of using useState for the form validity. You could replace these two reducers and the form validity with one big reducer that manages the entire form, but that's something I will come back to later in the forms module, since for now, it's just important that you understand useReducer and when to use it. So with useReducer out of the way, let's dive into a different problem you might face in bigger React applications specifically, but even in this tiny demo here, we already have it, that can be solved in a more elegant way. I'm talking about a problem, in quotes, where you are passing a lot of data through a lot of components via props. And a good example here is our isLoggedIn state and the login functions. We're managing this state in the app component because I lifted this state up to that component because we basically need this state, this isLoggedIn state, and the functions to change it everywhere in this application. We use the logged in state in the header, to which I'm passing it through the isAuthenticated prop. From there, we are able to log out. So I pass the pointer at the logout handler to my header on the onLogout prop. And we also need the login state to render different content here, either the login or the home component. And to those components, I also pass the logout handler or the login handler. Now, the logout handler being passed to the home component, that's something I'm doing here so that we theoretically could add a button there with our button component, for example, to allow the user to log out there as well. Not something we need in this app, but something you could add here with props on logout, since we're getting a pointer to this handler anyways. And if you do that once you log in here, You also have the logout button here. So long story short, we use this login state in a lot of different places in the app. Now, obviously, this is a very, very, very simple app, a very simple demo, and here, passing our state around like this is not a huge problem. Now, it is quite common that you pass data to components through props, but it's always a problem if you forward state through multiple components. So if you basically just leverage props to forward data to another component. And that's actually something we're doing in the main header. Here in the app component, I'm passing isLoggedIn through the isAuthenticated prop to main header. And I'm passing the logout handler through the onLogout prop to the main header as well. Now in the main header though, I'm using neither of those two props. I'm using them only to forward them again to the navigation component. Because it's the navigation component in the end which needs the isLoggedIn data to render different links, and which needs the onLogout prop and the logout handler therefore to do something when the logout button is clicked. So essentially what I'm doing here is in the main header, I'm receiving props, I'm receiving data through props, which I'm not actually using primarily in the main header. Instead, I just forward that data. That's not necessarily a problem, but in bigger apps, that chain of forwarding might become longer and longer. Consider this example of a fictional app. We could have an app with an app component, with let's say an off section with a login form, with a shop section where we have a list of products in which we render individual product items, and with a cart. Now in the login form, we might have the login event when the user fills out the form and submits the form, and we validate the data and find out that the user is logged in. And we might need that login data, so that login status, the information that the user is logged in different parts of the app. We might need it in the shop, we might need it in the cart, to show the cart, to avoid that the user can go there if he or she is not logged in. It's easy to imagine that we need information about the login status in different parts of the app. And we have something similar. Let's say the user adds a product to the cart. We need that information in the cart component to show the product there, for example. But since the product is a direct child of products, which is a child of shop, which is a child of app, and since the login event happens in the login form, which is a child of auth, which is a child of app, we don't have those direct connections to the other components where the data might be needed. If a user clicks a button in the product component to add a product to the cart, the information needs to reach the cart component, but there is no direct connection between the product component and the cart component. And the same for the login. And therefore, what we typically would do is we would use props to pass a function handler to the login form, for example, so that in there we can call it. But that essentially means that we're forwarding data through our different components. And the same, of course, if we add something to the cart. Now that means that this function that should be triggered when the user adds something to the cart would probably be managed in the app component, because we lifted the state up to the level where we have access to both the product component indirectly and the cart component. And that's only the case in the app component. Only this component has at least indirect connections to both components, product and cart. And therefore, we would forward a pointer to the add to cart function through all those other components, the shop component and the products component, even though those components probably don't need that function. They only need it so that they can forward it to the product component in the end. So in the end here, we have the same problem I described here, just on a larger scale. Here it's a very simple app, but even here we are forwarding data through the main header to the navigation component on props we receive in the main header, even though we don't really need the data there. So therefore, in bigger apps, you could easily build such prop chains which are used to forward data through components to other components. That's something you can do, and that's not necessarily bad, but the bigger your app gets, the more inconvenient it is to do that. Instead, it would be nicer if we could use props in a component to only receive the data this component really needs from its parent, and not to forward other data through the parent, which the parent does neither manage nor need itself. And for that, we got a component-wide, behind-the-scenes state storage built into React. We have a concept called React Context, and this in the end allows us to, for example, trigger an action in that component-wide state storage, and then directly pass that to the component that is interested without building such a long prop chain. And that allows us to solve our problem in a more elegant way here. So let's take a closer look at this now. So as I mentioned, we have this React Context concept, which allows us to manage state kind of behind the scenes in React, such that we actually are able to directly change it from any component in our app and directly pass it to any component in our app without building such a prop chain. For that, here in my source folder, next to my components folder, I will add a new folder, context, and you don't have to name it context. You could also name it state or store. Often such an app-wide state is also named store, so maybe let's go with that. And in there, I'll add a new file. And since we're going to manage some authentication state, I will add a auth context in there. So hence, I will name the file authcontext.js. The exact naming is up to you though. You could also name it auth context like this, so in this Pascal case notation, but this would imply that we're going to store a component in there, and that's not directly what we're doing. Hence, I'll go for this naming using kebab case. So auth context.js, and I can say right away, you can have multiple contexts for multiple global states in your app. And of course, you can also use just one context for a bigger state. That's all up to you, but let's maybe just learn how context works. So we got the auth context.js file. And in there, we import React from React as if we would build a component, but we're not going to do that. Instead, on React, I'm going to call create context. And this does what the name implies. It creates such a context object in the end. Now, create context takes a default context. And context here really is just your app or component-wide state. So it's up to you what that state should be. It could be something simple like just a string, my state. If your app-wide or component-wide state is just some text, you could have some, well, text as your default state. Often though, it will be an object. It will be an object where you, for example, in our case, manage the isLoggedIn state and set this to false initially, let's say. Now what we get back from create context is something interesting though. It will be a component, or it will be an object that also contains components. Let's put it like this. So we get back auth context, and I'll name it like this because whilst auth context itself is not a component, it is an object that will contain a component. Now we don't need this object here though. Instead we'll need it in the other components. So I'll export it as a default to make it available in other files. So now we can import this specific context object. And to then use context in your app, you need to do two things. You need to provide it, which basically tells React, hey, here's my context. All components that are wrapped by it should have access to it. And I'll come back to that wrapping part in a second. And besides providing, you then need to consume it. You need to hook into it. You need to listen to it, if you want to call it like this. Now, providing is always the first step. Providing means that you wrap in JSX code all the components that should be able to tap into that context, so that should be able to listen to that context. Any component that's not wrapped will not be able to listen. So here, if we know that we need this context everywhere in the entire application, so in all components possibly, we want to wrap everything in app component with it. If we knew that we only needed, let's say, in the login component and its child components, we could only wrap the login component. But here we'll need it in the main header, we'll need it down there, we'll need it everywhere. So therefore, we can wrap our main header and this main section with auth context, and for that we'll need to import it. So make sure you add this import from store auth context to import this auth context object. And I said that this itself wouldn't be a component. In JSX, we need a component though. But with a dot, we can access a property on this auth context object that contains a component. And that's the provider. Auth context provider is a component we can use in our JSX code, and we can wrap it around other components. And those other components and all their descendant components, so all their children and their children's children and so on, all those components will now have access to that context. Now, since we use auth context as a wrapper here, we can now technically also use React fragment because we got this wrapping component as a root level component I return here. And with that, the main header, but also the login and the home component and all their children will have access to auth context. So now we provide this. Now we have the second part, and that is the listening part. To get access to our value, which at the moment is always just this default value, which never changes. We're going to work on that too, of course. But to have access to that value, we need to listen. And we can listen in two ways. We can listen by using auth context consumer or by using a React hook. Now we'll typically use the React hook, but let me show you the other alternative to consumer as well. Let's say here in navigation, we're interested in knowing whether the user is authenticated or not. For that, we can also use auth context there and wrap everything where we need data from it with that consumer. So here, for example, we could wrap the entire component with auth context. Again, make sure to import it, of course. Dot consumer now. Previously, we had the provider. Now we have the consumer. The consumer works a bit differently, though. The consumer takes a child, which actually should be a function between curly braces like this. And as an argument, you'll get your context data. So in our case, you'll get this object here. And then in this function, you should return your JSX code, which should have access to that data. So here I'm grabbing all that nav code, I'm returning that. And in there, I now, for example, have access to ctx.isLoggedIn because my context object is this object here, and there I have the isLoggedIn prop. Now, if you save that, you will, however, see, if you reload, that this crashes. And the reason for that is that we do have a default value here, but this default value will actually only be used if we would consume here without having a provider. So technically the provider is not even needed. However, you should memorize this pattern I explained earlier where you need the provider. Technically, you don't need it if you have a default value, but in reality, you will use context to have a value which can change, and that will only be possible with a provider. So therefore, to make sure that this does not crash, let's go back to the provider, and there on the provider component, you can add a value prop. And this has to be named value because this is not a component by you. And to that, you can also pass your object. So in this case, I will just repeat my default object here. But now you would be able to change that object, for example, through state in the app component. And whenever it changes, the new value will be passed down to all consuming components. But that is something I will also come back to in a second. So here, let me save this. And now it reloads without problems. Now, of course, if I now log in, you will see that we only have one link here. So that first link, the user's link, is missing because there I'm pulling data from my context. And that at the moment is never changing. So let's make sure we can change it before I then show you the alternative to the consumer. Here, changing it is easy. We have set up the provider here in the app component. And there we manage the isLoggedIn state anyways. So instead of hard coding our isLoggedIn value in the value we pass to the provider, we can set it to isLoggedIn, of course. And if we do that, this value object will be updated by React whenever isLoggedIn changed. And that new object, that new context object, will be passed down to all listening components. So to all components where we consume this context. The difference to before is that we don't need to use a prop to forward that, therefore. Instead, we just set it on the provider, and then everywhere in all child components, we can listen to that. So here we could remove the isAuthenticated prop on the main header, and in the main header, therefore, stop forwarding it to the navigation. And in navigation, we could now use context.isLoggedIn everywhere where we need the isLoggedIn information. And that's now where we break up that props chain, where we stop forwarding that data, which we don't need in the main header, and where we instead leverage context. So now if I reload, you see that still works, and now the link is back, but now we're using context here. Now I did mention, however, that the consumer is just one way of consuming our context. It's an okayish way, but I don't like that syntax too much, having that function that then returns our code. You can do that, but there actually is a more elegant way, a more elegant solution using the useContext hook. So let's explore the useContext hook. For that here, I will actually remove this code. I will remove the consumer like this. And therefore I'm back to my old navigation component, but of course now I'm referring to that CTX object which simply doesn't exist anymore. Now we're still importing auth context, and we can use it again now by importing a hook from React, and that's the use context hook. Another hook that's built into React. And it does what the name implies. It allows us to use the context. It allows us to tap into a context and listen to it. Using it is simple. You call useContext in your React component function, and you pass the context, a pointer at the context you want to use, to it. So in our case, I'm pointing to auth context. Now what you get back is the context value. So here, I'll store this in a CTX constant to make my code down there work again. And with that, we can save this, and it will again work just fine, simply because I'm using the use context hook. Easy like that, simple like that. This is all we need to do, and this, of course, I would say is a bit more elegant and a bit nicer than using auth context consumer, which you, however, just to make this clear, are also allowed to use. It's not wrong or anything like that. This is just a bit more elegant, in my opinion. So we're using useContext to pass the isLoggedIn state to my other components here. That's great, but of course you will notice that we're still forwarding the onLogout prop or the logout handler function through props, and that's of course still not ideal. It would be nicer if we could use the main header like this, so without passing any data to it, because we don't need to forward onLogout. But of course at the moment this would not work. This would mean at the moment that we're simply not able to log out because we're not passing our logout handler. So hammering the logout button here in the navigation wouldn't do anything. The good thing is we can set up a dynamic context where we don't just pass data to our components, but also functions, which technically of course also is data, but still you get my point. Here all we need to do is in our auth context provider, where we set up the value, besides passing down isLoggedIn, we can also pass down, let's say, onLogout, where we point at the logout handler. Just like this. If I do that, and make sure you don't execute it, you just want to point at the function. If I do that, then every listening component, every component that listens to auth context will be able to utilize logout handler here, simply through the onLogout context value. So therefore, back in navigation, where we are referring to props onLogout, we can now simply do CTX onLogout. And this will work because on the context object, we now have the onLogout value. So if we save that, now logging out works again. And of course, the rest of the app also works just fine, as you can tell. So this now all works, again, with the help of context, where you can not just pass down values like strings, objects, and so on, but where you can also pass down functions. And therefore, now we're using this app-wide or component-wide context object to manage our state and to manage the function that changes the state. Hence, we don't need props in the navigation component anymore. And we can remove it. And you now have a great example for using context. Now here, in my main section here, I will still pass down the logout handler through onLogout and the login handler through onLogin, because I directly use those handlers in the login and home components. You see, in the login component, we directly refer to props on login. We're not forwarding it, we're using it here. And the same in the home component. I'm directly using onLogout here. Sure, we're technically forwarding it to our own button component, but this is a pure presentational component. And this here is actually fine. I don't want to use context inside of my button to always bind button clicks to onLogout, because whilst this would remove the need to pass onLogout like this, it would also mean that our button is now always logging the user out and not able to do anything else upon a click. And this also shows you when to use props and when to use context. In most cases, you will use props to pass data to components, because props are your mechanism to configure components and to make them reusable. Only if you have something which you would forward through a lot of components and you're forwarding it to a component that does something very specific, like for example the navigation, where this button will always log the user out. In such cases, you want to consider context. And as with everything in programming, with more experience, it will also of course become clearer and more natural when to use what. You can of course always rely on prop chains if you prefer that, but context allows you to write more concise code, and it often makes managing such app-wide state simply a bit easier. Now, a little enhancement to our context. It is a good idea to also add your functions, like onLogout in my case, to the default context when you create the context. And there you can just store a dummy function which does nothing. I'm doing this for better IDE auto-completion, because you will see that if I don't have this here, in the navigation component, here if I try to call onLogout, I'm not getting any suggestion by my IDE. It doesn't know that there is an onLogout prop. On the other hand, you will see that there is this isLoggedIn suggestion. Now that's simply happening because the way React works, and the way Visual Studio Code at least works, it's looking at this default context object to find out what you are able to access on your context. So for better IDE auto-completion, it is a good idea to add onLogout here in your default context object as well, just with a dummy function, because we're not going to use this anyways. And then here, you will see that now I get this onLogout auto-completion. So that's just a tiny hint you might consider, because it can be helpful. Another thing that you might consider is, depending on your application structure and how you're managing your data, you also might want to pull more logic out of, for example, app component and create a separate context management component, if you want to call it like this. How could this look like? Well, maybe in our auth context store file, we could create a auth context provider component now actually, where we return auth context.provider, and we accept props and simply pass whatever we got on props children between our provider. And then here, I don't just export auth context as the default, but I also export my auth context provider in addition to the default as a named export. Now, why am I doing that? Because now we can actually also import use state here inside of the auth context.js file and manage the is logged in state and set is logged in here inside of this auth context provider. Add the logout handler function here where I set is logged in to false, and also add the login handler function here now, so that we manage the entire authentication state in this separate provider component. And here I set is logged in to true, of course. And then I set the value here, of course, to an object where I have is logged in, which is equal to the is logged in state, where I have on logout, which points at the logout handler, and in addition, where we now also have on login, which points at the login handler. And therefore, I will also add this to my default context here, on login, with a dummy function, just making it clear that we there want an email and a password. We're not doing anything with that data, but technically we would need it in a real app. And now we have this standalone file which manages the entire login state in this auth context provider component, and which also sets up all the context. And the advantage here could be, and I'm saying could because this is something you can consider, it always depends on your preferences, the exact use case, and the size of your app, but this is something you could consider because now we can strip that all out of app component. We of course also though need to move over our local storage access here. So clear data in the logout handler, set our data in the login handler, and of course also add our use effect code here. That all now needs to go into our auth context provider, and therefore we also need to import use effect here. But with that all, we can now clear all that logic here from the app component, remove these hook imports here, remove our auth context import here, remove all of that, and therefore, of course, bring back React fragment like this. And I'm doing this because now we can wrap the app component as a whole, so therefore an index component, which is where we render the app component, with auth context provider. So with our auth context provider component, which we just created and exported in the auth context file. And with that, we have one central place for the state management, for the auth state management, I should say. And that central place is now not the app component, but a dedicated context component and a dedicated context file. And this might be a structure you might prefer because it is more focused and gives you a leaner app component, which now is not concerned with app-wide state management, but which now instead can just focus on, well, bringing something onto the screen. Of course, since I'm now using is logged in here, I need to be able to get that information. So now in the app component, we want to use context and pass our auth context, not the provider, but still the auth context object, which is our default export in the auth context file. And therefore, we now got our context here as well, and hence we can access it here. And now we could even remove the on login and on logout props here, because we're not managing the logout and login handlers in app component anyways. And now tap into context in the home and login components. So in the home component, we can now also import use context and get access to our auth context, maybe to mix up the naming and make it clear what's in there, to which context we're listening here, by importing auth context and passing it to use context. Again, use auth context here, not the provider. And then here we can use auth ctx.onLogout and do something similar in the login component. Import use context here And then in our component function, maybe here, we can set up our auth context by calling use context and passing auth context to it. For that, make sure you are importing auth context, of course. And then we can use auth context when we need to log in. So here it's not props on login, but auth ctx on login, to which we forward the email and password. Now, again, this is totally optional. The advantage here could just be that you have a leaner app component, which again is now just focused on returning JSX and bringing something onto the screen. And you have the actual auth state management and auth context management all in one file. And some developers, including myself, often prefer this more focused and separated approach, where you have components where every component has one job essentially and not a ton of jobs. And therefore I'm a fan of this split, but as so often it's not the only way of doing this, and it's also not the only correct way. It's definitely a practice that is worth looking into though, a practice you might see in projects out there, and therefore something that of course needs to go into a course like this, which has the job of turning you into a real React developer. And therefore you have to know patterns like this, which is why we refactored this. With all of that out of the way, let's test our application to ensure that this still works. And that all seems to work to me here. Let's also check the logout button here. Yeah, that all works now with one central context, with one central state management. So React context is great. Let's use it for everything. Well, not quite. For one, keep in mind what I mentioned earlier. It can be great for app-wide or component-wide state, so essentially state that affects multiple components. It's not a replacement for component configuration. Consider our button here in the UI folder. The button should be reusable. Sure, we could use context to make sure that upon a click we always log the user out. But that would mean that we can't use the button for anything else than logging users out. And that might not be what you want. For example, in this application, we are using the same button component in the login component to log the user in and trigger the form submission, as well as we're using it in the home component to log the user out. So that is a scenario where using context in the button component would be bad. You want to use props here to configure the button. So props for configuration, context for state management across components or possibly across the entire app. But even then, we have limitations. React context is specifically not optimized for high frequency changes. So that means, for example, if you have state changes every second or multiple times per second, this is clearly not the case in our example here. For authentication, that does not change that often. It changes once every few minutes in reality, maybe not even that. So that is a perfect use case for context. But if you had state changes that happen much more frequently, again, talking about multiple changes per second and so on, then React context is not optimized for that. And you don't have to take this from me. This is actually something that was stated by an official React team member. So it's not great for high frequency changes. Now you might wonder, okay, but what if I have app-wide or component-wide state that changes often? I would want to use context for that. Props might not be ideal, and you're telling me that it's bad. We'll explore a better tool for that later, no worries. It will be called Redux, and I'll have a whole section on it. And as I mentioned, it should not be used to replace all component communications and props. Props are still vital and important for component configuration. So you should still use props for that and not use context for everything. For replacing long prop chains, it might, however, be worth a look. So now in this module, we learned a lot of important new concepts, and we learned about new React hooks. Specifically, we can see it here in the login component. We knew about use state before, but now we also learned about use effect, use reducer, and also use context. So there are a bunch of React hooks. There are even more hooks than that, but we'll get there step by step. Now that we have all those hooks, it is important that we also learn about some rules for using them. We always followed those rules thus far, because of course I'm not teaching you incorrect patterns, but I think it's now also time to give you a formal definition which you can print out, put on your wall, and make sure you don't violate them. You find this slide attached therefore. Side note, all slides are always attached to the last lecture of each module. Anyways, there are two main rules you have to know when it comes to working with React hooks. And React hooks are simply all those functions that start with use. So use effect, use reducer, and so on. The first rule, which is important, is that you must only call React hooks in React functions. That means in React component functions, as we did it thus far, or also allowed in custom hooks. That's not something we explored yet, but of course that will also be included in this course. Just as the name suggests, it's a bit more complex and therefore a bit more advanced, and something we'll therefore dive in later. These are the two scenarios where you are allowed to use React hooks. And what does this mean? Well, to give you a concrete example, here in the login component, we for example have the email reducer function. This is a function next to the login function. The login function here, however, is my component function for the login component. And it identifies itself as such a function because it returns JSX in the end. That is what makes up a component function. Email reducer does not do that. It returns an object. It's not a React component, and therefore calling use state in here is not allowed. And the good thing is, a modern React setup with a good IDE like Visual Studio Code will even tell you about that. You see it down there. React hook use state is called in function email reducer, which is neither a React function component or a custom React hook function. So exactly what I stated on the slide. You're only allowed to use hooks in React function components or in custom hooks. Email reducer is neither of that, and hence we get an error. So you should get an error if you try to do that, should get a warning, and here is also your technical rule: don't do it. The second important rule is that you must only call React hooks at the top level of your React component functions or your custom hook functions. Don't call hooks in nested functions. Don't call them in any block statements. So again, to give you an example, here in the login component, so now inside of the functional component, we of course, for example, have our useEffect function here. So the function which we pass to useEffect. You're not allowed to call use context or use state or any other hook in there. Again, you will see I get a warning here. React hook use context cannot be called inside a callback. React hooks must be called in a React function component or a custom React hook function, and it needs to be called directly on the top level there. So calling it here is okay, because that's the top level of this login function, but in a nested function is not allowed. And that's not just true for nested functions, it would also not be allowed in an if statement. Calling use state in there, also not allowed. So again, a very simple rule, not too hard to follow. Only call React hooks at the top level. Now these are the two official rules of hooks. There is a third rule which I want to add here, not directly related to all hooks, but to one specific hook. And that's the useEffect hook. There, make sure that you always add everything you refer to inside of useEffect as a dependency, unless there is a good reason not to do that, I should add. And to make it clear what I mean, let's again go to login component. In here, we use useEffect to execute this function, and in there, we use nothing from the surrounding component. We use console log, but that's baked into the browser. I'm not talking about browser API things. I'm talking about data exposed by the surrounding function. And here we're not using any data, hence we have no dependencies. It's a different thing for this useEffect here though. There we have this function, and in there we're using setTimeout, which is a browser API. You don't need to add those. But we are using email is valid and password is valid. And that's data from the surrounding component. That's part of the surrounding component's state. And if it would be part of the surrounding component's props, the same would be true. So what I'm now saying would be true in that case as well. Such dependencies or such values need to be added as dependencies. Technically, we should therefore also add setForm is valid, because that's not a browser API. But this is one exception to that rule actually. The state updating functions exposed by useReducer or by useState are guaranteed by React to never change, and therefore you don't need to add them as dependencies, because if they never change, well, it's a redundant dependency. You could add it though. Wouldn't be wrong, wouldn't be horrible. You could add it and it would work in the same way. You are just allowed to omit it. And actually, you don't need to memorize all of that if you think, well, that's too much. No worries. If I remove a dependency here, in a modern setup, you should get a warning here that React hook useEffect has a missing dependency. Either include it or remove the dependency array. So, you are warned here as well, and I just want to explain this warning and why you are getting it. There are some exceptions, like the state updating functions, but all the other data, which is not coming from the browser or from outside your component function, so all the data that is from inside your component function in which you are using useEffect needs to go into the dependency array. That's my third rule here. And with that, you are well prepared to use hooks and to build amazing apps. Now let's continue on that road. Now there is one last hook, not in general, there are more hooks, but there is one last hook which I want to dive in right now because it fits really well into this section here, into this module. For that, we'll first of all have to change our code a little bit though. We'll create a new component, an input component, that contains our input divs and that receives all the data it needs through props. So that, just like the button, it's reusable, because we will indeed reuse it for the email and the password input. Now, feel free to try to create such an input component on your own and use it here in this login form. That's a little mini assignment, a little mini task you can dive in. Here's a short pause for you to pause the video, and thereafter we'll do that together, and thereafter we'll see which hook I'm talking about. So, were you successful? Let's do it together. For that, in the UI folder, I'll add an input folder with an input.js file, and in there from React, I import React because we're going to create a component in there. The input component which gets props and which we export here, just like this. Now, the JSX that should be returned here, as I mentioned, should be that div here. So I'll grab that div from the email, cut it from the login component, and add it here as a return value. And therefore, I'll also add an input.module.css file to bring over all the styles I want. So I'll import classes from ./input.module.css, and of course also migrate the respective styles. Here in the login module, I'm basically talking about all those control styles here. They are all related except for the actions. So actually I'll cut everything in front of actions because actions is part of the login component. Bring the control part into the input module CSS file though, and that of course then also includes this media query. Bring that over as well. And with that we got the styles migrated. Now back in the input component, we now got some data we need to get from outside. To make this reusable, I of course don't want to focus on just the email state here. Instead, I'm just interested in whether this input is valid or not. So I expect to get just a isValid prop on my props object here to then add this invalid class or not. This text here should be settable from outside, let's say on a label prop. This ID here should be settable from outside. So I will expect this on an ID prop. This type here should be settable from outside. The value should be settable from outside. And here the change and the blur handlers as well. So here I'll have on change, and here I'll have on blur. And this should be a quite reusable input component. And we can now use this here in the login component where we previously had that div. So there I'll add the input component. Of course, for that, make sure you do import it. You do import your input component here from the newly created input file. And now we need to configure that component. So for example, we need to pass our ID, email, our label, which was email like this, our type, which is email, and also the is valid prop, which is the email is valid constant, which we essentially have up here, pulling it out from the email state. That's something we want to forward. And of course, we also need the value prop that needs to be set on our email state value, and also on change and on blur. So on change here is our email change handler, and on blur is our validate email handler. And with that, we have our email input. Now we also, of course, need to migrate the password. So here we're going to replace this div with this input, but now for password, the label text should be password, the password and the type should be password. Here we have password is valid, we have the password state value, we got the password change handler, and we got the validate password handler here. So with that, we should have the same behavior as before, and we do, that works. But now we have the separate components here. Now that's a nice practice, and that's always good. And it's also a good example for when we want to use props versus context. We absolutely want props here because those input components, as you can see, should be reusable. And therefore we use props so that we can configure them from inside the parent where we are using them. If we would use context inside of the input, every input would do the same thing. It would be bound to the same context. It might be less reusable then. But that wasn't the main focus. This instead just now allows me to move on to the next hook, which I want to show you. The next hook I want to show you allows us to interact with the input components imperatively, which means not by passing some state to it that then changes something in the component, but by calling a function inside of a component, for example, which is something you won't need to do often and you shouldn't do often because it's not the typical React pattern you want, but sometimes it is helpful. Now it will become clearer what I mean in a second. First of all, let's remove this disabled prop from the button. I don't want to disable the button. It should always be clickable now. Second, in the submit handler, since the button is now always clickable, I want to check if the form is valid. And only if it is, I will call on login. Otherwise, and that's now the interesting part, I want to basically focus the first invalid input I find. So here it's now always submittable. And if I click on login, I now want to make sure that we actually focus the first input that is invalid. So in this case, that we put the cursor into the email input here. That's something you might want. So for that, I'll actually turn this into an else if statement and check if the form is valid because the email is not valid, hence the exclamation mark at the beginning. Or else, if the email should be valid, it has to be the password that is invalid, then we'll go into this block. Of course, both could be invalid, but again, I want to focus the first one, which is invalid, and the first input we have that could be invalid is the email. Hence, I'm checking this first. But now the goal is to focus the input. And for a regular input, that would be possible by putting a ref on it, we learned about refs already in this course with the useRef hook. And then we could call the focus method. Just to show this to you, here in the input component, where we have the native input, the raw input HTML component, we could use the useRef hook here to create an input ref like this. And then, for example, if we would want to focus this after the component was rendered, we could use effect to run some code after the component was rendered. You learned that the function you pass to useEffect runs after every component render cycle. Let's say we only want to run it once when the component initially renders, hence I pass an empty array as a dependency array, so that this only runs after the first time this component was executed and rendered. And then here, we could focus the input by adding the ref prop to the input. The ref prop is supported on all built-in HTML components, like input, for example. Point at input ref, and in useEffect, we could now use input_ref.current.focus. And the focus method is a method that is available on the input DOM object to which we got access through this ref. So here we're just using refs. As you learned them earlier in the course already, we connected our ref to the input, and then we use useEffect to focus this input after this component rendered. And as a result, since the input will render for both the email and the password, this will focus the password input, because that's the second and therefore last input that's being rendered. Hence, if this reloads, you see the first one is marked as invalid because it was temporarily focused, but then the password is the input that stays focused at the end. Now, that's not the behavior we want, but that's something we can do with references and the built-in functionalities we have in React and simply in vanilla JavaScript. Focus is a method that's not coming from React, but that's built into JavaScript, built into the DOM objects, the input DOM object specifically you're dealing with. Now again, my goal is not to do that after the input is rendered though, so we can remove useEffect. My goal is that I, for example, have my own method here in the input component. Let's say it's called activate. You could also call it focus, of course. And in there, I want to use the input ref, current, and focus my input. But now the goal is that activate is a function that's not called from inside the input, but from outside. Now I'll say it again, this is a rare scenario because typically you don't want to code your React projects like this. Instead, you want to work with props and state and pass data down to a component to then change something there. But in rare cases, like in this example, it might also be an elegant way of, well, focusing this input here, if you could call focus or activate on your input component, so that you essentially can use your input component as you can use the built-in one, because there you have a focus method as well, right? So maybe you want one, or in our case, an activate function on your own input component as well. So a rare use case, but you could face it at some point. Now, of course, you could think, well, that shouldn't be too hard. We go to the login component, where we have our inputs, and we simply use useRef here as well. useRef, like this. Import the useRef hook. And then in your login component, you create your email input ref, for example, by calling useRef. And you create your password input ref by calling useRef. useRef. So that you have two references, one for the email and one for the password input. And then we simply go down and we add the ref prop here on the first input and point at the email input ref. And for the password, we also add ref and point at the password input ref. Could be as easy as that. Now, therefore, we have a reference to our own components now. One reference to our input component for the email and one reference to the input component for the password. And therefore, in the submit handler, if the email is valid, we can is invalid. Excuse me. If the email is invalid, we can use the email input ref, current, and call activate, which is that function we have in our input. And we do the same basically in the else block, but for the password input ref. Right? This is something you might want to do. Well, if we try this, it will not work though. If I save this, you already see an error here. Function components cannot be given refs. So this will not work. We can't use a ref here. This is not possible. And our component, the input component, of course, also doesn't really do anything with a ref prop internally. It doesn't accept a ref prop on its props object. We're not using props.ref anywhere in there. But even if we do, ref is also kind of a reserved word. And yeah, we're getting this warning here for a reason. So this is not an approach that works like this. However, we can make it work. We just need to do two things. For one, in the input component, we need to import another hook, and that's the use imperative handle hook. Has a strange name, but in the end, it is a hook that allows us to use this component or functionalities from inside this component imperatively, which simply means not through the regular state props management, not by controlling the component through state in the parent component, but instead by directly calling or manipulating something in the component programmatically. And again, that is something you rarely want to use, and therefore you shouldn't use it very often in your projects as well. You want to find an alternative. Nonetheless, here it actually is a pretty nice solution for this problem. And all we need to do is we need to call use imperative handle here and pass two things to it. Let's start with the second thing before I talk about the first parameter. The second parameter is a function that should return an object. And that object will contain all the data you will be able to use from outside. So for example, here we could add an activate field or a focus field, totally up to you, and then point at the internal function or the internal variable or whatever it is that should be accessible from outside through that name. For example, here, point at activate. And again, this doesn't have to be focus, this can be activate or anything else as well. I'm just using different names here to make it clear that this activate refers to this function, and that is the externally available name then. So this is basically a translation object between internal functionalities and the outside world, so the parent component. Now this alone doesn't do the trick though. We also have this first argument which we need to provide to use imperative handle. And that's actually something we also get here in our component function argument list. Thus far, we always just worked with props, and in 99.9% of cases, that is all you will need. However, there technically also is a second argument you can accept, and that's a ref. Now that's interesting. That is a ref if a ref should be set from outside. We'll also need something else to make sure that this can be set, but this is then available. So if now the parent component, the login component, adds the ref prop and binds this to something, essentially this here will establish the connection. This will be part of allowing this binding. And it's this ref which we should pass to use imperative handle. Now we're still not there yet. This alone would not work. In order to enable this second argument here, we need to export our component function in a special way. We need to wrap it with something special. And that's coming from React, and it's called forward ref. And that is basically a function which we execute, a method which we execute, to which we pass our component function. So our component function is now the first argument to forward ref. And forward ref returns a React component, so input still is a React component, but a React component that is capable of being bound to a ref. Now since I wrap forward ref here, I of course also need a closing bracket here. And now with that, input is able to take a ref prop, and it will expose a ref, and it is controllable or usable with refs. But the only thing you will be able to use is what you expose here through use imperative handle. So for example, here I'm exposing this focus function, a function because it points at the activate function. So now in the login component, we can call email input ref.current.focus because that's the external name we set up. And with that, we can save this. And if I now click login, you see the email is selected, the first invalid input. If I enter something valid here and I click login, you see the password is now selected because it's invalid. The same here. If I click out of it, but it's invalid, it is selected. And I can, of course, also still log in if everything is valid. So that is a niche use case, but especially for something like focusing inputs and so on, this can be very useful. So this is a very realistic use case, which I'm showing to you here. With use imperative handle and forward ref, you can expose functionalities from a React component to its parent component to then use your component in the parent component through refs and trigger certain functionalities. That is something you can do, and that does not just work for functions. We could also expose the value here through refs if we wanted to. So that is something you can do, not something you will need all the time, and you should avoid it at all cost, I would almost say. But especially in cases like this with focusing, but also in some other use cases like with scrolling and so on, this can be very useful. And then triggering something like this programmatically is fine. And with use imperative handle and forward ref, you are able to make it work. Over the last course sections, the learning curve got a bit steeper, and we had a look at more advanced yet crucial React concepts, especially, of course, when we had a look at React hooks like use effect, use context, and also use reducer. Therefore, before we dive deeper into React, this course section is there for you to practice what you learned together with me by building another course project, the food order app. Now, of course, we have demos in all course sections, but this is another slightly bigger application where all the key things you learned throughout the last course sections again come together and can be seen in the context of a bigger project. And of course, we're not just going to have a look at those concepts covered in the last section, but we will again see all core React features in action, including components, state, and much more. Now, this is the application we are going to build. It's a simple dummy food order app where we got a list of meals from which we can choose, and we can then add these meals to the cart, also change their amounts and also add them multiple times. And of course, we can also view the cart to see what's in the cart here. We can also change our cart from that page if we want to. And ultimately, we can, of course, also click order, though for the moment, that won't do anything. Instead, it will just add a little output here in the console, but we will, of course, also have a closer look at how we can store that in a database or do other things with that later in the course. But for the moment, this application is there to practice all those key features we had a look at over the last course sections. Now, if you feel like it, you can of course also try this on your own. Attached to this lecture, you find all the CSS files I plan to use throughout this section, and these file names also give you an idea of which components I plan to use, but this is totally optional. It is a nice practice, but it will also be a big challenge. Therefore, it might definitely be worth a try, but we can also simply walk through all of that together to again practice all these key concepts step by step together to make sure that after this course section, everything we learned up to this point is super clear. So let's get started building this project together now. For this, attached you find this basic starting project here, which is just again an empty React application pretty much. And you can download this attachment, extract it, place it anywhere on your system where you want to work on it, run npm install in the extracted folder to install all dependencies. and then npm start to bring up that development server. And if you do all of that, what you'll see on the screen is just something like this, because we're going to build this project together from the ground up. And that, of course, means that we'll build many components and that we'll practice many things which we learned early in the course already, because components and passing data between components and managing state and all of that, of course, are crucial core fundamentals of React. So we will need those in any project we build. But then, throughout this course section, we're also going to apply all these other hooks we had a look at, like useEffect. So that's the plan for this module. Now, to get started with this application here, we will need a bunch of components. And if you remember the finished app which I showed you before, if you have a look at that, there of course are quite a few components that can be identified, like that list of meals, or the header at the top, or the card, but also a couple of wrapper components like this general modal component, this overlay component, or this container our meals are in. We also got this image below the header, so there are quite a bit of components involved. Now, to get started here, I will again add a components folder, of course, and in that components folder, I will add 4 subfolders, which is just a personal decision made by me, and I'll explain it along the way. One subfolder is the UI subfolder. I want to place general UI elements, general UI components in that folder. For example, I will have an input component in there, where the user can enter the amount in this application. I will have a card component in there, which will be this container around my meals, for example. And I plan to place the modal component in that folder. So some general UI components which are not tied to a specific feature of this application, but which instead could be used in multiple places in any project. I will also add another folder side by side to the UI folder, and that will be the layout folder. Now, in that folder, I plan to add my header component, basically, and also another component which will be related to that header. Another folder which I will add side by side to layout and UI is the meals folder. That is the folder which will hold that list of meals, but also the individual meal item components. And then the last folder for the last set of components I plan to build is the card folder, which will hold all the card related components. So that is just the structure I came up with here. Of course, it's not the only correct structure. Of course, you can go for a different structure and store your components the way you want and write the components you want to write. This is just my suggestion because I think that this is a nice split to split our components between features, meals and cart, and also have some general UI components and some general layout components. Now, of course, we're going to populate these folders step by step throughout this module. I want to start with the header for now, so with this toolbar at the top. And therefore, in the layout folder here, I will add a header.js file. And that will hold my header code. The header will also need some styling, so side by side to header.js, I will add a header.module CSS file. .module because I will use the built-in CSS modules support which modern React projects created with Create React App, which this setup is in the end, provide. So this CSS file will be needed. And speaking of that file, you find this header.module CSS file attached to this lecture, and you can simply replace yours with it or simply copy in all the provided styles, which are some styles I came up with to give this header the look you saw in the preview at the beginning of this module. Of course, you can also write your own styles if you prefer that. Now, in the header.js file, we want to have the JSX structure for our header. And therefore here I will export a header component function where we get some props. And of course, we'll also, export this function to make it available outside of this file, because I will use it in a different file. And inside of this component function, I don't need complex logic or state or anything like that. Instead, there I will just return the JSX code for this header. And here I actually want to have two blocks of code. One block of code will be the header itself, so that toolbar. The second part will be the image below the header. Though we could also split that into two separate components if we wanted to. Here I will keep it in one component, but again, that is definitely a split you could also make. Have two components instead of one. Now here I will use a React fragment, so that built-in fragment component, and therefore I want to import React from React so that I can access React fragment. Alternatively, we of course just import fragment and use that directly as a component like this. And I'm using this fragment component as a wrapper because we must only have one root element returned here. That's true for any place where you use JSX. You must only have one root element. And in there, I actually want to have two sibling elements. A header, using the built-in header component, and then a div, which will hold the image. And again, that would be the two components you could also separate into separate component files and functions. Here, I'll keep it in one component though. Now, inside of the header here, which is a default HTML5 element, I'll have a H1 element where I'll say React Meals, which is just the name of this application I came up with. Of course, you can choose any name you want. And then, side by side to that, I want to have a button which will open the cart later. So for the moment, I'll just add a button with the name of cart like this. I will change this code in a couple of seconds or minutes though. Before we change that button though, let's have a look at that div. And in that div, I want to have an image. So the built-in image element. And here I'm providing an image to you, which you find attached as well. And I will add an assets folder in the source directory, so next to components, where this image will actually be stored in. So attached you find that meals JPEG file, and I will just copy that into that assets folder. This is an image which is provided locally as part of the React application. Now, how can we use that image here in this JSX file? Well, we can use this image in a way which could look strange when you first see it, but which is very easy to use once you're used to it. You can simply import images, and it's a bit like importing CSS files. It's not really a JavaScript feature, but instead, imports like that, so importing CSS files or importing images, is supported by this project setup which we're using here. And behind the scenes, the import is simply transformed to include the image in the finished application, which we could deploy to a server, and to generate a link to that image, which is then dynamically inserted in the generated code. So there's a lot of behind the scenes magic going on here. For us, we simply import meals image, though this name is up to you, from going up, assets, meals JPEG. And here the file extension matters, just as for CSS files, because this tells that build process that this is not a JavaScript file, but in this case an image file, and that it therefore should be transformed and injected appropriately behind the scenes. And then we can use this imported image as a source here by binding the source dynamically with curly braces and pointing at meals image. This is how you can include a local image. Of course, if this would be an image on some server and you simply had a URL to that image, you could just add that URL to some image. To some image.jpg. You could add that if you had such a URL. But here, since it's a local image, part of the project, we instead use that other approach. Now we can also add an alt text, a table full of delicious food, something like this. And with that, I got the general structure for this header component finished. Though there are things missing. For example, the styling. Here on the header component, on the header element, I want to add a class name. And since we added this CSS file, which uses CSS modules, we import classes from that module.css file, so from header module.css. And here, as a class name for the header, we should point at classes.header. Because in that CSS file, if you have a look at it, there is a header CSS class defined. And as you learned in the styling section, this is how you use CSS modules then. Now on that div, which holds the image, I'll also add a class name. And here, it's classes main image written like this. Since it's a CSS class with a dash inside of it, we can't use the dot notation. And that's simply another CSS class defined in there. Now with that, the general header structure is finished. With that, we can now go to app.js, to our root component, and there we can import header from /components layout header like this. And then instead of this h2 tag here, I will use my header. And actually, I also don't want that div here anymore. Instead, here for the moment, I will just use a fragment, which I of course need to import from React. The React import itself is missing here because, as you learned, you can omit that in modern React projects like this one. You can always add it as well, though. You can always also import React from React, and it won't hurt either. Technically, it's required because of what JSX is transformed to behind the scenes, but in some project setups like this one, you can simply omit it. And with that, if you saved it, you should have that header here. And this is a good start. This is now our toolbar. Of course, the cart button in the header doesn't look at all like the button you saw in the preview, though. And therefore, that's what we're going to work on next. So let's work on this button in the header. And we could add all the JSX code in here. I will create a separate component for this, though. Again, you could do the same for the image here, by the way, but I will leave the image in here actually, since that's not a lot of JSX code. But I will create a separate component for the header cart button. So header cart button.js is my file name here. And we could create that component in the header.js file as well, since we're only going to use it in that file. But I want to keep that file lean and not bloated. Therefore, I will follow this common convention of creating a separate file. We will also need some styling, and for this attached you find a header cart button.module.css file, which you can simply copy into your layout folder. And this includes some styles for this button. And then in the JS file for the header cart button, I will add my header cart button function, my component function, which receives props. And of course, also export it like this. And then let's work on the JSX code for the button. For this here, I want to return a button, of course. And inside of that button, I now want to have an icon, then some text, and then a little badge with the current number of items in the cart. Therefore, I will add 3 spans in there. The first one will wrap the icon, the second one the text, and the third one the badge. And when it comes to this icon, I also got a finished component for you, which you can use. And that's the cart icon.js file, which you could add to the layout folder, because that's where we use it, so this would make sense. but which you can also add to the card folder because, of course, it is an icon specifically for the card. And whilst in this application, we will only use it in the header card button, you could be using it in other parts of the app as well, and therefore you might want to store it in the feature folder, in the card folder, instead of the layout folder. But that is totally up to you. Either way, this attached card icon.js file simply holds an SVG icon and not much more, and you can use that to, well, render this card icon. So therefore here, back in the header card button.js file, I simply want to import card icon from, going up one level, card icon. So I import it as a regular component because it is a regular functional component. And then here, in this span, I will add card icon like this as a self-closing component. So it's a regular React component, even though it holds SVG. Because that is something you can do in React. You can use SVG code in your JSX code as well. Now, in the second span, I will have a text of your card. And in the third span, I want to output the total amount of items in the card. And for the moment, we don't have the logic for counting this yet. So therefore here, for the moment, I will just hard code it. Let's say 3 as a dummy value. Now we will need some styles. So therefore here, I will import classes from the header card button module.css file. And then on the button itself, we can add a class which should be classes.button. Then on that span with the icon, I will add a class of classes.icon. And of course, these again, button, icon, and so on, these again are just predefined CSS classes in that CSS file. And for the badge, we therefore add classes.badge. If we do that, we can now use this header card button in the header.js file. Here, I want to replace this button with it. So therefore, I will simply import header card button from /header card button like this. And then here, simply add header card button. And now if you save everything, you should have a button that looks like this in your header. If it doesn't look like this, definitely download and compare my code snapshot because, well, this is all just JSX and CSS working together right now. So you should definitely have an output like this. The button, of course, doesn't do anything yet, but that is something we will add throughout this module. But for the moment, we therefore are done with that header. We added this header, it's finished now, and now we can work on the next parts of this application. So what's next? Of course, this is generally up to you, but here I want to continue with the meals, because of course that is a rather important part of this application. And for that, in the meals folder, I'll add a meals.js file. And this will be responsible for, in the end, rendering that meals list. Though actually not just the list of meals, but also this little summary text above it. And therefore, I will actually add two other components here, which split these responsibilities. I will add a meals summary.js file, which will render this text above the list of meals. And I'll render an available meals component, which will then be responsible for bringing the actual list of meals to the screen. Now let's maybe start with the meals summary component. For that, you attached find a CSS file, meals summary.module.css. And in the meals summary component file, in the JS file, as always, we just export a component. Now this will be a very simple component because it will just contain some hard-coded JSX code. It doesn't even need to accept the props parameter because we will not be using props here at any time. And here I just want to return a section, let's say, where we have a h2 tag where we say delicious food delivered to you, and then a couple of paragraph texts with some text below it. Now, to save you the extra typing, attached you find that meals summary JS file finished, and there you got these paragraphs already added, and you also got a class name added, and therefore here I need to add the import again. You already have that in the attached file, where I import mealsummary.module.css like this, and then add this summary class here, like this. Now again, you find this finished meal summary JS file attached because it is a very simple file. More interesting, of course, is the available meals file. Here we can have the available meals function. We also don't need props here actually, because I won't receive any props here. Instead, here in this application, we will work with some dummy meals data, which is baked into this component. That's of course a bit unrealistic, but we will later in the course learn how we could fetch data from a database. At the moment we don't know it yet, and therefore we will work with such dummy data. Speaking of that, attached you find the dummy meals JS file, and that includes a simple constant which you should add in this file above the available meals component function, which is this dummy meals constant, which holds an array of dummy meals. Again, that is that dummy data we're going to work with in this demo application. Now with that added here in the available meals component, we want to render this array of meals, which we of course could have fetched from some database or anything like that in reality. We want to render this as JSX. And therefore we will need to transform this regular array of JavaScript objects to an array of JSX elements. And that is something you of course learned throughout the course. That is something you can do easily with React. So here we want to return some JSX code, let's say with a section inside of it. And then inside of this section, I want to have an unordered list. And inside of this unordered list, I want to have my meals list. And therefore we can add curly braces and then refer to dummy meals and map them into an array of JSX elements. Now we can do this here, and we did do this here in the JSX code in the past. But to keep this return statement lean, I will actually create a helper constant here, which I'll name meals list, which simply stores that mapped dummy meals list here, so that down there I just output meals list. That's exactly the same as if I would be doing it down there. It just ensures that this JSX snippet is a bit leaner. And it's totally up to you if you wanna do this transformation here and store it in a constant which you use down there, or if you do the transformation inline in your JSX block. Either way, we will simply map all these meals by passing a function to map, which is executed for every meal by JavaScript. And then for every meal, we want to return a JSX element which represents this meal item. And that should be some list item, of course. Though I can already say for the moment, we can simply output meal.name here, like this, but that's just temporary. We will soon create a separate component for the meal item. But for the moment, we can leave it like this and finish this first draft of the available meals component by adding some styling. Now for this, again, attached you find the available meals.module.css file with some predefined CSS code. And in the available meals.js file at the very top, you simply import classes from available meals.module.css. And then on this section, we can add a class name of classes.meals. And now with that, we can go back to the meals component, which should now group the meals summary and available meals together. So here, the meals component will again also be very simple. It won't need any props either. Here, we just want to import the two other components. So the meals summary from meals summary like this, and import available meals from available meals like this, and then return both side by side. And since I want to return two elements side by side, you know that this is not possible in JSX. We must only have one root JSX element. And therefore, again, I will use the fragment. So we should import fragment from React as a wrapper component around meals summary as a self-closing component and available meals as a self-closing component. And now with that, we can go to the app.js file, and here below the header, I will add a main HTML element, which is a default built-in HTML5 element. And inside of that main element, I will add my meals. So I will import meals from components, meals, importing the meals JavaScript file in the meals folder, and then simply render this here as a self-closing component. And if you save that, you should see something like this. Now the summary already looks good. Of course, the list of meals doesn't, but here we are also just getting started. Now, as a next step, I want to wrap this entire list here, this unordered list, into a card component. So into a container with rounded corners and a white background and so on. And every list item itself should also become a separate component, which also outputs more data and in a nicer way. Now that's what we're going to do in the next lecture. Of course, as always, feel free to not proceed right away, but try this on your own first. Even if it then looks different than what we're going to build in the next lecture, this is a great practice you can and you maybe should do before you proceed, and we do it together next. So as I mentioned, I now want to add a card component and then work on the meal items. Now I will start with the card. And for that, in the UI folder, I will add a card.js file. Attached, you also find a card.module.css file with some styling for that card. And this will be a super simple component. It will just be a wrapper component, which provides some HTML structure and some CSS code for any content you want. And therefore, this is a component which could be used in very different places throughout the application, which is why this is such a general UI component. It wants some props because we will need to access props children to get access to the wrapped content. And of course, we export it here. We will also need some styles, so we can import classes from card.module.css already. And now in here, I want to have a very simple markup. We'll just return a div here, which then wraps props children, so that whatever is passed between the opening and closing tag of the card component is in the end used inside of card. And on that div, we can then add a class of classes.card using that CSS class I defined here. And that's it already. With that back in the available meals component here, I want to use that card to wrap this unordered list. So here, we can import, and we should import card from going up one level, UI card, like that, to make that component available in this file. And with that imported, we can simply wrap our unordered list with card. And if we do that and save everything, this already looks much nicer. Now, of course, the meal items don't have the final look I want to have. And therefore, I will add a new component in the meals folder, But to make sure that we don't have too many components sitting side by side here, I will actually add a subfolder, meal item. Now, if you add a subfolder or not also comes down to your personal preferences. I'm doing it here, again, to group all the components that will be dealing with rendering a single meal item together. Because it turns out that I will actually build 2 components for rendering 1 meal item. And you will see which components these are in just a second. So in the meal item folder, which is in the meals folder, I will add a meal item JS file. And attached, of course, unsurprisingly, you find a meal item.module.css file with some styling. And then here we can create our meal item component, which receives some props. So our component function. And of course, export it. And now let's work on the markup for these meal items. For that, I will return a list item. That's the wrapper around every meal item, which semantically makes sense because all these meal items will be rendered in an unordered list. So having li elements makes a lot of sense. But inside of that li element, I then want to have 2 divs side by side. And in the first div, we'll have a h3 tag where I want to output the name of that meal. And I expect to get that name through props, because we are rendering these meal items for all the meals in the dummy meals array. So therefore, here in the meal item component, I will now access props.name. Of course, on which prop you expect to get that name is up to you. You could also name this props.title or .n or whatever you want. It's your component, so it's up to you which props, which attributes, you could say, should later be set on that component. You just need to make sure that whatever names you're using here to access the data are the prop names you later use in available meals for passing down the data. So here I will go for props name, and I will reformat this. And below that h3 tag, I'll add a div where I want to output the description. And I'll therefore access a description prop here. Again, the prop names are up to you. And another div with the price. However, here, I actually don't want to access props price like this, but instead I will add a little constant here before we return, which I'll name price. And this constant will simply format the price a little bit. For this, I'll use a template literal and output a $sign, and then use this special syntax with $sign curly braces. So we got 2 $signs here, one simply to output the character $sign, and one in combination with the curly braces to inject dynamic content into this template literal. And the dynamic content I want to inject is props.price.toFixed2. And this will simply make sure that we always render 2 decimal places. And then it's this price constant, which I'll output here in this div. Simply to output this formatted price with 2 decimal places and a $sign in front of it. And then here in this second div, I want to render a simple form which allows users to enter the amount you want to use here, the amount of meals you want to add to the cart, and then the add to cart button. And that's this extra component which I'm going to add. A component which holds this form to not have all this form markup and logic in this component. So therefore here I will already add a meal item form.js file, and we'll work on that in a second as well. Before we do that though, let's work on the styling for the meal item. And therefore, since we already added the CSS file, I will import classes from mealitem.module.css. And now here on the list item, we can add a class name of classes.meal. On the div here for the description, I will add a class name of classes.description. And on the price, it's class name classes.price. And that's the meal item finished now. Now, before we work on the form, we can already use the meal item in the available meals component. There at the top, we just need to import meal item from /meal item to dive into that meal item folder, and then again meal item to access the meal item file in that folder. And then here, where we map our dummy meals, we now can map them to a meal item instead of a list item. So meal item like this as a self-closing component. And there we now should add a key. We should have added this before as well with the list item, but it was just temporary. But now we should definitely add it and access meal.id here, because every dummy meal has an ID. And I will also pass in the name prop, because in meal item, I am accessing the name. I'm also accessing description and price. And therefore, I will pass in the name with meal.name, the description with meal.description, and the price with meal.price. And I'll reformat this to make this easier to read. Now, if you preferred that, you could also pass in the overall meal instead of these separate props. And inside of meal item, you would then have to access props.meal.description and so on. I'm not doing this here, but this is an alternative you could definitely go for. But I will go for the separate props here. And with that saved, we should have something like this already. Now let's work on the form, which should appear here on the right, for adding them to the cart. So let's work on that meal item form now, which allows us to add items to the cart. For this, we already added the meal item form.js file here in the meal item folder, but of course it's empty right now. We will also need some styling, so again, attached you find a meal item.module.css file so that we don't have to write the styles manually here. Now, in the meal item form.js file, we of course want to create our meal item form component function, and this will receive some props here. And we of course export this function here. Now we can also already import the style classes with import classes from meal item form.module.css, and then start with the JSX markup for this component. Now here I want to render a form element, and in there we want to have an input like this, and we want to have a button. So therefore here we can add both. Now for this input, I will actually wrap that into a separate component so that we have a reusable input which we could use in other parts of an application as well. I'll do this as a second step though. As a first step, let's finish the button. For that, I'll simply say add on it, because that button will add it to the cart. Maybe add a plus in front of add as well. And of course, add a class on the overall form with class name and set this equal to classes.form, like this. Now we can go to the meal item JS file and import that meal item form component, meal item form, from meal item form like this, and output it here between the div. Now, if we save this, we have something like this, which is not the final look, but which is a start. Now, for the final look, as I said, I want to extract that input into a reusable pre-styled input component, which could be used in multiple parts of the application. Again, just as with the card and a lot of these examples here, not because this here would be a super huge application, but because these are realistic scenarios in bigger applications you might be working on, that you want to have these reusable, pre-styled utility components like inputs or maybe also buttons and so on, which you use in a lot of different places of your application. And therefore in the UI folder, I will add an input.js file, which will be responsible for rendering that input. And therefore attached, you also find the input.module.css file with styling for that input. Now in there, I will, of course, again, create my component function as we did it multiple times already. And of course, we'll import these classes, import classes from input.module.css. And then here, we can return the markup for this input. And in this case, I want to have a div here with a class name of classes.input for the styling. And then there, a label with some text for the input, and then the input itself. Now you could definitely write this in a lot of different ways, maybe even letting the user of this component decide whether you want an input or a select or a text area here. But to keep things simple here, we'll just always render an input. Now, of course, the label text should be configurable, and therefore the text output here is props.label. Though, of course, it's totally up to you which prop name you're expecting this name on. I will also set the HTML4 prop here to set the for attribute, like class. You don't set class or for, but in the case of class, it's class name in JSX. In the case of for, it's HTML4, because both class and for are reserved keywords in JavaScript. And here I will then point at props and then input.id. Again, this is my component, so I can decide which kind of props I expect and which structure these props should have. And I simply expect here that for this input component, when it's getting used, I get a label prop with the label text and an input prop, which then itself holds an object with configuration data for the input, like for example the ID, which we therefore then also add as the ID prop here on the input. So props.input.id. In addition, I will now use a nice little trick to pass all other configuration data I might have gotten for this input to this input element here as props. I add curly braces here, just like this, and then use the spread operator to spread props.input. This ensures that all the key value pairs in this input object, which we receive on props input, are added as props to input. So if input object here is an object that, for example, has type text, so if that is what we get on props input, for example, then this code here would make sure that type equals text is being added. This is how that works when you use the spread operator on an element like this. It's simply a convenient way of making this input highly configurable from outside this component through this input prop here. And of course, therefore, we can even get rid of this ID if we want to, and simply expect that this ID is part of this input prop as well, which we already do expect here, and then therefore also add it automatically through this syntax as a prop to this input element. Now, and with that added, we can, of course, go back to the meal item form component and there import input from going up, UI, input. And then replacing this input here with input as a self-closing tag. And there I will now add the label prop, because I'm expecting a label prop here with some text inside of it, with a label of amount. And then the input prop, which now itself should hold an object. So here the value is an object like this, hence the double curly braces. It's no special syntax. Instead, we have one pair of curly braces to evaluate a JavaScript expression, which is passed in as a value. and then that expression just happens to be a JavaScript object. Hence, we have that other pair of curly braces. And in that object, I want to have an ID, which is amount, let's say, a type, which is number, and this is one of the built-in input element types. And I'll add some validation props as well, which are all props you can add by default to the input element. And that would be the min prop with 1 and the max prop with 5, to make sure that the amount that can be added has to be at least 1, but is not bigger than 5. I'll add the step prop, which is also supported on the input element, and set this to 1. And also provide a default value of 1, so that this is the initial value with which this input is populated. And again, these are all default props which you can add to any input element. So these are not props which we need to interpret and handle. Instead, we just distribute them onto the input through this syntax, and then they automatically start making sense because these are all built-in props for input elements. And if we now save that, this is what we got. And that looks, of course, very, very nice. Now, with that, we built a lot of components. And we still got the card component to build, but thereafter, we are finally ready to also start working on the logic of this application and to add context to manage the card, for example. But of course, building all these components, that is the meat of basically any React application you are going to build. And therefore, I'm walking through that process again with you because you need to know how you can build components, how you can use components. That is super crucial and therefore an important practice. And with that, let's build that card modal, and thereafter, let's finally wire everything up and add more logic to this application. So let's work on the card. And therefore, of course, we can go to the card folder and add a card.js file for the card component. Now, the card component should render all the card items and, of course, display the total amount, and then also give us buttons for leaving the card and for ordering. Though, for this application, as shown in the preview, ordering won't really be a thing. Therefore, here we can add our card component function, expect props, and export it like this. And attached, you find a card module.css file with some styling for this card. Hence, we can already import classes from card.module.css and then return the markup for the card. Now here, as I said, in this application, I want to render this card in a modal. Now we're going to build this modal in a second though. You can also try this on your own, also by using React portals, which is a feature we learned about. But before we are going to do it together, I want to finish the general card markup. So I'll have a div here, which will later be the modal component. And inside of that div, or inside of that modal then, I want to render my card items here. And then below that, a div with the total amount. And below that, a div with the actions for the card. So the close and the order button. Now for the card items, I again will add a little helper constant here, card items, where I want to map all card items to card item JSX elements. Now, at the moment, we of course have no card items here. So I will start with a dummy array, which I create inline here, which will hold a card item, let's say with an ID of C1, with a name of sushi, with an amount of 2 maybe, and a price of $12.99. And for the moment, that's it. And we then map this array of objects, which here is just an example. Later, we will get a real object managed through React context. But we will map that item here to a card item component, which we also don't have yet. So for the moment, I'll just output a list item where I output item.name. And then it's these card items which are rendered here. Card items, like this. And actually, I want to wrap this in an unordered list. So I will overall set card items equal to an unordered list. Then an opening curly brace around this JavaScript expression, closing curly brace, and then closing unordered list item. And I can also already add a class name on that unordered list and set this to classes card items written like this because of the dash. And that's the card items which are being output down there. Now, speaking of down there, in that first div here then, I want to have a span where I say total amount, and then below that another span where the actual amount is being output. And for the moment, I'll just hardcode 35.62 here, but this is something which will of course be derived dynamically later. On that div, I will add a class name of classes.total. And then we got that other div with the buttons. This will receive a class name of classes.actions. And then in there, I want to have two buttons. The first button says close. And I will add a class name here of classes, and then it's button -- alt, and because of the dashes, again, I'm using this syntax of accessing that property. And then below that, I have another button where I say order, and this will receive a class name of classes.button. Now later, we will only render the order button when we have items in the cart, but since we're working with dummy data only at the moment, we don't need to worry about this right now. Okay, so that's the cart. Now, as I said, the cart should not be inside of that div though, but inside of a modal. So therefore, let's add such a modal wrapper, which renders this cart as an overlay next. Of course, try it on your own first if you want to, and thereafter we're going to do that together. So let's work on that modal. For that, in the UI folder, I'll add a modal.js file, and attached, unsurprisingly, you find the styling file for this modal, the modal module CSS file. And then here we have that modal, which will receive props. And of course, we export this component like this. And then here we can also import classes from /modal.module.css and then work on the markup for this modal. And here I will have a special markup, kind of, because I want to use React Portal for both my backdrop, so that thing behind the modal overlay, which blocks interaction with the rest of the page, and I also want to render the modal overlay itself with React Portal to use that component wherever I want, but render the actual HTML elements in a specific place in the DOM tree. That is something you learned about earlier in the course, portals. And to render a portal, we first of all need to go to the public folder, and there the index.html file. And here we got this root div where the overall React application is being rendered. And above that root div, I will add another div with an ID of overlays. And that is the div where I want to portal my modal and the backdrop to. So that is a change we need to make to index.html. And with that back in the modal.js file, we can create the backdrop and the overlay and then use the portal. Now I will create two separate components for that, and since they are really closely tied to this modal component and both very lean, I will create them here in the same file, but if you go for separate files, that of course would also be fine. But I will add the backdrop component function here in this file, and then also the modal overlay component function. And both receive props because both will receive data. Now, for the backdrop, we return a div with a class name of classes.backdrop using that backdrop CSS class, which is defined in the modal module CSS file. And for the overlay, I will return a div with a class name of classes.modal. And inside of that, I'll have another div with a class name of classes.content. I simply have these two divs for styling purposes. And then inside of that inner div, I'll output props children. So in the end, this will be the actual content passed between the modal opening and closing tags by the component where the modal is getting used. It won't work right now, but it will work in the future. So now we got these components. Now, here in the modal function, which is the main component which is being exported here, we now, of course, also need to return some markup. And there I want to have backdrop and overlay side by side. And for this, we'll need the fragment. So I'll import fragment from React and then simply return fragment. And in there now, backdrop and modal overlay. And this is how we could do it, or actually modal overlay like this to forward the content between the modal tags. But this is how we could do it if we would not be using a portal. Now, we technically don't have to use a portal, but to ensure that our HTML code is not all over the place in the final application, I will use portals here. And therefore, I will output two dynamic expressions here side by side, and I will call the createPortal method, which is built into React in both these expressions. For that, we need to import it, and it is actually imported, or it is available on the React DOM object from React-DOM. So not the React library itself, but the React DOM library, which of course also is by the React team though. And with this import added, therefore, we can access React DOM, create portal, and create a portal for the backdrop, and do the same down there. React DOM, create portal for the modal overlay. And here we need to pass props children between the opening and closing tags so that in the modal overlay that can be used. Now, createPortal needs a second argument though. It does not just need to know what to portal, but also where to portal it. And therefore we should select this div here with the ID overlays in our index.html file. Now, since we will need that in both createPortal calls, I will create a helper constant here, which I'll name portal element. Obviously, the name is up to you. And here we can access document get element by ID overlays to get access to that overlays div. And then it's this portal element, which I pass as a second argument to both createPortal calls. And that's now the finished code for that modal, at least for now. And with that code, we can go back to the cart component and there replace that wrapping div with modal. Like this. Obviously, for that, we need to import the modal component first, though. So import modal from going up one level, UI modal, not from the CSS file, though, but from the JS file. And then we can use modal as our opening and closing tag. And to see this in action now, we need to use that cart component somewhere. And I will use it in the app.js file. So here I will now import cart from /components cart, and then the cart.js file like this. And then maybe above the header, the exact position doesn't matter too much since we use a modal with a portal anyways. But here I will then add cart. Not cart, but cart. Like this. And if we save this, we should have this cart modal here. Now, at the moment, it's always there, and we can't make it disappear. But that is something we're going to add next. Because, of course, it shouldn't always be there. It should be there when your cart button is clicked. And, of course, it should also be closable. And that is definitely also something you can try implementing on your own. But of course, we're going to do it together in the next lecture. So how can we now ensure that the card is only showing up when the Your Card button is clicked and can be removed if we click on the backdrop or the close button? Well, we need to manage some state because we have different states now. One state where the card is visible and one state where it's not visible. These are two states, and whenever you have more than one state, you need to manage that state with React. And in function components, as we have it here, we use useState for that. So we import useState from React in the app.js file. Why in this file? Because that is where we do render the card. So that is where I want to manage the visibility of the card. Of course, we could also do it in some parent component and pass down the state data through props, but the only parent component to the app component is index, and that's not even a component, that's just where we initially render it, and therefore we actually have no parent component. And even if we would have, it makes a lot of sense to manage it here. So inside of the app function, I will use destructuring to pull out the two elements I get back from calling useState. My initial state is false because that is my card is shown state, and we also have a setCardIsShown function. And here we are just using useState as you learned it throughout this course, registering it with React so that React can manage this state for us for this component, and then getting access to the latest state snapshot whenever this component is re-evaluated, and getting access to this function, which allows us to update the state. And then here we can add a couple of functions to that functions. Functions which should be called when this button is clicked, for example, or when the backdrop is clicked. Because I'm talking about a showCardHandler function, which is a function defined here inside of the app function, in which I then call setCardIsShown and set this to true. And then I'll also add a hideCardHandler function like this, where I set cardIsShown to false. And now we just need to use that cardIsShown state and make sure that these two functions, which I just added, are getting called. Now let's start with using the cardIsShown state. In the end, we want to render the card component conditionally. And you learned how that works. You can simply wrap this in curly braces to evaluate a dynamic expression, and then access cardIsShown and use that shortcut with double ampersand operator to render card if this is truthy and not render it if this is falsy. And with that, the card disappears because initially it's false. Now showCardHandler should be called whenever this button is clicked. This button, however, is part of my header. So therefore, we should probably expect to get that function, that showCardHandler function called from inside the header. And for the header, to call this function, we need to pass a pointer at the function down through props. That's also a pattern you learn about throughout this course. Now it's up to you how you name that prop, but the convention for these props which hold functions is to start with on, since these are kind of like custom events which trigger this function if you look at it like this. And therefore here I'll name it onShowCard. Again, name is up to you. And I point at the showCardHandler. Important, don't execute it here, just point at it so that it can be executed from inside the header through that onShowCard prop. So inside that header component, we now want to execute that function, and we want to execute it whenever this header card button is being clicked. Now, this of course is another custom component, and therefore here, let's say we expect that we have an onClick prop, Again, this is up to you. I'm just using this name, which looks like the built-in onClick, because I in the end want to react to the button being clicked. But technically, you can use any name you want here, because you will have to write code inside of header card button to handle this prop anyways. But to this prop, I want to pass a pointer to that function I'm receiving on props on show card here. So in the header component, we receive the on show card prop, which points at show card handler. And now I'm forwarding that pointer at that function to the onClick prop on the header card button. And now in the header card button, we therefore need to handle that onClick prop, which we receive. Here on that built-in button, there is a built-in onClick prop. So here the name is not up to you. And I now want to point at props onClick, so that the function I receive on onClick in the header card button is forwarded to the onClick prop on the button. This can be confusing, but in the end, we're just passing down a pointer at this show card handler button to that header card button. Now, you learned that if you have a prop chain like this, where you pass a prop through multiple levels of components, could be replaced with context. And indeed, we could use context here for handling this card visibility state. I will not do it here though, because I think here it is okay to have these two levels of components through which I'm passing props. But you could implement context here as well if you wanted to. We are going to use context in this demo application as well, but not for this card button. Here I will instead go for this prop drilling, so for this chain of props. With that, however, if you save everything, if you click your card, it should open up. Now, to make it closable, we want to make sure that both that close button as well as a click on the backdrop closes the card. So therefore, in app.js, where we use the card component, we should probably expect a onClose prop, or something like this. As always, the name is up to you, to which we pass the hide card handler. And now it's inside of that card component where we need to handle this onClose prop. For one, I want to go to that close button and there add a onClick prop and point at props.onClose. OnClose because that's the name I just chose in the app.js file. It's the onClose prop on which we receive the hide card handler, and therefore it's this function which I now want to forward to the button, so that upon a click on the button, that hide card handler function is being called. Now that's one way of closing the modal. It should also be closed if the backdrop is clicked. And to make that happen, we should go to the modal component, and on the backdrop there, we should add an onClick prop to the div. So using that built-in onClick prop, which exists on basically all HTML elements. And there, forward the value we expect to get on whatever prop you want. So here, let's say I expect to get an onClose prop. Now here, when we use the backdrop, we need to set that onClose prop because we just added it inside of the backdrop. And here I expect to get another onClose prop, but now on the modal component itself. So again, here I'll be passing a value through multiple levels down to the backdrop. You could use context, but I also want to highlight that if you are using context and you always bind a click on the backdrop to closing the card, then you would make this backdrop very specific and you would not be able to use the modal for other kinds of content because clicking the backdrop would always close the card. So if you had other content in modals as well, then you would be too specific. So here, using multiple levels of props could even be better because in this case, it makes the modal more reusable and doesn't tie it to one specific use case. That's just a side note why here I think using props instead of context is good, even though we are passing data, or to be precise, a function, through multiple levels of components in this case. And therefore now, in the card component, on modal, we can add the onClose prop as well, and forward props onClose. And that's now the onClose prop for the card component, which is being set in the app component. And that is then this hideCardHandler function. With that, we can open the card, click on the backdrop to close it, or click on the close button to close it. So that's working. And with that, we implemented the card, at least with some dummy data here. It's not finished at all at the moment though. As a next step, I want to make sure that we can really add card items, and then we'll also refine the card overall, and so on. So let's now make sure that data can be added, or items can be added to the card. And for that, I want to use context. I want to manage the overall card data through context because we will need it in different places of the application. On the meal items, we need to update the card, and in the card component, we need to output it, of course. And we also will need to manage it in the future because inside of that card, later, the card items can also be added or removed again. So therefore, let's start by setting up that card context. And for this, I'll add a store folder side by side to the components and the assets folder. The name is up to you, but since we are going to store our application-wide state here, store is kind of a convention in React world as a name for this application-wide state management. And in there, I'll add a card-context.js file. The naming of this file is up to you though. In here, I will import React from React because we can then call React create context. And I will initialize this context with some default data, which will not actually be used, but which will give us better auto-completion later. And here we'll have an items array, since we are going to manage a couple of card items. We'll have a total amount, which is 0, let's say initially. And then we'll have two functions which allow us to update that context. And that's the add item function, which let's say receives the item that should be added. And it's the remove item function, which receives, let's say, an ID to identify the item which should be removed from the card. Like this. Now I'll store this in a card context constant, and I will export this card context here. So that's step number 1. Now we got this context generally created. But now we will also need to manage that context in some component with useState or useReducer, as you saw it earlier in this course, so that this context can also change over time and can update parts of the application over time. And we could do this in the same file here, but I will create a new file for this and name it cardProvider.js. Because in here, I want to add a card provider component, which receives props, and of course, which I export. And the goal of this component is simply to manage the card context data and provide that context to all components that want access to it. And for that here, I will import card context from /card-context, and then return JSX code, because this is a component, where I simply access card context.provider. And now we can simply pass props.children between card context provider, and this allows us to wrap any components that should get access to this context with this card provider component. And we can also add all the logic for managing the context data to this component so that all about that is contained in one component and no other component needs to deal with that. Now for that, I will add a card context helper constant in this component function. And that is simply an object with items, total amount, so all the fields we set up for the context itself. This will be the concrete context value though, which will also be updated over time. And this also holds pointers for the add item function and for the remove item function. And we can already add these functions here and add a add item to card handler here, where we get the item and then do something with it in the future. And the remove item from card handler function, where we get the ID and do something with it in the future. And now it's simply pointers at these functions which are stored as values for add item and remove item in this card context object. And it's now this card context object here, which is set as a value or as a value for the value prop on the card context provider component here. And again, this will be dynamic soon. It's not right now, but it will be dynamic soon. And with that added, we can now use this card provider component to wrap all components that need access to the card. And in our application, that's actually all the components which are rendered in the app component. The card, of course, needs access to render the card items and also to edit them later. The header needs access to update this badge in the header button. This badge where we output the number of card items. So the header also needs access to the card. And the meals need access to the card because there we want to add items to the card. So therefore, we can replace this fragment here with card provider as a wrapping component. And of course, we should now also import card provider from the store folder and then the card provider file. And we can remove the fragment import. Now we could manage that entire context also in the app.js file therefore, since we need it in all the components there. But by using a separate card provider component, we keep the app component lean and don't have to put all the card management logic in there. Simply imagine that you're working on a bigger application with different app-wide states. Let's say you have a product state and a card state and a user state and anything like that. If you would manage all of that in the app component, it would become super large. So having dedicated store components which manage that makes a lot of sense. Now with that, we provide that context to all these components. Now we can leverage it. For example, in the header card button, there we needed to update the appropriate amount of card items in that batch. And hence what we can do is we can use the context in there. So therefore, definitely try using that context on your own. In the next lecture, we're going to do it together. So let's start using our context. For this, in this function component, we use the useContextReact hook from React, as you learned, and we use it here in the header card button for a start. Now we will also need to import the context itself. So we need to import card context, not the card provider, but the card context object from going up, store card context. We don't need the provider component, but really the context itself. And then we can call useContext and pass this card context to it. To get access to this card context, which is managed by the closest provider, which is this card provider used in the app component, inside of the header card button. We simply can store this access, this object, this context object, in a card CTX constant, but this name is up to you, of course. Now, by using use context here, the header card button component will be re-evaluated by React whenever the context changes. And it of course changes when we do update it in the card provider component. So now we established this connection. And we can now use this to output our number of card items. For this, we can add another constant here. Number of card items sounds like a descriptive name. And here we want to get access to card context dot items. And you could now think that you simply use the length of that array to get the number of card items. This could work depending on how you write your card logic, but I don't want to add every item as a new entry in that list. Instead, if we add, let's say, 3 pieces of sushi, I want to add 1 item to the card items array, but set the amount for that item to 3. So then the length would be wrong because it's just 1 item in the card items array, but there are actually 3 meals inside of it. Simply because inside of our card items array, we'll have objects where for every kind of meal, we store the amount of meals of that type is part of the card. So therefore, the proper way to derive that number of items is to access card items, so card context.items, but then use the reduce method on that. Reduce is a built-in method. In the end, it is a method which allows us to transform an array of data into a single value, into a single number in this case. For that, it takes 2 arguments. The first argument is a function, which will be called for you. The second argument is a starting value, and you'll see why it's a starting value in a second. Here we use 0. This function, which is passed in as a first argument, then receives 2 arguments itself, automatically by JavaScript, which is calling that function for every item in that array on which you're calling reduce. That's the current number, however you want to name it, and then the item at which it's currently having a look. And current number will be different for every item it's calling it. Item will also be different, but this is basically a number, a value, which is carried on across executions. Initially it's 0, but then after the first time this function has been executed, it will be the result which you returned in that previous execution. And here I want to return current number plus item.amount, because my card items objects will have an amount field which stores the number of items per item type. And this will now reduce this array to a single number, and it's this number of card items which will be output down there. Now if we save this, we see 0 here in our or on our card button. Therefore, as a next step, let's make sure we can actually add card items. For adding card items, we need to go to the card provider, because that's where we manage our card data in the end. And here we get this add item to cart handler. Now, whenever this function is called, we get the item that should be added to the cart. And then I basically want to check if that item is already part of the cart. So if we, for example, already have sushi in the cart, and if that's the case, I want to update the existing item. If it's not the case, I want to add a new item. And of course, we want to manage this as state in this component, so that this component, and therefore the context, and therefore any components affected by that context, are re-evaluated whenever the cart data changes. So here we want to import use state or use reducer. Both are React hooks which allow us to manage state. And I will go for use reducer here because this will be a bit of a more complex state which we're managing here. because we'll have to check whether a meal is already part of the cart or not. And for removing, we'll also have more complex logic. Hence, I will use reducer for managing the state here. And therefore, as a next step, outside of this component function, I'll add my cart reducer function. Outside of the component function, because this reducer function won't need anything from that component. It won't need any surrounding data defined in this component. And it shouldn't be recreated all the time when the component is re-evaluated. Now you learned that in the reducer functions, you receive a state object and an action automatically by React. The action is dispatched by you later in your code, and the state is simply the last state snapshot of the state managed by the reducer. And then, as part of the reducer function, you have to return a new state snapshot. Now for this, I'll define another constant outside of the component function and outside of the reducer function, and that's my default cart state. Now that's simply an object where I say that I have no items, so an empty array, and a total amount of 0, therefore. And then it's this default cart state which I return here in cart reducer. Now with that, in cart provider, at the very top of this component function, we can call use reducer, this React hook which we're importing. And now as a first argument, we point at our reducer function here. We don't execute it, we just point at it. It will be executed by React for us then. And we set an initial state, and that's the default cart state. So I'm reusing that constant here. Now you learned that use reducer returns an array with exactly 2 elements. Hence we can use array destructuring to pull these elements out of that array and store them in separate constants. The first array element is always your state snapshot. So I will name it cart state here. The second element is this function which allows you to dispatch an action to the reducer. So I will name it dispatch cart action. Both names are up to you because it's the position which matters here in array destructuring. Now the cart state is now needed to construct this cart context object. Instead of hard coding the empty array here, I will access cart state.items, because we're now managing the items with state, and the total amount with cart state.totalamount. Now we can start dispatching actions. And I want to start with adding items to the cart. Here we can then dispatch a cart action. And as I explained when I introduced the use reducer hook earlier in the course, it's totally up to you what an action is. It could just be a number or a text, but typically it's an object which has some property which allows you to identify that action inside of your reducer function. So that in that reducer function, you can run different pieces of code depending on which action type was dispatched. And I will use type as a property name for identifying the action, but it's totally up to you how you name this. You could also name it identifier or whatever you want. But I will go with type and then follow this convention of having a string all caps identifier. Again, it's also just a convention, but a very readable and common one, which is why I will stick to it. And then here we have, let's say, a type of add. It could also be add item or add card item or whatever you want, but I'll keep it simple and short and just use add. Now to add the item in the reducer function, I also want to forward the item as part of the action. So I will add a second property to this action object and name it item. This name is also up to you, and point at my item argument here, so that I'm forwarding the item, which I expect to get here on this function, to my reducer. And now we can go to the cart reducer and start adding logic for adding a cart item here. For this, I first of all want to add a if check and check if the action type is equal to add, because I only want to run this adding logic for this kind of action. At the moment, it is the only action type we have, but later we'll also have a remove action. If we want to, we can already dispatch this here, by the way. We can already add type remove here and forward the ID, let's say, like this in the remove item from cart handler. Now we would have, theoretically at least, two kinds of actions which trigger this reducer, and therefore we want to check for which type of action it was triggered. And now in here, I want to update my cart items. We could simply add our item as a new item in that array, but as I mentioned, I want to group items for the same meal together and manage the amount on a per meal basis. I also want to update the total amount, the total price, for all aggregated cart items. Now let's start simply and simply add an item as a, item to the array though. And for this, we can simply create an array, maybe name it updated items, and set this equal to state items, so the items in the current state snapshot, which we get as a first argument in the reducer by React, and call concat. Concat is a built-in method in JavaScript which adds a new item to an array, but unlike push, it doesn't edit the existing array, but return a new array. And that's kind of important. You want to update your state in an immutable way, which simply means you don't want to edit your old state snapshot because of the reference value thing in JavaScript. That would mean that existing data in memory gets edited without React knowing about it. But instead, you want to generate a brand new state object, which you return. And concat gives us a brand new array instead of editing the old array in memory, which is better. And we want to concat this item, this action item to be precise, which we're getting. And I simply expect to have all the data I need on that action item. So the name, the amounts of items that should be added, the price. I expect to have all of that on the item which reaches this add item to cart handler. Currently, we're not taking care about this yet in the other parts of the application, but we will do so in the future. Now, with that, we got the updated items. I also want to get my new total amount, or my updated total amount. And that should simply be the old total amount on the old state snapshot, plus, action.item.price times action.item.amount. So I expect to have an amount field on that item which we're getting, and a price field. And of course, if we multiply these two, we know by how much our total amount needs to change. And with that, we can return our new state. At the moment, I'm not checking whether our item is already part of the array, by the way. That's something we'll add in the future. For the moment, I will simply return a new state snapshot where I set items equal to updated items and total amount equal to updated total amount. And now we got this basic cart reducer finished. Now we need to make sure as a next step that add item to cart handler is being called from some components in our application, like the meals component, where we have all these meal items and the meal item form, with the appropriate data. So with an amount field on every item, with a price field on every item, with a name field on every item, with an ID field on every item. That's what I want to work on next. So let's now make sure that this add item to cart handler is being called. And for that, we need to go to the place where we want to call add item on our context object. And that's in our meal item form in the end. There, we of course want to handle the form submission, so when this button is clicked. And when the form is submitted, we in the end want to, well, add that item to the cart, because that's what this form is there for. So as a first step in the meal item form component, we can add our submit handler function, where we get the event object, which is sent as an argument automatically when we call this function upon a built-in event. And I want to call this function, or I want to have that function called for the onSubmit event, or the submit event on that form here. So here I point at the submit handler. Now you learned that here we should call event prevent default to make sure that that browser default of reloading the page is prevented. And then I want to extract the entered amount. Now I want to use refs for that. The alternative would be two-way binding by managing some state, but I want to use refs. Now the thing is that here I actually have a separate component, a custom component. Normally we can use refs by importing useRef from React. And then we create a ref and we assign that with the ref property or with the ref prop to an element. Generally, we can do that here as well. I can call useRef and create my amount input ref like this. Now I would want to pass that to the ref prop, but since this is a custom component, the ref prop doesn't work, at least not out of the box. Instead, I also taught you how you can make refs work on custom components. I showed you how this works earlier in the course. All we have to do is go to the component where we want to receive refs. In this case, that's the input component in the UI folder. And then make sure you import React in there from React and wrap your component function with React forward ref. So that component function is now an argument to forward ref. Then you get the ref, which can now be set through the ref prop on your component as a second parameter here. And you can now use it inside of your component function to forward that ref to that input here. So here I can now set the ref prop on the input element to my ref parameter. And that's this forwarded ref, which is the ref which is being set here on my input component. With that, we can now get access to the input through refs, and that allows me to read that entered value in my submit handler function. There we can get the entered amount by accessing amount input ref.current. It's always .current for refs created with useRef.value. Because amount input ref.current will point at the input element, which is stored in that ref in the end. And then every input element by default has a value property which holds the currently entered value. That value is always a string. Even if the input is of type number, it's always a string. So we can convert it to a number by adding the entered amount number, or however you want to name it, by simply adding a plus in front of entered amount. And this will convert the string number to a number. And then we can add a little if check for validation, where we check the entered amount as text, trim it to remove any white space, and check if that's maybe empty, so if no value was entered. Or if the entered amount as number is smaller than 1, or if the entered amount as number is greater than 5. That's a little validation I want to add here. And if either of these conditions is met, so if we make it into this if check, I want to return and not continue with this function execution of this submit handler. I also want to output an error message below my input and button. And therefore, I'll manage some state here, which is of course optional, but which I want to do. I'll simply use state because it will be a quite simple state. It will simply control whether this form is valid or not. And I'll set this to true initially, and then extract my two values, the state snapshot and the state updating function. And I'll name it amount is valid and set amount is valid. And if we make it into this if check, we know that the entered input was not valid. So here I'll call set amount is valid and set it to false. And if this is false, then I want to output an error message. So here below the button, I'll output some content conditionally, and I will check if not amount is valid. And if that's the case, I will render a paragraph where I say, please enter a valid amount, 125. So that's just a little addition also to practice state and conditional rendering again. Most importantly, the form submission is now only completed or only fully handled if we have valid inputs. So if we make it past this if check. And here I then want to execute my context method to add a cart item, but I'll not do this in this component. Instead, here I will simply call a function which I expect to get on props, and I'll name it onAddToCart. And I forward my entered amount number. Because the cart item which I want to add needs more data than just the entered amount. In this meal item form, though, we only have that amount. We don't have the ID or name or price of that item. That's why I'm not calling the context method here, but why I'm just calling some other function, which I expect to get through props, to pass the entered and validated amount number to that function. And now it's the meal item component where that function will be defined. Here I'll add a add-to-cart handler function where I get that validated amount as a parameter. And I pass a pointer to that function to the meal item form on that onAddToCart prop, which I'm executing in that form component. So here to that prop, I pass a pointer at this add-to-cart handler function. And now in the add-to-cart handler function, I want to reach out to my context. So therefore, in the meal item component, I also want to get access to my context. So here I will import useContext from React, and then simply call useContext. And we now need to import the context to which we want to get access. So cart context from going up and going up again, store cart context, the file with a dash in the file name, and pass this to useContext to establish a connection. And then here we have our cart context, and in add-to-cart handler, we can now call cart context add item, which is one of the methods defined in our context. Here, we're pointing at the add item to cart handler. And I'm calling that function here. And to that function, we now need to pass this item, right? That's what we're expecting here. We expect to get the item which we forward to the reducer. So it's that item which I want to pass to add item. And hence I create a new object on the fly with an ID, which I expect to get through props here. So props ID. With a name, which I get through props. Props name, which we're already outputting down there. We don't need to pass on the description, but I do want to set an amount field, which points at the amount we're getting here. And I do want to add a price field, which points at props price. Not this formatted price, but the price as a number, which we get on props. So now we just need to make sure that we also get props ID, and therefore in the available meals component, where we render all the meal items, I will now also set a ID prop and forward meal ID. And with that, we should be triggering that context method whenever that form is submitted. And that should then add items to the cart. So if we save this, we reload, if I click add here, you see that badge number updated. And it updates whenever I click add. Now the cart logic isn't the final logic I want to have yet, but at least we can see that the context is already working now. Now let's make sure that here, when we open the cart, we are outputting the actual cart. So for outputting cart items, we of course need to go to the cart component. And there we again need to use context now. So we should import use context from React, and of course import the context object, cart context from, going up to the store folder and then cart-context. And in the cart component, we now call use context and pass cart context to it to get access to that cart context. Now here, we no longer want this dummy array of cart items. Instead, now here we can access cart.ctx.items to transform these items to items in the cart. And before we continue working on the cart logic or anything like that, let's actually work on these cart items, that they have the correct look, and let's also make sure we output the total amount and so on. And I'll start with the total amount actually. For that here, I'll add a total amount constant, and I will simply access cart.ctx.total amount. However, I will call toFixed2 here to make sure that we always have 2 decimal places. And I will put this into a template literal to output a $sign in front of this now dynamically injected and derived JavaScript expression. And that's now the total amount, which should be output here instead of this hard-coded value, like this. So that's now the real total amount for this cart. I now also want to make sure that this order button is only showing up if we have items in the cart. So for that, we can add another constant here, right below total amount maybe, which I'll name has items. And here I'll simply check if cart context items has a length greater than 0. So if there are items in the cart. And now we can use has items down there to check if has items is true and only render the button if that's the case. And with that already, if I reload, you see if I open the cart with no items, we have no order button and a total amount of 0. But if I start adding a couple of items, we see them here, we see the updated total amount, and we got an order button. Now, at the moment, items are still added incorrectly to the cart. We're going to work on that soon, but before we do that, I want to work on how these cart items are being displayed. Now for that, I prepared a component for you. Attached, you find a cart item zip file, which contains both a cart item JS file and a cart item module CSS file. Simply copy both files into that cart folder. That's simply a cart item component, which is not too fancy, which is why I'm just providing the finished component to you. In the end, this will just output the price, the amount, and then buttons for adding or removing more of that cart item. And in cart.js, we can now use that cart item. So here you can simply import cart item from that just added cart item file. And then render, instead of that list item here, a cart item. Cart item. Like this. And to cart item, we now need to pass a key, of course, since it's a list. And that can be or should be item.id. We also want to display the name, so that's item.name. We want to display the amount, which is item.amount. And pass the price, which is item.price. And then also pass functions for adding or removing items from the cart. So I will add these functions here now. and add my cart item remove handler, where I get the ID of the to be removed item, and my cart item add handler, where I get the item itself. And we'll add the logic to these functions in a second. And now here on the cart item, which we output in the list, we should add a onRemove prop, because that's the name I'm expecting in that provided component. And to onRemove, we pass a pointer to cart item remove handler. And we add a onAdd prop, another prop I'm using in that provided cart item component, where we point at the cart item add handler. Now on both these functions, you should call bind and bind null item ID. This ensures that the ID of the to be added or removed item is passed here to remove handler. And on add, you should also call bind and bind null and pass the overall item. You learned that bind pre-configures a function for future execution and basically allows you to pre-configure the argument that function will receive when it's being executed. And that's something we need here to ensure that both these functions do receive the ID or the item respectively. Now with that, your cart should look something like this. And here I'm zoomed in, which is why it's a bit cut off. It should look something like this. Now, to make sure that this is never cut off, I'll also quickly go to the cart module CSS file. And here, I'll go to cart items and give this a max height of, let's say, 20 rem, and then add overflow scroll. By doing this, I make sure that this can't get too big, but that instead it becomes scrollable. But your card should now look like this. And of course, the problem we have here is not just that these buttons won't work, but that, for example, here we also have sushi 3 times, which is absolutely not what we want here. I also want to go to cart item and quickly make sure that on the price here for props price in the cart item component, I also call toFixed2 to force this to always have 2 decimal places, for example, here for the schnitzel now. So now, as a next step, I want to make sure that the logic for adding items to the cart is different. And if we add sushi a second or third time, it's aggregated together into one item where this amount changes, instead of more items being added to this array. Now, to change the logic for adding cart items, we need to head back to the cart provider and there to the cart reducer. At the moment, items are always added as new items in that array. Now that needs to change. When we're adding an item, I always want to calculate my updated total amount like this first. That is always correct, no matter if the item is already part of the cart or not. But then, before I derive my updated items, I instead want to check if an item is already part of the cart. And for this, I'll create an existing cart item index constant, where I will reach out to my existing items in the cart, and where I call findIndex, which is a built-in method in JavaScript which finds the index of an item in an array. Now it takes a function which should return true if that's the item we're looking for and false otherwise, because this function will be executed for every item in the array. And I want to return true if item ID is equal to action.item.id. So if the item we're currently looking at in that array has the same ID as the item we're adding with this action, which was dispatched. Now this will then return us the index of that item if it exists. So what we can do now is we can get the existing cart item by reaching out to state items and accessing that existing cart item index. And this will only work if we have that item already. Otherwise, we'll try to access an item which doesn't exist, and hence existing cart item would be null. If that item already is part of the array though, this item will be set to that item. And now we can add an updated item variable and an updated items variable, which clashes with this constant, but we'll fix this soon. And then we add another if check here, where we check if existing card item is a thing, if this is truthy, which will only be the case if it's already part of the array. In this case, the updated item will be set equal to a new object where I copy the existing card item, but where I update the amount, because the amount now needs to change. If sushi was already part of the card and we added 2 more sushis, then of course we need to update the amount of that existing sushi, which is part of the card. So here I then access existing card item.amount plus action.item.amount. So the amount which was added by this action. And updated items is now equal to a new array where I copy the existing items so that I update this immutably without editing the old array in memory. Hence, I'm creating a new array where I copy the old objects. And then for that existing card item index, I override this with the updated item. So I pick the old item, which we identified in the card items array, and I override it with this updated item. Now that's what I do if an item is already part of the card items array. Now we also have the else case that an item is added for the first time to that card items array. In that case, the updated item is simply a brand new item where I copy my action item. And now updated items is simply set to state items concat, and then here I add this updated item. Or we keep this simpler and we keep on adding action item. We don't set updated item here, and we move updated item in here therefore and create this on the fly as a constant, because now we only use updated item in that first part of the if block. And our else block is very lean now. With that, we set updated items to different things, depending on whether the item is already part of the array or not. And either way, we then return our new state snapshot, which picks up these updated items. I hope this logic makes sense. And with that, if we now reload, I can add sushi. And if I add it multiple times, and if I add 4 sushi at once, you see we only have one entry here with the appropriate amount. And that's exactly what I want. Now, if I add a second item, this is added as a new entry, of course, because it's a different item. But then again, if I add more items of that, it just increases the counter. So that is working. Now, let's make sure that the plus and minus buttons here in the cart also work. And for that, we also need to make sure that we can remove items. So let's now make the cart work, and let's make sure we can add and delete items from there as well. Now actually we can start with adding items because we got all the logic for that in place already. And in the cart.js file, we got the cart item handler, which is being triggered when this plus button for a cart item is clicked. So in the cart item handler, we now simply need to reach out to our cart context and call add item there and simply forward the item. And that will trigger that add item function in the cart provider. Here it is, which dispatches this cart action, and that will therefore already do the rest. So with that, if we save that, if we reload, if I add a couple of items, if I click the plus next to sushi, this already updates, and the same for the schnitzel. So this is working. Now what's of course not working is removing items. So therefore, let's work on this now. We already got the remove item from cart handler in the cart provider, where we dispatch an action, but currently we're not really handling that action. In the cart reducer, we should now add another if check, where we check if the action type is equal to remove. Like this. And actually, we should do that not here, but next to the add if check. So here, right before we return our default card state, which is our fallback in case we had some other action. Now, in here, we now want to update the card. And again, we'll have to make a differentiation here. Generally, we want to update the existing card item. So for example, here, if we already have sushi in the cart and we click minus, we want to decrease the amount by 1. But sushi will still be a card item unless we had an amount of 1 here. Then, if I press minus again, if this was 1 here, I want to remove the item entirely from the cart. So we'll have to differentiate and check for that here in our reducer. We can start by finding the cart item as a first step though. For this, I'll again get my existing cart item index here by reaching out to state items find index. Same logic as before. And here, just as before, we can copy that entire code here and replace this actually. We now find the index of an existing item. Now we can also get the item itself by then reaching out to state items for that identified index here. We also want to update the amount, and we can do that first. The updated total amount is simply state item, state total amount minus simply existing item dot price, and I should move this past the existing item, of course. Because either way, if we remove the item entirely from the array, or if we just decrease the amount in the cart, we simply remove one item of that type. So the total amount definitely decreases by the price of one single removed item. So this line here is always correct. Now we can again create our updated items variable and then again differentiate. And simply check if for the existing item the amount is equal to 1, which means it's the last item of that type in the cart which we want to remove, in which case we want to remove the entire item from the array. Else, if it's bigger than 1, we want to keep the item in the array, we want to keep the item in the cart, but we want to decrease the amount. So let's start with the if case. Here, updated items is simply state items filter. Filter is a built-in method which returns a new array filtered by applying specific conditions. And we pass a function to filter which is executed for every item in the array. And that function receives the item. And if we return true here, we keep the item in the newly returned array. If we return false, we get rid of it. So here we want to keep all items, but we want to remove the item with that ID which we get on our action here. That's the item we want to get rid of. And by the way, here we should just check action ID, not action item ID, because for removing items, we are dispatching an object which just has the ID, not the entire item. So that's a little fix we should implement anyways. But now back to filter. Here we want to check if item ID is not equal to action.id. With this check, we make sure that all items where the ID is not equal to the action ID are kept, because this returns true and hence the items are kept. But the one item where the item ID is equal to the ID of the action, which is the to be removed ID, for that one item we return false here, and then we remove that item from the newly generated array. So that gives us a new array where this item with this ID is not part anymore. And that's the entire logic for this case that we had an amount of 1. Now, if the amount is greater than 1, we don't want to remove the item from the array. We just want to update the amount. So here we have the updated item, which is a copy of the existing item in a new object with the spread operator. And we just update the amount. We set the amount to existing item.amount minus 1 to decrease it by 1. And updated items is then a copy of state items to create a new array with the old items. But we override one of these items, the item for that index which we got here, where we then override the old item in the array with the updated item, which has the updated amount. And then here, after this if-else block, we simply return a new state object where items is updated items and the total amount is equal to the updated total amount. And that's our logic for removing items from the cart. Now we just need to wire up this button in the cart component. Here in the cart item remove handler, we now want to call cart context, remove item, and forward that ID. And if we do that and save everything, if I reload and I add a couple of items, I have one of all these items in there. If I now remove sushi, it's removed entirely from the array. If I add one to the schnitzel and I then remove that, the amount is just decreased, and only if I remove that again, it's removed from the cart. So now it looks like adding and removing to and from the cart is working correctly. And that's exactly, of course, what we want here. Now with that, we're almost done, but I want to play a little animation on the cart button now whenever a new item is added to highlight that this badge changed and that the cart overall changed. Now, as a final step in this application, I want to come back to this button in the header, to this header cart button. Everything works in this application, but I want to play a little animation on this button whenever we add an item to the cart, or also when we remove an item. So whenever the amount of items in the cart changes. And for this, I already prepared something in the CSS file, which I provided to you earlier. I set up a little CSS animation here, which makes the button bump and change its scale. Now we just need to make sure that this class, which starts this animation, this CSS class, is added to the button. For this, here I'll add a little constant button classes, and I'll simply set this equal to a string using the template literal notation with backticks instead of single quotes. And here I will always add classes.button, but then conditionally I want to add the animation class. Now to show you how it works, I will add it right away, not conditionally, but always for the moment. And that's the bump class. And now here for class name on the button, I set this equal to button classes. If you save that and reload, you see this bump animation here. It only plays once, but later it should play whenever this card changes. To make that happen, we can utilize useEffect. We haven't used it thus far in this application because we had no traditional side effect up to this point. No local storage access, nothing like this. Of course, you could add such features, but here we simply don't have it. Therefore, here I will utilize useEffect to play this animation. And therefore here in the header card button, I'll import useEffect and then call useEffect here in this component function. Now we pass our effect function to that and then our array of dependencies, as you learned. Now here in this effect function, I want to do one simple thing in the end. I want to change my button classes to include the bump animation class, and then I want to set a timer which removes that class again so that when it's added again in the future, it again plays. So therefore, I will also import useState because we'll need to re-evaluate and re-render this component when that animation class is added conditionally. So here I'll call useState, set this to false initially, because this will control whether or not the button should be animated. And I'll name it button is highlighted and set button is highlighted. Of course, the state names are up to you. Here in useEffect, I'll then call set button is highlighted and set this to true. Then, as a next step, here for my button classes, I will not always add the bump class, but I'll check if button is highlighted is true. And if that's the case, classes.bump is added. Otherwise, an empty string is added. So no extra CSS class is added then. And I do this here because since I'm updating the state, the whole component will re-execute when that state changes. So this line will also change again, and the updated classes will be picked up down there. Now, of course, I don't always wanna change this state though. I only wanna change it if my items changed and if the length is greater than 0. So if there is at least one item in the cart, let's say. Hence here, I will check if cart CTX items length is equal to 0, in which case here I'll just return so that the rest of this effect function doesn't execute. Because this should only execute if we have at least one item in the cart, let's say. Now we need to add this as a dependency, but if I add cart context like this, this effect would rerun whenever anything about my cart context changes. And that's not what I want here. Therefore, I'll use object destructuring to pull out the items, to get them out of my cart, so that here I can just refer to items and pass items as a dependency. So that not the entire context, but only the items array is a dependency for this effect function. Of course, we can also pull this out a little bit earlier and, for example, also then refer to just items here. Now, if we save this, if I reload, if I click add, watch the button in the top right corner. It now bumps. But only the first time I add something. The reason for that is that then this class is added, but since it's currently never removed, thereafter it never changes, because the animation is actually only played when this class is added for the first time. Therefore, we should also remove the class after the animation finished. And I'll do that by setting a timer here. I'll set a timer which fires after 300 milliseconds, because that's the duration of this animation here. I played over 300 milliseconds, so after that duration, I trigger a function where I set button is highlighted back to false. And if that's false, this here will ensure that an empty string is added to the class's string instead of the bump class. So that will remove that CSS class from the rendered DOM. Now I also want to add a cleanup function where I clear that timer in case that component should be removed. This can't happen in this application, the button is always there, but it's still a good practice to clean up any timers or any other side effects that might be ongoing because you started them in useEffect. So here I'll return my cleanup function. You learned that if you return a function in useEffect, this will be called automatically as a cleanup function by React. And here I'll call clear timeout and clear that timer, so that when this effect reruns, we clear the timer. And actually, we do need this here, now that I think about it, because of course this timer can be set again before it expired. If we add multiple items rapidly after each other, we want to clear the old timer and make sure that a new timer is set and the old timer is, well, cleared. So we definitely should have that cleanup function here. And now we do. And with that, if we save this, if I reload, you see, whenever I add an item, this button bumps. And that's just a little visual tweak, and in addition, as a nice side effect, no pun intended, it's another practice and exercise of useEffect, which you need for handling side effects. At this point in the course, we are capable of building basic React apps. We learned a lot about some of the most important features that are baked into React, but there's one thing that's really missing, or that we haven't had a closer look at until now, and that is how React actually works behind the scenes. Now, I know that to some students, this is not interesting. You might be one of them. And generally, that's of course fine. You are using a library like React so that you don't have to do all the heavy lifting on your own. However, it really helps to understand how something works that you're using to ensure that you are using it correctly. And whilst I of course do teach you common practices and best practices throughout this course, it nonetheless is important for you to know the tool so that you are able to make the right decisions in the apps you're going to build. So even if that's not super interesting to you, I would strongly recommend that you don't skip this module and at least go through the videos at a higher speed if you're really not interested. We'll also dive in some new features which are related to the behind the scenes work, so I would recommend that you at least watch those lectures, though they will of course make more sense if you watched the entire module. So what's in this module then? We'll have a look at how React works behind the scenes. That does not mean that we're going to dive into the source code. It means that I will show you how React works with your components, how it updates those components, how state is related to all of that. We'll understand that React uses something which is called the virtual DOM, and we'll understand how that works and how it affects updates made to the real DOM, which is in the end what drives your website in the browser. And we'll take a closer look at state management, how React does that, and how state updates are managed by React. A lot of important concepts, so let's dive right in. So how does React work? Let's not forget that React is a JavaScript library for building user interfaces. That's what I taught you at the very beginning of this course, and of course it hasn't changed. We also learned and we saw that React is all about components. We use components to build those user interfaces, and React embraces this component concept. It uses components to effectively compose user interfaces, and it uses components to effectively update user interfaces. There's one important note. We also saw this React DOM thing. And in the end, React DOM is your interface to the web. React itself, React.js, does not know the web. It does know nothing about the browser in the end. React knows how to work with components, but it doesn't care whether those components contain HTML elements or if they contain totally fictional elements. That does not matter to React. It's React DOM to which that matters in the end, and which ultimately needs to bring real HTML elements to the screen. But React is just a library that manages components, that manages state, and that manages different component states, and that finds out how components might need to change and which differences you might have from a previous state of a component compared to the current state. And React hands all that information regarding what changed and what should be visible on the screen, no matter what screen that is, off to the interface it's working with. For example, it hands it off to React DOM, because React DOM is then responsible for working with the real DOM, which is part of the browser, and therefore React DOM is responsible for bringing something onto the screen which the user is then able to see. React only cares about components. It cares about props, which is basically data you pass to components to make components configurable and to enable parent-child component communication. React cares about state, which is internal data inside of a component. And React cares about context, which is component-wide data. Now, of course, React has a couple of other features built in as well, but these are the core features. And whenever props, state, or context changes, components that use these concepts are updated by React, and React checks whether this component now wants to draw something new onto the screen, and if that should be the case, React will let React DOM know about that so that React DOM is able to bring that new screen, that new component, that new output to the screen. So therefore, if we have a closer look at that components, real DOM communication here, the question of course is, how exactly does this work? As I mentioned, React is concerned about components. And what React in the end does is it uses a concept called the virtual DOM. It determines how the component tree, which your app is building in the end, and every component itself, of course, has a subtree, the JSX code returned by that component. It determines how that component tree currently looks like and what it should look like, for example, after a state update. And that information is then handed off to React DOM, which now knows about the differences and which then knows how it should manipulate the real DOM to match that virtual DOM, that virtual snapshot React derived for your component trees. And related to that, there's one important thing to note. Throughout this course, I often said that React would rerun a component function, that it would re-evaluate a component. And indeed, as I mentioned before, whenever state, props, or context of a component changes, that component function is re-executed. That component is re-evaluated by React. But it is worth noting that re-evaluating a component is not the same as re-rendering the DOM. So just because a component function is re-executed by React does not mean that the respective part of the actual real DOM is re-rendered or re-evaluated. Instead, we have to differentiate between our component part, our React part, and the real DOM. Our components, as I just said, are re-evaluated whenever props, state, or context changes. So React then executes that component function again. Now, the real DOM, on the other hand, is only updated in the places where it needs to be changed based on that difference React derived between the previous state of a component and its tree and the current state after the state, prop, or context change. So the real DOM is not changed all the time. It's changed rarely and only when needed. And that's important for performance, because making a virtual comparison between the previous state and the current state, that's fairly cheap and easy to do. That happens only in memory. Reaching out to the real DOM that's rendered in the browser is pretty expensive from a performance perspective, because working with the real DOM just turns out to be a performance-intensive task. Of course, not a tiny change in one place, but if you do that tiny change in a lot of places all the time, then your page might become slow because you're working with the real DOM too much. And that's why React has this structure of doing virtual comparisons with that virtual DOM, and then only passing the changes between your last snapshot and the current snapshot to the real DOM. That's how React works here. It does this virtual DOM diffing, finding out the difference between two snapshots. And to see a real example, it could look like this. Let's say of a given component, our previous evaluation result, so when the component function ran the last time, is this. And now some state changes, and all of a sudden we want to show a new paragraph. So that's our current evaluation result. In this case, React would determine that the difference between both snapshots is this paragraph, and it would report this change to React DOM so that React DOM can update the real DOM and insert this paragraph. React DOM would not re-render the entire DOM. It would not touch this existing h1 or div element. It would only insert the paragraph after the h1 element inside of the div. That's how React works behind the scenes in a nutshell. Now let's see this in action with some real code, and let's play around with that a bit so that we get a feeling for this and so that we can also find out how this all behaves and possibly changes for props and state changes, for context, and for other components being involved, because it is really crucial that you understand this. Attached, you find this very simple application, which in the end currently just has this app component with a div and a h1 tag. So essentially what you just saw on the slide here. And now let's replicate that behavior I showed you on the slide. Let's say for some reason, eventually a paragraph should be added here. Now, how can we eventually add this and not add it right from the start? Well, with a state change, for example. We could have some state which changes such that initially no paragraph is rendered, But then at some point, because a button was clicked or a timer expired or anything else happened, the paragraph is displayed. Now I will work with a button here, and therefore first of all I will import use state, of course, because we need some state, because as I mentioned, React will only rerun this function and reevaluate what's on the screen if state, props, or context changes. Now, since this is our root component, props and context is a bit harder, and in the end it's also worth noting that of course it all comes down to state changes ultimately. Even context internally will use some state that might change the value which is then distributed through context. And if we think about props being passed from a parent to a child, how could the value passed through props change? Well, ultimately, only if state in a parent changed. It all comes down to state changes in the end if you think about it. So therefore here we're going to work with some state, and I'll name my state here show paragraph and set show paragraph. And initially that is false. My initial state here is false. And then here we use show paragraph as you learned it in the conditional module, in the conditionals module. This is how we can show an element conditionally. Now, if I save this, of course we will not see the paragraph because our state is false, and currently we have no way of changing that state. Now, in the starting project, you find a button component, just so that we have a nicely styled button. So I will add this button component here, import button from /components UI button. Show paragraph is the label we could have on it. And then here we can add the onClick prop on the button and add a function here, toggle paragraph handler, for example. And this function should trigger when the button is clicked. And it should actually toggle the paragraph, let's say. So I'll rename my caption here to toggle paragraph. And in there, I will then set show paragraph, and I will set the state to what show paragraph currently is not, so that we basically inverse it. The short form would be this syntax, where we set the value for show paragraph to the opposite of the old value. But since we depend on the previous state snapshot, I mentioned that we want to use the function form for the state update here. I will come back to why we do that later in this module again, by the way. And therefore, let's use the function form, previous show paragraph, and we'd return the opposite of previous show paragraph, therefore. And this is the cleaner way of changing our state. And now we bind the toggle paragraph handler to the button. So with that, we have the logic to conditionally show the paragraph. Now to center this, I'll quickly go into my styles here and add text align center here in the app selector. Side note, I'm not using CSS modules here, I'm just using regular CSS imports. Okay, with that, let's click toggle paragraph. And you see the paragraph is here, and it's gone, and it's here, and so on. Now that's interesting to know. But let's now analyze what's happening. First of all, I always mentioned that state changes, prop changes, and context changes would result in this component function being executed again. If that's the case, we should be able to add a console log here and say app running and see this whenever we click the button in the end. Well, let's see whether that's the case. I'll save that. Here's my console, and you see initially app running. That is because the page reloaded and that brought this app component to the screen for the first time. So of course this was executed by React. And for that first render cycle, React then found out that it wants a div, a h1 element, and a button, no paragraph, because initially that's not shown. And it checks that to the last output it saved. And since this rendered the component for the first time, there essentially is no previous output, there is no previous snapshot, and therefore this difference comparison in the end resulted in a div, a h1 tag, and a button to be rendered. And that information was handed off to the React DOM package, which therefore rendered that to the screen. Now if I click toggle paragraph, we see app running again. So that proves my point that for every state change, the entire component in which the state changed is re-executed, is re-evaluated. Now, how is the real DOM affected though? For that, let's go to the Elements tab in the DevTools, and let's expand our div here, the app div. Now, if I reload, we see we just have the h1 and the button element here initially. And now, the good thing about this Elements tab is that things that are changed in the DOM will be flashed. They will be highlighted so that we can see where the real DOM was re-rendered or updated. Now therefore, watch this part on the right here as I click the toggle paragraph button. You see, the only thing that flashed was this paragraph. The h1 and the button element did not flash, neither did anything else. It was just the paragraph. And if I remove it, it's just a div, because from there the paragraph was removed. But the h1 and the button elements were not flashed because they were not re-rendered. And that's what I meant. Only the difference between those virtual snapshots was considered for the updates made to the real DOM. And that is really, really crucial to understand. Now let's see how that might change if we work with more components. For that, in the components folder, I'll add a new subfolder. I'll name it demo. And in there, I'll add a new file, and that's my demo output.js file, where I import React from React. And then here I have the demo output, where I get props. And I export this as a default, of course, so that's a standard component. At least it is as soon as we return JSX. And now I'll take my paragraph here. This is new. Remove this line here from the app component and add it instead here as the return value. To be precise, I'll do something slightly different now. I will not conditionally render my own component or not, because it should be obvious that this will behave like rendering the built-in paragraph component or not. Instead of demo output, I'll change the HTML structure a tiny bit. It'll not just be this paragraph, like this. Instead, I will render this text in the paragraph conditionally. And I will render it conditionally based on some data I get through props. So that I can check if props show, for example. So if the show prop is truthy, let's say we expect a Boolean here, so if it is true. And if that is the case, then I want to render this is new. Otherwise, I will render an empty string. So the paragraph element is always rendered, just the text changes now, based on the show prop. So now back in app component, I therefore want to include my demo output here. So make sure you import demo output, of course. And there I want to set the show prop, because we use that show prop in demo output. And the value we pass here should of course be show paragraph, because that is a Boolean. It is false initially, and it's changed to true if we click the button, and then back to false, and so on. So now this component here is always rendered, and in the component the paragraph is always rendered, but the text that's shown, that will change based on the show prop. So now if I save that, let's go back. First of all, if I click this, you see we got basically the same behavior as before. There is no great difference. Now, if we expand our DOM here a little bit, we see, of course, that the paragraph is always there. But again, if we click the button, we see that the paragraph flashes when I click it, and it flashes again if I click it again. The reason for the paragraph flashing is that we now only work with that element, and we add or remove the text. And this is treated as a change for the entire element, which is why the paragraph flashes and not just the text. Because the text is basically like a prop to the paragraph, you could say. It's its content. But again, it's just a paragraph. It's not the h1 or the button element. So the fact that we're using a custom element, a custom component, does not change this. And of course it shouldn't. The updating mechanism should always work by comparing differences. It is of course interesting to see that we are changing state in the app component, and yet only the paragraph, which is part of another component, flashes. So this of course proves that the React updating and diffing mechanism works and finds out changes correctly. Now one other thing is also interesting though. If we go to the console and I reload here, you see app running, and you see that of course runs whenever I click this button. Now keep in mind, the actual change happens in demo output. But of course the app component runs again as well, because that's where we manage the state. And I mentioned the component where you manage state or where you have props or context and that state, props, or context changes, that component will be re-evaluated and re-executed. And we are managing the state in app. So just because the change visually only affects this paragraph in another component does not mean that the app component is not re-evaluated. Of course it is, because there we manage our state. And that's, by the way, also what I meant earlier with props and context, in the end always coming down to state changes. The props we got in demo output are of course responsible for why demo output is re-rendered. But ultimately, of course, the value we get here on the show prop is the value we manage in the show paragraph state. Ultimately, it all comes down to state and state changes in React. Now, it of course should be obvious that if I now add a console log here in demo output, that we'll see this being printed for every button click as well. We see it initially because that component is rendered initially. And then if I click toggle paragraph, well, we again see demo output running for every click. And again, that makes a lot of sense because the props changed with every click. So thus far, this hopefully all is pretty clear and pretty straightforward. Now I'll show you something that might be confusing. Keep in mind that demo output running is printed for every click. And again, that makes sense because we do change the state and therefore the props here with every click. But now let me tweak this. In app.js, I will now hard code the value I pass to show, and I will set this to false. This means that we'll never show the output because it's now detached from the show paragraph state. Indeed, I'm not using the show paragraph state at the moment. I'm still changing it, but I'm not using the state value. Now, what would you expect as a result? Let's see. If the app reloads, we see app running and demo output running. Makes sense, the app just loaded, both was rendered. But something interesting happens when I click toggle paragraph. If I do that, you see app running, okay, we changed the state there, but you also see demo output running. And that's interesting. The props didn't change, right? We have the show prop, and the value I pass in there is still false. It never changes, it's always false. So why was demo output re-executed? Well, let's take it step by step. The app function is re-executed because state changed there. Now what is part of that app function? Of course, this return statement. And there we return some JSX code. Now all those JSX elements here in the end are like function calls to the respective component functions. So we call the function for the demo output component, we call the function for the button component. That's why those child components are also re-executed and re-evaluated just because the parent component changed, because they are part of the parent component's function body. And if the parent component function runs again, of course the child component functions also run again. So in the end, the prop value doesn't even matter here for this component to be executed again. It's just the fact that the parent changed. Changes in props might lead to actual changes on the real DOM, but for the function to be re-evaluated, it's enough that the parent component was re-evaluated. Of course, the fact that demo output runs again does not mean that the real DOM is touched. We can verify this with elements. There, you'll see that nothing flashes. I can hammer that button and nothing changes there. Because React just re-evaluates the components, and as you learned, re-evaluating a component and rerunning its component function is not the same as re-rendering the real DOM or manipulating the real DOM. But it is really important to understand that if a component is re-executed, all its child components will also be re-executed and re-evaluated. So therefore, of course, not just the demo output component is re-evaluated, the button is as well. If I console log button running here, you will see that if I go to console and reload, we see all three outputs initially. And if I click this toggle paragraph button, we also see all three. So the button component is also re-evaluated as well. This, of course, brings up one question though. Here we have a very simple app, just one root component with two child components, which then each don't have any more child components. If they would have child components, though, those child components would also be re-evaluated. Of course, and I can show this to you. If I add a my paragraph.js file here, where I essentially copy demo output, but I then simplify this, and here I have my paragraph also as a component name. And then in there, I just output a paragraph tag with props children in between. I can use my paragraph instead of the built-in paragraph, and I'm really just doing this for demo purposes here to show you how React updating works, not because this would be such a useful component. It isn't. But now with that, if I add my paragraph, which replaces the built-in paragraph, just to then reuse it, if I add this, you of course will see in the console that my paragraph running also is re-executed for every button click. So this continues down the component tree, and this brings up one important question. Isn't this bad? Because if all those component functions are re-executed, that's a lot of ongoing function executions and virtual comparisons that certainly cost some performance, right? So isn't this bad if there actually is no reason for that? Because we know, for example, that we never need to re-evaluate demo output because it can't change. The only prop which it has is hard-coded. If it had no props at all, we also would know the output in there will never change because of the state that's managed in app component. So re-executing demo output and all its children is a total waste. Well, this certainly costs some performance. Of course, we got ongoing function executions, we got a virtual comparison. It's needless to say that React is highly optimized for those executions and comparisons. So in a lot of apps, and especially in simple apps like this one, this will absolutely not matter. Nonetheless, in bigger apps you might want to optimize that, and therefore you as a developer can tell React that it should only re-execute this demo output component under certain circumstances. And those circumstances would be that the props which this component received changed, for example. So that if I bring back show false here, React actually checks if the show value changed, and only if that's the case, it will re-execute demo output. That might be closer to the behavior we want. How can we tell React that it should behave like this? Well, we have to go to the component for which we want to opt into that did the prop change check. And we simply wrap our component, for example, here in the export line, with React memo. This is for functional components. For class-based components, this does not work, but I'll take a closer look at class-based components and how to optimize those in the class-based component section later down in the course. Since we can basically work with only functional components, class-based components are not the focus here. So React Memo allows us to optimize functional components. Now, what does Memo do? It tells React that for this component, which it gets as an argument, React should look at the props this component gets and check the new value for all those props and compare it to the previous value those props got. And only if the value of a prop changed, the component should be re-executed and re-evaluated. And if the parent component changed, but the prop values for that component here did not change, component execution will be skipped. If we wrap this and we save that, we can see the result of that by going back. Initially, of course, demo output is executed because the app was just rendered for the first time. But now if I clear the console, if I click this button, you see only app and button running is being printed. The demo output running is not being printed. And therefore, my paragraph running is also not being printed because my paragraph is a child of demo output. And if demo output is not re-executed, of course, its child is also not re-executed. So this is now an optimization in place here that avoids this unnecessary re-rendering. Now, that might bring up a new question though. why aren't we using that on all components if it allows us to optimize them? Because this optimization comes at a cost. The memo method here tells React that whenever the app component changed, it should go to this component here and compare the new prop values to the previous prop values. So therefore, React needs to do two things. It needs to store the previous prop values and it needs to make that comparison. And that, of course, also has its own performance cost. And it therefore greatly depends on the component you're applying this to, whether it's worth it or not. Because you're trading the performance cost of re-evaluating the component for the performance cost of comparing props. And it's impossible to say which cost is higher, because it depends on the number of props you have and on the complexity of your component and the number of child components your component has. Of course, React Memo can be a great tool if you have a huge component tree with a lot of child components, and on a high level in the component tree, you can avoid unnecessary re-render cycles for the entire branch of the component tree. Like in this case, by avoiding the re-evaluation of demo output, we're also automatically avoiding the re-evaluation of my paragraph, even though we're not using React Demo in there, just because we cut off this entire branch, so this entire branch of the component tree. That is something where React Memo can definitely be worth it. If you, on the other hand, have a component where you know it's going to change, or its props values are going to change with pretty much every re-evaluation of the parent component anyways, then React Memo doesn't make a lot of sense. Because if the result is that the component should re-render anyways, well, then you can also save that extra comparison of the prop values. That's then just some overhead cost, which is not worth it. And of course, ultimately, as always, it depends on your app size. For small apps, for small component trees, and so on, for all of that, it might simply not worth it to add this. But for larger apps, where you can cut off entire branches of unnecessary re-evaluations, it might very well be worth it. You just don't want to wrap every component with React Memo. Instead, you want to pick some key parts in your component tree, which allows you to cut off an entire branch of child components. That's way more effective than doing this on every child component. So now that we learned about React Memo, let's also apply it to the button. We can argue whether that's good or not, because the button is a trivial component, so doing that prop checking might not be worth it. On the other hand, we as a developer know that this button realistically doesn't really change. So re-evaluating the button all the time shouldn't be worth it. There's nothing on it that changes, right? We have the same text, we have the same function, so why don't we wrap it? For that, let's go to button and use React Memo down here and wrap our button component with it. Now you will see something interesting if you do that. If you save that and reload the app, of course initially we see button running, but now if I click toggle paragraph, we again see button running. Why is that happening? That makes no sense, right? Well, we see button running again and again because actually its prop values did change. That's strange, right? If we have a look at that, it only gets one prop on click, or actually two props, the children here, but both prop values never change. We always have the same text and we always have the same function, right? Well, this is one of the most common gotchas with React. Keep in mind that this app component is just a function in the end. And it re-executes like a normal JavaScript function, because it is a normal JavaScript function, if your state changes. The only magic thing here is that the function is going to be called by React and not by you. But then it still executes like a normal function, which means all that code executes again. And that has one important implication. Of course, this function which you pass to the button is recreated. This is now a brand new function for every render or every execution cycle of the app function, because in the end it's just a normal constant which we recreate. All that code in here is executed again. So of course, a new function is created. This is not the same function all the time. It's a function that does the same thing, But technically, to JavaScript, it's a brand new function for every time the app function is being executed. That's, by the way, also true for false being passed to demo output. Previously, I said that this never changes. Even that technically was not correct. This app function is re-executed, therefore a new false value is created. So even if we had false in the last render cycle too, now we have a new false. But if that's the case, why does React Memo then work on the demo output but not on the button? What's the difference between false and the function here? If a new false is created and a new function is created, shouldn't then both components be re-evaluated? Well, for that you have to keep in mind that false is a boolean, and booleans like strings and numbers are primitive values in JavaScript. Now what React Memo does in the end is it has a look at all the prop values, and in the end it compares props show to props previous.show, you could say. This is not exactly what it does internally, but you can imagine it like that. So in the end, it has a look at the previous value for the show prop and compares it to the current value. And it does so with a regular comparison operator. Now for primitive values, that will work. Because for primitive values, if I compare two booleans, I get true if they are the same. If I compare two strings, I get true if they are the same. Now technically, that is a different boolean than this here, and that's a different string than this. These are two different values. But for primitive values, this comparison works. Now that's not true if you compare arrays or objects or functions. For comparing two arrays, let's say, which look similar to us humans, in JavaScript, they are not equal. And that's not React specific, that is JavaScript. And attached to this lecture, you find an article and a video on primitive and reference values so that you really understand this, because that's a core concept of JavaScript. Now, it's important to understand that functions are just objects in JavaScript. Again, not React specific, that's just JavaScript. So here, a new function object is created with every time the app function runs. And this function object is passed to the onClick prop. Now therefore, button in the end compares props onClick to props previous.onClick, for example. And in there, we have two function objects. Now two objects, even if they have the same content, are never equal in JavaScript when compared like this. And therefore, React Memo finds out that the value changed just because of how JavaScript works. Now that is really important to understand. I know it's a common gotcha and something a lot of developers, even more experienced ones, are struggling with. That's why I'm emphasizing it like this. This is crucial to understand and to get right. Now, of course, as a result of that, does this mean that React Memo is useless for components that receive objects or arrays or functions through their props? No, thankfully not. Let's have a look at the solution in the next lecture. We can make React Memo work for prop values that are objects as well. We just need to tweak the way we create and store those objects a little bit. There is an extra hook provided by React that helps us with that, and that is the use callback hook. Use callback is a hook that allows us to basically store a function across component executions. So it allows us to tell React that we want to save a function and that this function should not be recreated with every execution. With that, one and the same function object is stored, so one and the same place in memory, and therefore the comparison does work. Because, just to make this clear again as well, if you have object 1 like this, and you have object 2 like this, which look similar, you learned that they aren't similar in JavaScript. If you, however, set object 2 equal to object 1, you point at the exact same place in memory, and therefore now object 1 will be equal to object 2. And that's in the end what use callback does for us. It will save a function of our choice, basically somewhere in React's internal storage, and we'll always reuse that same function object then when this component function executes. And using it is simple. We just wrap the function we want to save with it. So here we use the useCallback hook and pass our function as a first argument to useCallback. And useCallback then returns that stored function, and when the app function reruns, useCallback will look for that stored function, which React stores for us, and reuse that same function object. So if we know that this function should never change, we can use useCallback to store it. Now you see I got some yellow squiggly lines here though, which tells me that I did probably forget to pass an array of dependencies. UseCallback, like useEffect, actually wants a second argument, and it wants it even more so than useEffect. And just like for useEffect, the second argument should be an array of dependencies of this useCallback call. And the dependencies here are the same as they are for useEffect. Anything you use in your function, which is coming from the surrounding component, so any state or props or context, should be specified here. Now here we only have the state updating function, and we could add this as a dependency, but we don't have to, because as mentioned earlier in the course, React guarantees us, actually with help of useCallback probably, that this will never change, so that this will always be the same function object. Hence, this is an exception which we don't have to add. And then in this simple callback, we have nothing else. Keep in mind that this code here is just a function we pass to setShowParagraph. So that is totally contained inside of our callback function. So therefore here we have an empty array of dependencies, which basically tells React that this callback function, this function here, which we want to store in toggle paragraph handler ultimately, will never change, that it has no dependencies, and that therefore always the same function object should be reused when the app component re-renders. Hence now if I save that and I reload, we see button running once, but then you never see it again. Because now React Memo is able to do its job because we ensure that all the prop values we pass in are comparable. In this case, because this toggle paragraph handler function object is guaranteed to always be the exact same object in memory because of useCallback. Let me come back to useCallback because it is important to understand this. UseCallback allows you to save a function so that you can reuse it. Now you had to specify this strange dependency array. And I don't know about you, but initially you might think, what do I need this for? My function has always the same logic across re-render cycles. Well, keep in mind that in JavaScript, functions are closures, which means they close over the values that are available in their environment. Now again, if you're not 100% sure about closures, attached you find some resources that get you started with them, because you need to know closures to fully grasp how React works. Let me give you a concrete example. Let's say we have a second button, which enables the toggling functionality. So a button that makes the other button work. Allow toggling. For that we need a new state. Allow toggle and set allow toggle, and initially that's false. And we have a new function here, allow toggle handler. We could again use callback, but for the moment let's omit it, doesn't matter here. Here I want to call set allow toggle and set it to true. So I always set it to true here. This does not toggle the toggle value, it just enables toggling for the other button. Because now, and that's the gotcha, I will not only bind the allow toggle handler here to the new button. Instead, I will use the allow toggle state snapshot in my other function here to check whether I'm allowed to set show paragraph. So now here I will check if allow toggle is true, and only if it is, set show paragraph will be called. So the show paragraph state will only be updated if toggling is allowed. And now I will also reuse show paragraph here to replace my hard-coded false value. With that, if the app reloads, you will see that if I click the toggle paragraph button, nothing happens. Now, if I click allow toggling, now the other button should do something, and when we click it, we also should see app running. However, if I click it, still nothing happens. And that's because functions are closures in JavaScript and because we're not using useCallback correctly right now. We even got some yellow squiggly lines here to make us aware of that problem. At least I got them here. Now, what is the problem though? Functions in JavaScript are closures. That means when a function is defined, which happens when the app function runs in this function's case, when that function here is defined, JavaScript basically locks in all the variables that we're using in there. All the variables that are defined outside of the function that we are using, I should say. In this case, the allow toggle variable. That is a variable or a constant coming from the app function, and I'm using it inside of this function. Therefore, JavaScript closes over that constant and basically stores that constant for that function definition. That means the next time this function here, the toggle paragraph handler, is executed, this stored variable will be used. And with that, the value of that variable at the point of time it was stored. This generally is perfect because this allows us to use variables from outside the function in the function and call that function at any point of time we want, which is exactly what we want for a function that we bind to a button. The problem with that and with useCallback, however, is that with useCallback, we're telling React to store that function and exactly that function somewhere in memory. Now, when the app function is re-evaluated and re-executed because the toggle state changed, then React will not recreate this function because we're using useCallback where we told React that we don't want to recreate it under all circumstances. So therefore, the allow toggle value React stored for our function is still the old allow toggle value from the first time the app component was executed, not the most recent one. Because JavaScript, as I just explained, stored allow toggle, this constant, when it created that function here. And that's of course a gotcha here, that's a problem. There are cases where we actually want to recreate a function because values being used in that function that are coming from outside the function might have changed. And here we have such a case. So here we would want to add allow toggle as a dependency in our dependency array. And that tells React that we generally want to store that function. But whenever allow toggle changes and it has a new value, we want to recreate that function and store that new recreated function. And this ensures that we always use the latest allow toggle value inside of that stored function. If allow toggle does not change, however, then we don't recreate the function. And with that, if I save this, if we go back, now if I click toggle paragraph, nothing happens initially. However, if I now click on allow toggling, now we'll see that if I now click toggle paragraph, we do get our paragraph and all the expected output. It's also worth noting, of course, that for toggle paragraph, we see button running, but we only see it once. And that's actually our second button where React Memo has no effect because we're not using useCallback on the allow toggle handler. We would see it twice if the button for toggle paragraph would also be re-rendered. But that's not the case because our useCallback call here ensures that we're not rebuilding this function every time. We only did that once when allow toggle changed. Now I know these are concepts that can be confusing. In the end, it's not so much React though, it's more JavaScript. And you have to understand how closures work, and you have to understand that primitive reference value concept. If both is clear, it's absolutely clear how React works. And I hope that this and the last lectures could help you understand that and made it clear how use callback works, how functions are re-executed, and how React Memo works and how that works together with use callback. So now, before we proceed, let me sum up what we just learned, so that this is all really clear because it is important. In React apps, you work with components, typically with function components in modern React. Those components have one job in the end, and that is this JSX code which they return. This tells React what the output of that component should be. Now, in your React components, you can work with state, or with props, or with context, though props and context, as I mentioned, all come down to state changes in the end, to make changes to a component and to make changes to the data that affects this component or that affects parts of your application. Whenever you change state in a component, that component where the state changed is re-evaluated, and that simply means that the component function is executed again. So all this code runs again, and therefore we get a new output. This might actually be exactly the same output as before, but it could also look different. For example, if suddenly a paragraph is rendered or not, or as in the case of the demo output component, if the text is rendered or not. React simply takes the result of this latest evaluation and compares it to the previous evaluation's result. And it does that for all affected components. And then it hands off any changes, any differences it identified to, in our case, React DOM, because we are using React DOM to render our React app here in the index.js file. And React DOM will take those changes and apply them to the real DOM in the browser. And really only those changes, nothing else. Now, when React re-evaluates a component, it does not just re-evaluate that component, but since it reruns the entire function and therefore also rebuilds this JSX code, rebuilds the output for this latest snapshot, so to say, it will also rerun all components that you have in this JSX code. Like in this case, it will rerun the demo output and the button components. Now, to avoid unnecessary re-executions of child components, you can use React Memo to tell React, hey, please only execute this component function again if the props really changed. So if we got real new values in there. If we got no new values, please don't re-execute this function. Now, since re-evaluating a component means that the entire component function runs again, that can have strange effects if you're not aware of the fact that this really means that everything in this function runs again. And therefore, if you, for example, create functions in the function and you pass those functions through props to other components, you will indeed get a new function object, and even React Memo will then not be able to help you because objects are reference values and comparing them with equal signs, which is what React Memo does under the hood, will not work. For primitive values, you will therefore not have that problem. That's where use callback comes in and can help you, because with use callback you can tell React that it should store a function and not recreate it when the surrounding function runs again, as long as certain dependencies didn't change. That is what we learned thus far. Now, there are a couple of open questions though. For example, if the app function runs again whenever the state changes, doesn't this mean that we all the time reinitialize our state? Because we also execute use state over and over again then. Why is this not causing problems? Well, it's questions like this and general state-related questions that we're going to dive in next. Obviously, state is a crucial concept in React. Ultimately, everything comes down to state when it comes to re-rendering components and changing what's on the screen. So therefore, components and their interaction with state, that is really a core aspect of React. And it is worth noting that both, of course, is managed by React. This components concept comes from the React library, and React also takes care of your state that is attached to components. It takes care, for example, by using the use state hook, and that's how this interaction between components and state is handled. Speaking of that, one of the most common forms of managing state is to use the useState hook. With that, you create a new piece of state, you could say, and you automatically attach it to a component, the component in which you call useState. This attachment, kind of, is done behind the scenes by React. Because when you call useState, React behind the scenes creates a new state variable, you could say, which React manages for you, and which React also for you ties to this component. Now, I mentioned at the end of last lecture that it's strange that even though we call useState every time the app function runs again, we don't seem to lose or reinitialize our state all the time. The reason for that is simple. useState is coming from React. And I just said that React is managing the state and the connection to the component for you. And as part of that management process, React makes sure that useState and the value you pass as a default value to useState essentially is only considered once. The first time ever a component is rendered, so the very first time the app component runs, useState, when executed, creates a new state variable, which is handed off to React and which is managed by React. React then basically memorizes to which component that belongs, the app component in our case. And it uses the default value to initialize the state with that value. For subsequent app function calls, so for re-evaluations of the app component, when useState is being called, no new state is being created. Instead, React recognizes that it already has a state for this component, and it instead simply updates that state as needed, because the app function reran because some state changed most likely, and therefore React will only do that state management and updating. It will never reinitialize the state unless the component was totally removed from the DOM in the meantime, which in case of the app component will never happen since it's our root component. For child components, if it's rendered conditionally, for example, a component might be removed, and in that case, if it's then later reattached, a new state would be initialized. But as long as a component stays attached to the DOM, state is only updated after that first initialization. That's one important note to take, and of course the same is true for a useReducer, for example. Now that's not all you need to know about state though. We know how React manages state, or at least we have an idea, but there's one thing which is important, which I mentioned before, but which I now want to emphasize again, and that is how React handles state updates. In your code, you might have a component, and in that component you might manage some state with help of the useState hook. And therefore, React in the end manages that state for you. Let's say the initial state for this product component is DVD. So we have a DVD as a product here. Now, eventually, because a user clicked a button or whatever, in that component we update that state. For example, with setNewProduct, that could be our state updating function returned by the useState hook, and we set the new product to book. So from DVD to book. Now what happens with that is not that DVD is instantly, after setNewProduct finishes execution, is replaced. DVD is not instantly replaced just because setNewProduct is done running. Instead, calling setNewProduct and calling those state updating functions in general schedules a state update with the data book. But that's now a scheduled state change. React is aware of it, React plans on processing it, React doesn't process it immediately though. Now, in reality, most of the time, state changes, scheduled state changes, will be processed very fast, pretty much instantly. So in reality, it might feel instant. If we click a button and that removes a paragraph, to us as a human, that happens instantly. But React reserves the right of actually postponing that state change. For example, because a lot of other performance-intensive tasks are going on at the same moment, potentially tasks that React considers to have a higher priority. Let's say on your screen you have an input field where the user is able to type something. Reacting to that user input would have a higher priority than changing some text on the screen. And for reasons like that, React might postpone scheduled state changes. Now, what React does is it guarantees you that the order of state changes for one and the same type of state is guaranteed. So if we call setNewProduct again and we set this to, let's say, carpet or whatever, then this state change would not be performed before the previous state change. So the order is kept, but it's not necessarily executed immediately. Eventually, of course, it will be processed and your new state will be booked. And once that new state is active, once that state change was processed, React will reevaluate the component, it will rerun the component function. Now, because of that scheduling, where of course you might have multiple outstanding scheduled state changes at the same time, because of that, because multiple updates can be scheduled at the same time, because of that, it is recommended that you use this function form for updating your state if you depend on the previous state snapshot. In a lot of cases, this will probably not matter because it's processed so quickly that you can't even click fast enough to see a delay. But because it theoretically could be postponed, this is the safe way of ensuring that state changes are processed in order, and for every state change where you depend on the previous state, you get the latest state. Otherwise, you might just get the latest state when the component function was executed last, which is not necessarily the same state as if the state changes are executed in order. Because if you have multiple outstanding state changes, they all come from the same last re-render cycle of that app component. They all come from that last component snapshot. But of course, if they were processed, the component would re-render in between. But since they're all already scheduled, all outstanding states changes don't take that new in-between component result into account. That's why this function form is helpful, because there, React will actually ensure that for every outstanding state change, it looks into the latest state and gives you that, and does not use the latest state from the last time the component was re-rendered. That's an important difference between when the component was re-rendered and when a state change was scheduled. You can have multiple outstanding state changes from one and the same component re-evaluation. That's the key takeaway here, and that's why this matters. That's also why in the last non-project module, where we initially learned about useEffect and so on, it was safe to actually update our form validity based on the email and password is valid states inside of useEffect. Because just like using the function form for updating a state based on a previous state snapshot, useEffect actually, because of its dependency mechanism, is ensured to rerun the effect here every time a state or a value, which is a dependency, changed. And therefore, you can't miss outstanding state changes, because here it will simply rerun this effect for every time the component was re-executed, the component function was re-executed. It will thereafter always rerun the effect, and therefore you are also guaranteed to get the latest state when doing it like this. So these are simply two different patterns for dealing with one and the same problem, you could say, depending on what you're trying to achieve. Here we want a state update that depends on some other states. In this case, on the other hand, we want a state update that depends on the same state, just a previous snapshot of that state. So that state update scheduling is a mechanism you have to keep in mind. Not because you actively need to do something about that. React manages those scheduled updates for you, but because you need to write your code accordingly to rule out any danger of potentially working with outdated data. You rule it out when using that, you rule it out when working with useEffect. Now, there is another important thing you need to know about state in React. There, we actually have this nav context, and in the navigate handler, I do something which you see a couple of times throughout this course. I call two state updating functions after each other. Now, we just learned that just because you call such a function does not mean that in the very next line the state was updated. State was not updated here. Instead, we just learned that the update will be scheduled and eventually the entire component will rerun, so this component in this case, and then once this component reran, then we have the latest state available, not earlier. Now that's what we learned. Now here, however, we have two state updating functions after each other. That clearly means that two state updates will be scheduled. Does this, however, also mean that the component will be re-executed, re-evaluated twice? You could imagine that this happens, but that's actually not what React does here. Instead, if you have two state updates in the same synchronous code snippet after each other, so not in a promise in different then blocks, but in the same function, for example, where nothing in between would cause a time delay or anything like that. So if you have two synchronous lines of code after each other, where you then call a state updating function, in such cases, React will batch those state updates together. In one long synchronous process, so for example in one function that executes start to end without any callbacks or promises in between, in such cases React will take all the state updates that are produced by that function and it will batch them together into one state update. So back in this picture, even if we would not just update the new product here, but if we would update something totally different in the same function, we would still just have one scheduled state change, which then, however, just changes two different states. But it's one process. It's not two scheduled changes with two upcoming component re-executions, re-evaluations, but instead it's one scheduled change where all the different states you might want to affect are simply batched together. So state batching is another important concept you have to be aware of when working with React. So we learned about use callback. Attached, you find a new mini example where I also want to dive into another hook that helps us with another optimization we could add. Here we have use callback to basically store a function to not recreate it. This is a function which I pass to the button through the onClick prop. The button internally uses React memo, and because we store that function with use callback, the button will never re-render in this case, because its props never change, and React is aware of that. Now I'm also rendering a list here, and the interesting thing is that the list is sorted. It's sorted in an ascending way. Now, the data which I put into the list is not sorted, it's in random order, as you can tell here. So that means that, of course, obviously in the list we're doing some sorting. And indeed, here I'm sorting my list with this simple built-in sort method, to which I just pass a function that defines how the sorting should happen. You can look up the sort method documentation if you want to learn more about that. And that gives me my sorted list, which I then output. Now, the thing is, sometimes in your code, sometimes in your components, you might have logic like this, which could be a bit more performance intensive. Obviously, that's a short list, sorting will be quick, but for longer lists or simply for other tasks, you might have some code which takes quite some time. Eventually, this code of course needs to execute, but you certainly don't want to run this code every time the entire component is re-evaluated. Now, of course, we learned what we can do to avoid unnecessary re-evaluations. We can use React memo here, right? With that, we can wrap the demo list. And with this shouldn't run unnecessarily. If I now console log demo list running here, we see that of course it runs initially. That means the list was sorted, but thereafter it shouldn't run again. Well, actually I have this button. When I click it, I change the title here. And the title is part of my list here. Therefore, when I click the button, demo list runs again, and it needs to run again because one of its props changed. The title changed. It has a real different value there. So React memo is not failing. It needs to rerun in this case. Now, as a side note, of course, currently it would always rerun when the parent component re-renders though, because at least this array here is constantly recreated in the parent component whenever the parent component runs. So even if the title would not change, if the parent component would rerun for some other reason, the demo list component would be re-executed because we always generate a new array, like functions, arrays are objects, objects are reference values, and therefore two arrays, even if they have the exact same elements in the same order, are never the same, because they occupy two different places in memory. But here we don't even have that problem, but instead, as I just explained, because the title changes, we have a valid reason to rebuild demo list. So sometimes the component reruns is re-evaluated, and still you might not want to repeat every bit of work you did there in the past, especially if the work you would have to redo is more performance intensive. And sorting is one of the more performance intensive tasks you can do in your components. So, is there a solution to that? Yes, there is. We have use callback to store function objects and only rebuild them when some input changed. We have something similar for all other kinds of data. And that is another hook which we can import, the use memo hook. Use memo basically allows you to memoize, so basically that means to store any kind of data which you want to store, just like use callback does it for functions. And here we could memoize, and yes, that's memoize, not memorize. These are two different terms, but it's pretty much the same here in this context. So you can memoize the result of this sorting here, simply by calling use memo here, and now use memo as a first argument wants a function. That is, however, not a function that will be memorized. Instead, that function should return what you want to store. So in this case, it should return that sorted array. Now, just like use callback, use memo wants a second argument, which is an array of dependencies. Basically, to ensure that this stored value is updated whenever one of the values you're using in there changes. And in this case, indeed, whenever items changes, whenever we get new items, we want to resort them. So items are a dependency here. We could add props here, because items are pulled out of props. But that means that the entire props object is our dependency, and therefore this would essentially always recalculate. So a more elegant way is something we used on useEffect and its dependencies earlier in the course. We can use destructuring to pull something out of props, in this case, to pull the items out of props. And then we can just add the items here as a dependency and use just items here for sorting. And now this will only rebuild this if items changed. Now let's see when that happens. For that I can add a console log here, items sorted. Let's see how often this runs. If I reload, we see it runs initially, of course, but it still also runs when I change the title. Now the idea was that it shouldn't run there. Why is it running again then? Well, because items indeed changed. That's what I mentioned earlier, a few minutes ago. The items here actually are always recreated when app reruns, because we always create a new array here. So even if it's technically a similar array with the same values in the same order, it's still technically a new array in memory, and that is treated as a brand new object which isn't the same as the old array, even if it contains the same values. That's this reference value thing I mentioned a couple of times throughout this module already. So to ensure that we don't unnecessarily pass a new array here, we can of course also use memo here. We simply import use memo, and then here we can wrap it, add this function which should return this array, and add our dependencies, which here is an empty array. We got an empty dependencies array here, because here this of course never changes. It has no external dependencies. It's all hard-coded in here. So therefore now we also call use memo here, and of course we can also pull that out of there and say list items is the result of calling use memo, and then we pass list items here to items. And with that now we should not unnecessarily sort the list again. Now we see items sorted initially, but if I click change list title, we don't see it again because of use memo. Now, I will say you will use memo far less often than you use callback, because memorizing functions is much more useful, and you need that more often than memorizing data. You essentially want to memorize data if it would be performance intensive to recalculate something based on it. Otherwise, it might not really be worth it, because you always have to keep in mind that if you store data with use memo, Of course, that occupies some memory, and of course, this storing functionality also takes up some performance. So this is not something you want to use on every value you're using. If you got a scenario like this one here though, where you want to sort something, then it might be worth a look, because then using useMemo and avoiding unnecessary sorting steps in future component updates, that might be very well worth it. Now, throughout this course, of course, we'll see more examples, and therefore throughout this course alone, you will get a better feeling for when you want to use what. In this module, I just want to put all those things out there and explain them so that you understand them and so that you are aware of them. When you use them, always comes with experience, depends on your preferences, your exact use case, and there also isn't a clear right or wrong. It's just something you should be aware of so that you can look into optimizations like this if you find out that your application is slow or that you want to improve some parts of your application. In this course section, we are going to learn how we may build components in React. Well, wait a second. Isn't that something we've learned in depth until now already? Well, we did, but there is an alternative way of building components. Besides building components as functions, which is what we did up to this point, you can also define components with classes. You can build class-based components. But I got one important note right away before you feel overwhelmed. This is 100% optional, and in most modern React projects, you are probably not going to use this approach. You can therefore skip this section, but I want to emphasize that you will see a lot of class-based components out there in the wild, in third-party libraries, or in projects you might be working on, because traditionally, not too long ago, you had to use class-based components in certain cases. This is no longer the case, but I will explain all about that throughout this section. I will explain what exactly class-based components are and why they exist. We will learn how we can build class-based components and how we can work with class-based components. And we're then also going to have a look at error boundaries, and at least this is something you should at least take a mental note to come back to, because error boundaries right now require class-based components to be built. That being said, you will not build a lot of error boundaries, but still, this module holds important information about React's past, about an alternative way of building components, and most importantly, of course, why that way exists and how it works. Now, as I mentioned in the last lecture already, class-based components exist and they are an alternative to functions. Up to this point, when we built components, they looked something like this. Of course, instead of the function keyword, we might have used const and stored an arrow function in there, but either way, we simply built a function. That is what we did. And we built a function that receives props and then returns the JSX code that should be rendered to the screen. This is what components are in React, and they are simply regular JavaScript functions which return some renderable results, typically JSX. This is what we refer to as functional components, which is a term I also already used a couple of times. Now, this term exists because it's not the only way of building components. If it would be the only way, we could just call it components, right? But we call it functional components because there is an alternative way of defining components, not of using them. You always use them as custom HTML elements in your JSX code, but for defining them, there is this alternative. You can define a component by creating a class, which is a default JavaScript feature. Classes are not a React feature. Classes exist in modern JavaScript. And you can define a class with a render method, and that is a reserved name, render. It has to be named like this. And then React will call that render method to evaluate what should be rendered to the screen. So this is an alternative way of defining components, and that is what is referred to as class components or class-based components. Now, I will emphasize the left approach using functional components is the default and most modern approach of building components these days. And in most modern React projects, you will therefore pretty much work with functional components only. You might never build a single class-based component there because nowadays, with the exception of error boundaries, which we'll have a look at later, there is no reason to go for class-based components. Except for personal preferences, of course. You can simply prefer class-based components, and that would be absolutely fine. You can build anything, you can build with functional components, with class-based components as well. It just requires a different mental model in some regards and some aspects. Now, the class-based components exist because they were required in the past. In the past, which means prior to React 16.8, there were scenarios and use cases where you needed class-based components. Specifically, when dealing with state and with side effects, you had to use class-based components. Traditionally, prior to React 16.8, you could not change state in functional components, and you couldn't really handle side effects there either. That changed with React 16.8 because that React version introduced a concept called React hooks, which are all these hooks, these functions starting with use state and use effect, and so on. These are functions for functional components which bring features to functional components which previously were reserved for class-based components. And indeed, class-based components can't use React hooks. That's also important. That's really important. What you learned about React hooks up to this point, it does not matter at all when working with class-based components. But now in the next lectures, I'll show you how you can convert functional components to class-based components, how you can manage state there, and also how you translate use effect and use context and use reducer to the class-based component world. Now, to dive into class-based components, I got another starting project for you. And you'll find it attached to this lecture, of course. Simply download it, extract it, run npm install and then npm start, and you will see this simple demo app here. Here we got a button where we can toggle this list of users. Now, that's all not too fancy, and it's simply built by, in the end, using two components and the app component. We got the users component with some dummy users, and there we got the toggle user handler function. And then in the end here, we simply create our list of users by replicating the user component. And we got a button which triggers that function, which changes the state with use state, which controls whether that user's list is visible or not. And inside the user component, I simply render a list item with some styling, and I'm using props. So that's all not too fancy, and that's of course all something you learn about throughout this course. Now let's learn how we could write this user component as a class-based component. So how we can transform this to a class-based component. And for this, we start with the class keyword, which again, just to make this really clear, is built into JavaScript. It's not a React concept. Modern JavaScript supports classes. Now here we would define a class named user, and when we define a class in JavaScript, it looks like this. class, then the name of the class, and then curly braces in which we define the class now. And inside of these curly braces, we can now start adding methods to this class. For example, we can add a constructor method. Here we could do some initialization work, and I'll come back to this in a second, but actually I got no initialization work in this component, so I will just remove the constructor. Instead, we should add a render method. Now, theoretically, we can add as many methods as we want to a class, and we can name them however we want. Render just is a specific method expected by React, which React will call when it finds a component being used in JSX code, like we're doing it here. And then React will call the render method to find out what should be rendered to the screen. So the render method in a class, in the end, is your equivalent to your return statement in a functional component, you could say. And in the render method, you then also need to return the result that should be rendered. So that's now how we can rebuild this. Though one important thing is missing here, and that would be the props. In the function component, we receive props as a parameter, automatically passed in by React. In the class-based component, that's not the case. Here, the render method does not receive props. Instead, though, we need to do something else, not just for props, but to make the class-based component work in general. We need to import component from React. And then we need to extend component here, which is also a built-in concept in modern JavaScript. You can build classes which extend other classes, so which inherit from other classes. And now our custom user class inherits from the component class, which is defined by React. Now, this component class adds important functionality to make your class work as a component, and that's the important part for us now, it also adds a couple of important properties. For example, the props property, which we can now access with this props. This is only possible because we extend component. Because of that, there will be a props property in our class, which we can access through the this keyword. And that contains all the props data we received for our component. And now we got the class-based equivalent to our functional component, which we can now remove or comment out. And I'll do the latter so that we still see both in side-by-side comparison. As you can tell, the functional component is a bit leaner, which is one of the main reasons why they are more popular. But other than that, it is the same now. We also still export user, and now we can save this, and if I reload, we get the same app as before, and it works and looks like before. And that is also a very important takeaway here. Class-based components can work together with functional components. Users is a functional component, but it renders user, which is a class-based component. And that is absolutely no problem. A class-based component could also render a functional component. That would also work. In the end, these are just components, and you can mix and match them as you want. In reality, you will most likely build a project by either sticking to just functional or to just class-based components though. You can mix and match, but that will mostly matter if you are working on an existing application and you're adding new features, and you maybe also step-by-step migrate from class-based to functional. If you're starting a brand new project, you will probably go with your favorite approach, whatever that is, and then stick to it. But you can mix and match it. And that is how you build class-based components. Now, however, I did mention that we had to use them in the past when it came to managing state, like we're doing it here in the users.js file. Therefore, let's find out how that works with class-based components now. So let's now convert this users component to a class-based component. For this, we again should import something from React. Let me restructure these imports. We should import component from React, because we now build our users component by creating a class named users, which extends component. That's what I explained in the last lecture, and that's how you always build your class-based components. In there, we can now add a render method. And in that render method, we return the JSX code that should be rendered. So I'll copy this return statement and bring it into my render method. Now we learned that we can access props with this props, but here I'm not working with props. Instead, I'm relying on state, and I am pointing at a function that should be executed when the button is clicked. Now let's start by adding that function. In class-based components, you now don't add a function inside of the render method, though that would technically be possible, but it wouldn't behave correctly. But instead, since this is a class, you group together functionality by grouping it all in that class. So you would simply add a method named toggle users handler, like this. There are also alternative ways of writing a method in classes, but this is the most default and standard way of defining a method. Now we have the method, but we don't have the state. And managing state worked totally different in the past with class-based components. With React 16.8, hooks were introduced, and we could use the useState hook to manage state in functional components. And it is very simple to manage state then. Prior to 16.8, class-based components were the only kind of component that could manage state, so you always had to write class-based components when you needed state. And there, you basically needed to do two things: initialize and define your state, like we're doing it with useState when we first call it, and then update it when needed, like we're doing it here in the toggle users handler. Now, to define state in class-based components, you would use the constructor. The constructor function is automatically called whenever this class is instantiated, which happens when React encounters your class being used as a component. And then in the constructor, you can do initialization work, like initializing state. And this would be done by accessing this state and setting it equal to an object. And this is super crucial now. With class-based components, your state always, important, always is an object. With functional components, your state can be anything. It can be just a Boolean, just a string, just a number, but it can also be an object. But it's flexible. It can be anything. With class-based components, that's not the case. Here, your state always is an object. Because with class-based components, you always group all the state slices and pieces you might need in a component into one state object. With functional components, instead, if you have multiple state pieces, you could use multiple useState calls. You could also create just one state object and group it together there, but that is optional with functional components. And I do talk about that in the state course section. With class-based components, this is not optional. There you have to group all the state that makes up a component into one object, no matter if these state pieces are closely related or not. So here we would then have our show users state and set this to true initially, let's say. And if we had more state, then we would simply add this as an extra property. You can, of course, also have nested state. You could have a nested object. You can have erase a state, that all works. But you have one state object which groups it all together. Then if you want to change your state, like in toggle users handler, you don't do this by accessing this state and changing it like this. That's not how you do it. Instead, you call a special method, setState. This setState and this method on this class is of course also provided by the component class we're inheriting from. This setState then also always takes an object. And this object now contains the new state you want to set, but very important, it won't override the old state, but instead React will, behind the scenes, merge the object you're passing here with your existing state. So if I had another state here, which I don't need here, but if I had that, and I then would set show users to false, show users would be set to false, but the old state would be kept. The other state would be kept because React merges this update with the existing state. It doesn't overwrite the state. And that's different with useState. Here, when you call the state updating function, you always override the old state with whatever you pass to the updating function. Unless it is a function, in which case React executes that to derive the new state. But you override the old state. It's not merged automatically by React. If you would want merging, because you are managing some state object, you would have to write the logic for this on your own. With class-based components and setState, that's different. There, React merges this for you. Now here, of course, I don't always want to set this to false. I want to set it to the opposite of what it was before. And therefore here, setState, just like the state updating function from useState, also supports such a updating function. So here we can also pass a function to setState, alternatively to the object with the new state. And we should do that if our new state depends on the previous state. Nonetheless, it's not enough to just return a new state value like this, because here I would be returning something invalid because our state is an object. Instead, here we have to change this a little bit and return a new object, just as you have to pass our object to setState. If you use that function form, you have to return an object. And there I set show users to curState show users and invert that. And again, what we return here will be merged with the old state. So this second state piece here will not be lost. And that's how we update state. Now to use it, we go down to the render method where I need my state. And here we can now access this.state.showUsers to access this state object and then the showUsers property, which we set up here and which we manage and update here. And we do this in all the places where we need that state. Now, of course, I also want to derive the users list. Therefore, I'll grab this constant here and add this to my render method. Because we still can, of course, define helper constants like this in the render method. That all is valid and works. One last thing is missing though, and that's this method here. I added the toggle user handler method, but you don't call it by using it like this. Instead, it's a method of this class here, and therefore we need to point at this toggle user handler to point at this method part of this class. But even that wouldn't work due to how this works in JavaScript. And that has nothing to do with React. The this keyword can simply be tricky in JavaScript. Attached you find a resource which allows you to learn more about this. What you need to do in the end is you need to make sure that the this keyword inside of your method refers to the surrounding class. And it wouldn't by default when your method is called upon an event like that, like the click. So to fix this, we can, for example, use bind and bind this, which simply means that this keyword inside of this method here is now set to have the same context or the same value as the this keyword when this code is evaluated. And here the this keyword will refer to this class. Again, this is just related to how JavaScript works. It is not required in the functional component world, because there we just define a function right before we point at it. There we don't use the this keyword at all, because we're not working inside of a class. With that, we can again remove the functional component or comment it out, and then save everything. And now, if I reload, we get an error. Must call super constructor in derived class. That is indeed true. When you add the constructor to your class and you extend another class, you need to call super, which calls the constructor of the super class, so of the class we're inheriting from. And with that, if we reload, this works, and it works as before, now with class components only. So as you can tell, it's simply a different way of writing your components. Of course, now we can also get rid of the use state import because we're not using it anymore. And as mentioned before already, you also can't use it in your class-based components. None of the React hooks can be used there. Now we know how we can generally build class-based components and how we can manage state and work with events there. But what about side effects? As I mentioned, you can't use these React hooks in class-based components, so you can't use useEffect. But class-based components have a concept called the component lifecycle. And of course, every component technically has a lifecycle. It, for example, is rendered to the DOM or removed from the DOM. But there are specific methods you can add to class-based components to run code at different points in that lifecycle. And the first, most important lifecycle method you can add to class-based components is the component did mount method. Like render, that's a built-in method which you can use as soon as you extend the built-in component which you import from React, and then you can add this method and React will call it for you when the component was just mounted, but more on that in a second. Other lifecycle methods you can add would be component did update and component will unmount. There are a couple of other less important lifecycle methods, which we'll not take a closer look at here, because these three lifecycle methods are by far the most important and common ones. Now, as I said, component did mount is called when a component is mounted, so when it was evaluated and now rendered to the DOM. It's basically the equivalent to using useEffect like this. You have your effect function, which I left out here with the 3 dots, and then you have the array of dependencies. And every effect function is executed when the component first is mounted. But if you have no dependencies, if you have an empty dependencies array, the effect function is only executed in that case. So adding useEffect with an empty dependency array is basically your equivalent to component did mount. And we're going to see component did mount in action in just a second. You also have component did update. This is called once a component was updated. So when something changed, when your state changed and the component was re-evaluated and re-rendered. This is basically your equivalent to useEffect with some dependencies. Whenever the dependencies change, the useEffect function re-executes. And the dependencies are re-evaluated when the component is re-evaluated and was rendered again. Because you learned that the effects are generally re-executed whenever a component re-rendered, if dependencies changed. So that's why this is basically your equivalent to component did update. Now, component will unmount is called right before the component is removed from the DOM. And here, the equivalent is basically the cleanup function from useEffect. That cleanup function is called right before the effect function is executed again, and also always again when the component is about to be removed from the DOM. Now again, let's take a closer look at that in action here. And for this, I altered the project slightly. Attached, you find the user finder component, which you can add to your components. And now we need to go to the users component and there get rid of the dummy users here. And instead here, where we used the dummy users, refer to this props users. Because users are now passed in through props into this users component. And now we just need to go to the app component and use the user finder component and import user finder from components user finder instead of users. Also add the user finder.module.css file, which you also find attached. And if you added all of that and you save this, you should see an application that looks like this. And here, if you type, you now also filter this list down there with every keystroke. It's a very simple filter logic, which I added here in the user finder. And the user finder component is a functional component using multiple state slices and useEffect to manage the users and to then filter the users and pass the filtered users to the users component. Now let's transform this component to a class-based component to get an idea on how these class-based components deal with side effects. Now to convert the user finder to a class-based component, I will again import component from React and then define a class named user finder, which extends component, of course. Now in here we need a constructor because we got some state which should be initialized by setting this state to an object. Now here I actually got two state slices, the entered search term and then the list of users, and therefore I'll add my filtered users here and set that equal to dummy users, and then add my search term and set this equal to an empty string initially. Next, we got a function here, the search change handler, which I'll implement as a method in the user finder class, because that is then the function, the method that should be executed to update the state. At least a part of the state. It should update that search term. Now we get the event object here because this is bound to the change event on the input, and we then use the event object to read the value entered by the user, and therefore we can expect this event object here as well to then set our state, important, here always to an object, which is then merged by React, and update the search term part of that state to event target value. And only that part. Again, it will be merged, so the filtered users won't be lost. Of course, we also need to add a render method where we should return our JSX code. So I'll grab this return statement and add this here as well. In here, I should point at this search change handler, and also, to ensure that the this keyword works correctly in the method, bind this as explained in the last lectures. And here for the filtered users, we should refer to this.state.filtered users. And with that, we transformed this component, at least almost. One crucial part is missing, and that would be the useEffect function here, which we can't use in a class-based component. Now we could derive our filtered users and set them in our state update here in the search change handler. That would be possible. But I want to show you how these lifecycle methods work, and therefore I'll use an alternative approach. We can add component did update here, and this method will be called automatically by React whenever this component is re-evaluated because its state changed, for example. So therefore in here, we could set our new state for the filtered users. So here we can copy this logic from the user finder functional component and call this set state to set the filtered users equal to dummy users filter and so on. However, if we would do it like this, we would create an infinite loop because component did update is now executed every time this component changed. When we set the state, the component will change. So then this will execute again, and it will change the state again, and it will execute again. You get my point. This would be an infinite loop. Therefore, what we need to do is we need to check whether the state we're interested in changed. In this case, if the search term changed. For that, component did update receives two arguments which help us: the previous props and the previous state. So the last props and state snapshot before the current component update. And with that, we can check if priv props search term was different than the current search term. So this state search term. Only if it is different, so only if the search term changed, I want to execute this logic. If something else changed, like for example the filtered users, which we are updating here by calling setState, this method component did update will run again, but we won't make it into this if block. So we won't update the state again, and we won't have an infinite loop therefore. Here, by the way, it should also be this state search term. And now with that, we replace useEffect with component did update. This also shows you how nice useEffect is. It's very short, and by specifying the dependencies here, we don't have to add an if check inside of it. We need to add an if check here for component did update to prevent an infinite loop, but we don't need to do this with useEffect because we specified search term as a dependency. So automatically, this effect function will only be executed by React if that dependency changed. And other changes and other reasons for this component to re-render are ignored for this effect because of this dependencies array. Now, one thing I just noticed, by the way, of course, I don't want to compare prev props, but prev state. The previous state search term should be compared. If you would be updating based on prop changes, so you got some new prop values and you wanna, and the component therefore updates, then you could compare previous props to current props. But here it's the state change which matters to us, the state change inside of this component, and hence we compare our previous state, a specific slice of that state, with the current state and that specific slice of that state. Now we should also add super in the constructor, by the way, before we forget this. And now we transformed this component, and we can hence remove user finder in the functional form or simply comment it out. And now if I go back, this again works as before, but now with class-based components and component did update. And as I mentioned before in this module, it's a different mental model. When you work with these lifecycle methods, you primarily think about when will this method be called, which is the case when the component updates. And then you might need to add if checks to restrict your logic in there. With useEffect, you don't care about whether the component is rendered for the first time or if it updated or whatever. You care about the fact that search term changed. And whenever that changes, you run this logic, which is a very simple mental model in a positive way. Nonetheless, you could use component did update instead, as you saw here. Now, besides that, we also got other lifecycle methods, most importantly, component did mount and component will unmount. Now, let me show you these lifecycle methods as well. Let's say our dummy users are loaded from a server, from a database. So we're sending an HTTP request. We're not doing that here, but let's imagine we're doing that. So initially, filtered users might be an empty array. Then, when the component is rendered for the first time, we want to send a request to the server. Hence, we can't use component did update in this scenario because I don't want to fetch the users over and over again. You might need to do that in other apps, but not in this imaginary example. Instead, we want to fetch the users when this component is rendered for the first time, and that is something we would typically do with component did mount. You add component did mount like that, and then in there you could send your HTTP request and handle all of that, and eventually you would update your state and set your state, in this case, to set filtered users to dummy users, which might have been fetched from some server. Again, it's just a dummy example here. That's what you could do. We don't need an if check here because component did mount will only run once when the component initially was rendered for the first time. If it then is updated thereafter, component did mount will not execute, instead component did update will execute. So therefore that's how we could write this, and if we do, we essentially got the same result as before, but now we're loading this when the component is mounted. The equivalent to that in the functional component world would be to call useEffect with no dependencies, or even with dependencies, it would execute this function when the component is mounted for the first time, because it treats the dependency as to have changed if we had no dependency before, because the component wasn't rendered, and now it is rendered, and therefore we do have this dependency. So the useEffect function will also always execute when the component is initially mounted. Now, last but not least, we have component will unmount, and I can show this method in the user component, because the list of users is rendered conditionally, so it is actually removed if I click hide users. Therefore, in the user component, which is also a class-based component, I can add component will unmount, and in there I'll just console log user will unmount. And if we now save this and go back and open the developer tools here, like this, if I click hide users, you see user will unmount 3 times. Why 3 times? Because we used the user component 3 times. We rendered 3 users in the end, and all 3 instances of that component were removed, and all these lifecycle methods run for every component instance, of course, just like useEffect and state work for every component instance standalone. And these are the lifecycle methods. It's a different mental model, but in the end, with it, you can of course achieve the same as you can with these React hooks, with useEffect and so on. It just is a bit more code, and it could be the more difficult mental model. Now, what about context and class-based components? Well, the first important takeaway is that you can still define it and provide it as you learned it. You define it by calling create context, maybe with some initial value, and you then provide it by using the provider component, which is part of that created context object. And then you can pass a value to that, and here it's actually a static value which never changes, but it also may change with state updates, and that all doesn't change. Only the way you update state, of course, changes if you use a class-based component, as explained over the last lectures. As a side note, if you want to follow along, attached you find the updated app component and this user's context.js file, which you can add into a newly created stored folder. But back to that. Here we provide as we learned it. The only part which changes when you're working with context is related to how you use it in your class-based components. Now, I haven't added any code for using context up until now, so therefore let's go to the user finder and think about how we could add it there. There, let's say, I no longer want to work with the dummy users defined in this file. I no longer want to get my data from there, but instead I want to get my data from context because it's managed application-wide. If this would be a functional component, we would of course use the use context hook for that. That's what we would do. But this is not an option here in the class-based component because we can't use hooks there. Instead, here we got two ways of using context. One approach was shown to you earlier in the course already. The context consumer component can be used in both functional and class-based components. So in your render method, you could import the user's context, so add it here, and of course import it from the user's context file, and then simply add that consumer or access this consumer component and then use it as shown to you earlier in the course. Since this is used in JSX only, it works in both functional and class-based components. But the use-reducer hook is used so that we don't have to use this consumer component. So what's the equivalent to this? There is no perfect equivalent. I will say that right away. With use context, you can listen to multiple contexts in one and the same component by calling use context multiple times and pointing at different contexts. This will not be possible with class-based components because there you can only connect a class-based component to one context. And you do that by adding a static property, by adding the static keyword here, and then adding the property named context type, written like this. And then you assign a value of user's context here. With that, you're telling React, hey, this component should have access to the user's context. But you can only set the static context type property once. So if there are two contexts which should be connected to one and the same component, this would simply not be an option. You would have to find some other workaround, like wrapping it in another component or anything like that. With that set, however, you can then simply access this context users in this case, in all the places where you need access to the users. And with that, it will again work as before, as you can tell, but now with context. So it is also quite straightforward to use, but a bit less flexible than in the functional component world. Of course, you will not always need more than one context per component. Often one context is enough, but if you do need more contexts connected to one component, then this restriction can of course hurt. Now that's it for this introduction to class-based components. I showed you that they exist, how they work and how you write your own ones, how you work with props and the render method, how you work with state, and also how you work with these lifecycle methods for side effects. And we also had a look at how you use context. You can build your entire application with class-based components if you want to. That is absolutely fine. And in the past, as I mentioned, you had to use them in some cases. But in modern React apps, you typically stick to functional components instead, simply because they are leaner and more flexible, as you learned throughout this module. That's why I also started with functional components in this course now, because the React ecosystem transitioned to functional components as the main thing, and that's why I focus on functional components in this course. Also going forward, for the rest of this course, functional components will be the focus, and I will only occasionally show you how to work with class-based components. Nonetheless, I want to emphasize that you don't have to use functional components. It is fine to use class-based ones if you prefer them. But chances are that you also see the benefits of functional components, and therefore it is fine to generally ignore class-based components, with one exception to which I'll come back to in a couple of minutes. Now, if you're not sure which approach to use, if you're not sure whether you want to go with class-based or functional components, here's a little helper decision tree, if you want to call it like that. As a general rule, you should simply prefer functional components. And you should instead use class-based components if you personally prefer them. So if you disagree, if you like them, of course you can use them. There's nothing wrong with them. If you're working on a project or in a team where there are a lot of class-based components being used, you might not have a choice then, and you might be confusing your colleagues if you start working with functional components only. And you also should use, and you must use, class-based components if you're building error boundaries. Now that's something we haven't learned yet, but that's exactly what we're going to take a look at in the next lecture now. Let me introduce you to error boundaries. Sometimes something goes wrong in your applications. And I'm not talking about bugs you introduced as a developer. Of course, you should simply fix them. But sometimes there are errors which you can't prevent, or which are simply being used to transport information that something went wrong from one part of the application to another part. Consider an HTTP request which is being sent. If the server is temporarily not responding, the request can't complete, and you will likely end up with an error being generated in your application. Now, there is nothing you can do about that as a developer. Servers can be offline, and there are, in general, errors which can't be prevented. Here, I built a little dummy example. In the users component, I added the component did update lifecycle method. And in there, I check if my users prop, which I'm getting, which is an array of users, has a length of 0, which means there are no users. In which case, I throw a new error. And that is, of course, a technical thing in JavaScript. By doing this, by executing this line, I'm generating an error, and I let this error bubble up the call stack. So I pass it through all these components, and if it's not handled anywhere, this will crash my application. And you can see this if you add this code, if you run your application. As long as there are users, everything is fine. But if I search for something which is not part of any username, like an S, this will crash. And it crashes with the error I specified because it's my error which is not being handled. Now, of course, I could just simply not throw an error, but instead handle this case differently. But it's also quite common to use errors not as a bad thing, but simply as a way of transporting the information that something went wrong from place A to place B in your application. You can learn more about that, by the way, learn more about embracing errors in my Clean Code course if you want to, but that's just a side note. So here I generate an error, and I want to generate an error. Of course, I don't want the entire application to crash. So what can we do? In regular JavaScript, we use try catch for this. We can try some code which might fail, and we catch potential errors when that code executes to then handle that error and run alternative code. That's what we can do in JavaScript. And with React, of course, we are just writing JavaScript code. Nonetheless, if an error is generated inside of a component, and we can't handle it in that component though, let's say we don't want to handle this error in the user's component, but in a parent component instead, then we can't use try catch, because that only works in places where we write regular JavaScript statements. And if we throw an error and we want to handle it in a parent component, our problem is that in this case here, the user's component is generating that error, but that is not a regular JavaScript statement here. Instead here, we have JSX code, and the error is generated inside of that JSX code, inside of the user's component. Now we can't wrap this JSX code with try catch. Something like this doesn't work. So that's not an option. Instead, in such a case, you can build and utilize an error boundary. And that's what we're going to do now. For this, I'll add a new component and I will name it error boundary, though the name is up to you. It doesn't have to be named like this. It's a JavaScript file, and in there I will create a regular component, which I'll name error boundary. So let's import component from React, because I will build it as a class-based component, as you can already tell, like this. And now in there, I'll do something special. The error boundary component is a regular class-based component, but it is a class-based component which implements the component did catch lifecycle method. The component did catch lifecycle method can be added to any class-based component, and whenever you do add it to a class-based component, it makes that class-based component an error boundary. It's just a term which we use to refer to when we talk about components that have this lifecycle method. You can't add it to functional components, and there is no equivalent for functional components at the moment. So if you want to build an error boundary, it needs to be a class-based component, and then it is a class-based component which implements this lifecycle method. Now, what's the special thing about this lifecycle method? Well, this lifecycle method will be triggered whenever one of the child components throws an error or generates an error. Therefore, what we do in the error boundary as well is we add a render method, like in all components, and we return this props children. And that's special now. Here I return this props children because I want to wrap my error boundary component around components which should be protected by that component. So here, for example, in the user finder, I could wrap the error boundary around my users component. Of course, we now need to import it also. So we import error boundary from error boundary. And then we wrap it around any components which might throw errors which we want to handle. And of course, you can wrap it around more than one component. It's totally up to you. Now back to the error boundary. In there, or in this file, I of course also want to export error boundary. But then inside of this class, I now want to do something when an error occurs. For that, we get the error object here as a parameter automatically passed in by React. And we can then, of course, look into that error to find out what went wrong and maybe run different logic based on different errors. Though you could also consider creating different error boundaries for different errors. But then, of course, we can do whatever we want to do, because it is a regular class-based component in the end. So we can also add a constructor called super, and then set our state equal to has error false, for example. And that's totally up to you. It doesn't have to be named has error. You can manage any state you want here, because it is just a regular class-based component in the end. But then when we catch an error here, we can call this set state and set has error to true. And then in the render method, we could check if this state has error is true. And if that's the case, we return something went wrong, like this. And that's how we could handle the error. We can, of course, also log the error or send it to a server for analytics or whatever we want to do. But now with that, we built an error boundary. And here's the result. If I now reload this, if I now enter an S, you will see something went wrong. Only briefly though, and then we see this screen again. Now that's only a development thing though, as you can also tell by the message down there. This is still shown by the React development server here in the end to make it clear to us that an error did occur. If you build your application for production and deploy it, something we'll also do later in the course, of course, this would not be visible. And you can close it here as well, this overlay. So this is what you would have in your real app, in your production app, without that development error message. And therefore, here we can see that the error boundary does work. Of course, it's unstyled because I haven't added any styling here to my error boundary, but you could do that. And the idea behind error boundaries really is that you can ensure that not your entire application crashes if something goes wrong, but that instead you can catch those errors and then handle them in an elegant way, just as you would do it with try-catch in regular JavaScript. And for error boundaries, if you add them, you need class-based components. This is currently not possible with functional components. At this point in the course, we already learned a lot about React, though I will say there also is more left to be learned. But everything we learned up to this point was about React doing things inside of our app in the browser. And of course, that is why we do use React. That is its main job. But we also only worked with local data up to this point. So we only played around with dummy data, which was always just managed and stored in the browser. In this course section, we are going to dive into how you may connect your React application to a backend, to a database. Because of course, many applications, probably all applications, need to fetch data from a database or store some data in a database eventually. No matter if we're talking about users that need to be created and stored and logged in, or if we're talking about products that need to be loaded, or anything like that. And therefore, this section is about establishing such a connection, and it is about sending HTTP requests from inside our React app to a backend. And specifically, we are going to learn how exactly React apps do interact with databases, because whilst it's simple, as you will learn, it will not necessarily work as you expect it to work. You will learn how you can send HTTP requests and work with responses which you get back. And we're going to have a look at how we can handle errors and loading states in our application. Now, before we dive into any demo or any code, let's understand how React apps do talk to databases. And as you can tell by the title of this slide, it's not working as you maybe thought it works. Because React apps, or in general, browser-side apps, browser-side code, so JavaScript code running in the browsers, should never directly talk to a database. So if you have a React app, and then some kind of database, SQL database, a NoSQL database like MongoDB, it does not matter. If you have such a database running on some database server, then of course you might want to fetch and store some data and you might want to establish a connection, but that's not what you should do and that's not what you'll ever see out there in the wild unless it's a highly insecure and bad written application. Because if you would directly connect to a database, if we leave aside that this will technically be challenging, but if you would do that, if you would directly connect to a database server from inside your client-side, your browser-side JavaScript code, you would expose your database credentials in that code. Because you must never forget that all JavaScript code running in the browser can be accessed and read not just by the browser, but also by the users of your website. Simply open up the developer tools and you can view all the code there. This generally is no problem, and attached you find a more detailed article and video which I created on this. But of course it will become a problem if you expose security relevant details in your code, for example credentials that allow access to a database. In addition, directly connecting to a database could also bring other problems like performance issues, but the security problem is the biggest problem of all. So therefore, instead of directly talking to a database from inside your React app code, you always take another route. You have a backend application running on another machine, not running in the browser, but running on some server out there. Maybe on the same server as the database, often on a different server though. Now, this backend application can be written with any server-side language of your choice. Node.js, PHP, ASP.NET, everything is possible. And it's this backend application which will do the talking to the database. Because you can safely store and use database credentials on the backend application, since that backend code can't be viewed by your users. It's on a different server and the users of your website will never see that code. And therefore, the React app will then talk to that backend server, to that backend API typically, which is a server which exposes different URLs requests can be sent to, and we're going to see this throughout this section. And then you have a safe connection to the database, because the credentials are on this backend app, and for talking to the backend app, no security relevant details are needed. This is how this works, and this is what we're going to see in action in this course module. Now, I prepared another dummy application for you. Of course, you find it attached. It has two dummy movies, which are being rendered here, and this button, which currently doesn't do anything. Now, the code for this is fairly straightforward. It's an app component, which renders a section with this button, and which then renders a movies list component. And currently I just have some dummy movie data which is fed into the movies list. And in the movies list, I simply loop through these movies to output the individual movie components, which render list items with, well, this content. And that brings this here to the screen. Now at this point in this application, as I said, we're just using some dummy data here. I want to change this now. I want to fetch data from a database which contains some example movies. And for that, I'll use the Star Wars API. You can visit swappy.dev for Star Wars API. And here you have a little dummy API with some dummy data which you can send requests to play around with it, basically. Now, I will say right away, this is an API. It's a backend app. It's not a database because of what I explained in the last section. Behind the scenes, it of course probably uses some database to store some data about the Star Wars movies, but we interact with this backend app. And I said API a couple of times. API stands for Application Programming Interface, and it's a very broad term, not just related to React and HTTP requests. In the end, it means that in our code, we're dealing with something which has a clearly defined interface, clearly defined rules on how we can achieve certain results and do certain tasks. And when we talk about APIs in the context of HTTP requests, we typically talk about REST or GraphQL APIs, which are basically two different standards for how a server should expose its data. Now, this is a REST API, and it simply means that there are a couple of URLs, like this URL, which you see here, to which you send a request to get back data in a certain format. And different URLs to which you send different requests will give you different chunks of data. That's what makes it an API. You got different entry points which lead to different results. If you want to learn more about REST APIs and what exactly that all is, you'll also find a helpful resource on that attached to this lecture. So here we can basically send a request to this URL, for example, to get information about a certain person from the Star Wars movies. We can also grab this URL here and send a request to swappy.dev/API/films, and we will later get back a response with a bunch of objects describing the different films, the different Star Wars movies, with, for example, the opening crawl text and the title, the episode ID, and so on. Now, this is just a dummy API, which I want to use for getting started with sending HTTP requests. That's why I'm having a look at this first. And this is the API to which we now want to send requests from inside our React application here to populate this list of movies here with some real data instead of our dummy data. And how does this now work in React? Now, when it comes to sending requests from inside React apps, we must not forget that in the end, we're still writing regular JavaScript code, right? A React application in the end is just a JavaScript application. That is what it's all about. And since that is the case, we can of course use any send HTTP requests in JavaScript solution which we want. For example, there is a package called Axios which you could use. You can visit it on GitHub, which makes sending HTTP requests and dealing with responses very, very simple, no matter which JavaScript library you might be using. You can even use it without any library. But nowadays, we also have a built-in mechanism for sending HTTP requests from inside JavaScript, and that's the Fetch API. The Fetch API is built into browsers, and it allows us to fetch data and actually also to send data, even though the name doesn't imply it. And we can use that to send HTTP requests and work with responses. And therefore, it's the Fetch API, which I want to use here to get my movies. Now, we can start simple and make sure that whenever this button here is clicked, we do fetch movies, and then we display the movies. And for that, I will simply remove my dummy movies here and instead add a new function here, which I'll name fetch movies or fetch movie handler. Fetch movies handler is probably a better name, like this. And in here, we can now use fetch, this function, because that's a function the browser makes available to us. That's this Fetch API being used. And in its simplest form, we just need to pass in as a string the URL to which you want to send a request. So in my case, swappy.dev/API/films. To be precise, HTTPS and then that URL. We could provide a second argument here, which allows us to pass in a JavaScript object where we configure various options. For example, where we add extra headers or an extra body or change the HTTP request method. But here we don't need that because the default method will be get. So by default, a get request will be sent. And that's all we need here for the moment. So that will now send such a HTTP request whenever this function is called. But of course, we also want to handle the response. And fetch returns a promise, which allows us to then react to the response or any potential errors we might be getting. Now we're getting a promise here, which is an object which will eventually yield some data instead of immediately doing that, because of course, sending a HTTP request is an asynchronous task. It doesn't finish immediately. It can take a couple of seconds or milliseconds. It can even fail, of course. And therefore, we can't just continue in the next line of code and use the result immediately. Instead, the result will be there at some point in the future. And that's exactly what promises exist for in JavaScript. So we can add then here to define a function which will be called whenever we got a response. And we could add catch to handle any potential errors. But for the moment, let's ignore that and let's focus on the then case. Here we get a response, and then here I'll write an arrow function. We get a response, and then in this function body, we can use the response. And this response argument here is now actually an object with a bunch of data about the response. For example, we can read the response headers, we can get the status code. There also is a utility OK field, which will be true if everything worked and false if we got some error. But here we're now interested in the response body. And this API sends back data in JSON format. JSON is simply a data format, a very popular one for exchanging data. And it looks like this. It looks like a JavaScript object, but keys are wrapped between double quotes, for example. And there are a couple of other rules you have to keep in mind as well. Also, there are no methods, it's just data. And the advantage of JSON data is that it's very easy to translate it to JavaScript objects, but there is a translation step which needs to be transformed. Thankfully, the response object which you get has a built-in method which will automatically translate this JSON response body to a real JavaScript object which we can use in our code. All we gotta do for that is call JSON, which is a built-in method on that response object. And this will now do this transformation. Now this itself then again returns a promise. And therefore what we should do here is return that promise and then add another then block here, which will then be fired once this data transformation is done. And here we therefore then get our transformed data, which in the case of this URL will have this structure here. So it's an object with a count field, a next field, previous, and a results field, which then in turn holds an array. And it's this array I'm interested in here. So we can access data.results to get access to this array, like this, and then store these results in some state, which we then update in this place here, and which we then use here for movies list. So let's add use state and initialize an extra piece of state here in this app component. Let's say initially it's an empty array and we name it movies and set movies. That's our state updating function. And here, once we got our movies, once we got the parsed and extracted movies, I will call set movies and set my data results. So this array here as my new state, as my new movies state. And now we just gotta forward movies here as a value for the movies prop. Now, one thing to note here is that in my application here, I'm actually extracting title, release date, and opening text from the data I receive. Now, there will be a title key, but opening text is actually called opening_crawl here, and release date is called release_date here. So we either adjust the prop names here, which I expect, or we make sure that we transform the incoming data from this format here to the format we expect in our app. And I'll do the latter. So in app.js, where we are making that HTTP request, before setting the data, the results as a new state, I'll actually transform them. So here I'll have my transformed movies, let's say. And that in the end will be data.results, which is this array we're getting back, .map to convert every object in the results array into a new object. And it's then the new objects, the array full of new objects, which will be stored in transformed movies. Now the logic for mapping here simply is that I get my movie data, or whatever you want to call it, which will have this format here, so like this object here, and I'm only interested in the ID, the title, the opening crawl, and the release date. So I will return a new object here, and this will be my movie object in the front-end application, which has an ID, which I get by accessing movie data.episode_ID. Because there is this episode ID field in the data we get back. And I now translate this into just an ID field in the data I'm working with here in my front end. Now for the title, we access movie data.title like this. And for my opening text, which I expect to get, I simply access movie data.opening_crawl. So the text stored in this opening crawl field will be stored in an opening text field here in the object I'm creating here. And then we also need the release date, of course, and that will be movie data.release_date. Now this is transformed, and now it's the transformed movies which I'll store here with set movies. Now to make sure that everything works, we now have to connect fetch movies handler, this function, to this button. And therefore, of course, here we add on click and point at fetch movies handler. If we now save that all, we can go back to the React application. And initially we got no movies because I removed the dummy data. But if I click fetch movies, you see it takes a short while, but then this movie data shows up. And this is now fetched from this Star Wars API and therefore from a backend app, which in turn is talking to a database. And that in a nutshell is how you do connect to a database from inside React apps. And since this is the wrong term, it would be better to say that this is how you send HTTP requests from inside React apps to a backend. So we are sending a GET request, this first HTTP request here, whenever this button is clicked. Now, I mentioned that we're dealing with promises here. Fetch returns a promise, and that's why we have these then calls. And just in case it shouldn't be clear, promises are nothing React specific. It's a JavaScript language feature. Now, you might be aware that when you're dealing with promises, you can build these then chains here, so then call after then call, but you can also use an alternative syntax, async await. You can add the async keyword in front of a function, and then await an operation which is returning a promise. And it's just a transformation in your code, which behind the scenes basically does the same as if you do use these then blocks. It's just a bit easier to read. Because now you can say const response equals await fetch, and you can remove this then block. And you can then say const data equals response.json and add await in front of that. And then get rid of that. And of that, and simplify the code to look like this. Now it's still asynchronous code, as you can tell by the async keyword. It looks synchronous, it looks like we execute step after step, but behind the scenes you can imagine that it's still transformed to this syntax you saw a second ago with these then calls. I just use async await here because it's a bit easier to read, I would argue. So that's something we can also do if we're working with promises here. Again, this is not React specific. This is also a default JavaScript feature. So now let's continue working on this application. We are fetching the movies whenever we click this button, and that's great. Now, we're not really showing any loading state. If I reload this app and I click fetch movies, it takes a second or so for the movies to show up. In reality, you typically want to show some loading spinner or at least some loading text in the meanwhile to signal to your user that data is on its way and you're doing some work. And of course, we want to do this here as well. Now, how could we do that in React world? In the end, it's again just about managing state. We get the movies state, and we can of course tell whether we have movies or not. Now, to tell whether we're waiting or not, we can introduce a second piece of state. We could name it isLoading and set isLoading. And then add use state and initially set this to false. Initially, we're not loading data. When this component is loaded, when the app component is rendered to the screen, we're not loading data. But when we call fetchMovies handler, when this function starts to execute, we of course want to call setIsLoading here and set this to true. With that, we change the state when we start to load. Now, once we're done, so basically after this await block, or after we set movies, but that doesn't really make a difference because these are synchronous tasks. But once we're done, we want to call setIsLoading again and set it to false again because we're not loading anymore. We got some data. And now we can use the isLoading state to render a loading spinner or some loading text. So here we could say that we only want to render the movies list if we are not loading. So of course we can do this as we learned it, wrap this in curly braces, check is loading, and if we're not loading, then we want to render this, which we can do with this shortcut here. So if we're not loading, then we render this. Alternatively, if we are loading, so there's no exclamation mark here, I will render a paragraph where I say loading. So if we save this and we click this button, you see loading here, only briefly because the data arrives super fast, but you see loading here for the fraction of a second until the data is there. And also if we refetch. And that is how we can show a loading spinner, loading text, whatever you want to do whilst you're loading. Now, of course, loading and not loading are not the only states you might have. We might also want to show a different content if we're not loading, but we got no movies yet. So if movies is an empty array and there is nothing to display. Of course, we could also handle this. We could say that we only want to render the movies list if we're not loading and movies length is greater than 0. So only if we're not loading and we got movies, only then we display the movies list. Here, we want to show the loading text whenever we are loading though. No matter if we already have loaded movies or not. We started a new loading process and therefore, of course, we want to show the loading text. Now, maybe we want to show some fallback content if we're not loading and we got no movies though. So here we could say if we're not loading, so we want to display some content, but the movies length is equal to 0, so we got no movies, then we show a paragraph where we say found no movies or anything like that. This of course is just a simple fallback example. Now you see when we reload this application and we therefore have no movies initially, we see found no movies. If I click fetch movies, this will change to loading and then to the movies. And that's of course a crucial part of building user interfaces. You want to let your users know which state your application currently has. And there is a difference between we got no movies, we are loading, and we have movies, of course. Now, when sending HTTP requests, things can also go wrong, of course. You can encounter errors, both technical errors, because, for example, you have no network connection, or you do have a network connection and the request is sent, but you get back an error response code, something like 404 or 500 or 401 codes. And in case this doesn't tell you much, attached you find this Wikipedia article on the response codes which you commonly get. And for example, you will get a 200 or a 201 code, or any 200-ish code, if you had a successful response. So you sent a request and the server was able to produce a successful response. But when sending requests, you also sometimes get 400 or 500 responses. For example, if you're sending a request to a resource which you may not access because you're not authorized, something we'll talk about later in the course when we talk about authentication. Then the request might be sent successfully, there is no technical problem, but the server replies with a 401 or a 403 response, making it clear that it got your request, but it doesn't want to give you the response you wanted. So you then get a successful response technically, but it has an error character because of this error status code, which is attached to it. And you could also be getting a 500-ish response if there was some server error. This is how the web works. Now I can simulate this here if I try to send a request to swappy.dev/api/film instead of films. This is an invalid URL. It's a REST endpoint which is not supported by this REST API. And hence if we save this and we send a request, we don't get back data. It's stuck in the loading state, which of course is a bad user experience. It would be better to show the user some error so that the user of this application knows that things went wrong. Now if we open the developer tools, we see an error here. We got back a 404 response. That's what I meant. Technically, it was a successful request. It left our machine, was sent to a server, and we got back a response. But the response has a 404 status code, indicating that something is wrong with the response. In this case, that we requested a resource the server was not prepared for. Now, as I said, we want to handle such errors. And therefore, we might want to introduce a third state here. An error state with error and set error. Now, initially that might be null, because initially we have no error. And whenever fetch movies handler is fired, we also might want to reset this error to null. Like this, to make sure that we clear any previous errors we might have gotten. But we want to set it to something else than null if we do get an error here. Now, if we're not using async await, if we work with then and so on, then we would add catch to catch any errors. Now, when working with async await, we instead use try catch. So we try some code and we catch any potential errors. So here I want to grab all of that and move that into the try block and then catch any potential errors that might be caused by the code in the try block. So now whenever some error is thrown here, we will catch it. Now one problem we'll face here is that the fetch API doesn't treat error status codes as real errors. It will not throw a technical error if we get back an error status code. So the problem we have here would not result in an error. We would only get an error in a second step if we then try to operate on data which we haven't gotten. But that's not how we want to handle this. Instead, it would be better if we would throw a real error if we got back a response with the unsuccessful status code. And again, by default, the fetch API here doesn't do that. Axios, on the other hand, this package I mentioned earlier, this third-party library, which you could use for sending requests, would generate and throw a real error for error status codes. Now, since we're not using Axios here, but the fetch API, we have to do this on our own. And it is easy to do that. I mentioned that the response object which we get back has this OK field, which basically signals whether the response was successful or not. So we can check if response is not OK, like this, and then generate and throw our own error in that case. So here we can then throw a new error with some error message of our choice. We could read an error message from the error response we got back from the server, or use our own error message, which is what I will do, and I'll just say something went wrong here. Now we throw this error if we have an unsuccessful response. And since we throw an error here, we of course won't continue with the next step in line. Instead, we'll make it into this catch block. And here, we can now call setError, and set this equal to error.message. So now error is a string. It's this string here, in this case, to be precise. And with that, we're managing this error state. Now we also want to, of course, output it down there. We want to output some content based on whether we do have an error or not. So we can, again, render something conditionally, and we can check if we're not loading, Because of course, if we are loading, we want to wait what the result of that is. But if we're not loading and we do have an error, so if that is not null or undefined, but if we do have an error, then I want to display this error. So then I'll render a paragraph with this error text inside of it, like this. And I also, of course, want to make sure that we always stop loading. Even if we have an error, we're not loading anymore. So we also want to set is loading to false here, or we simply move it after this try catch block, so that we always set is loading to false, no matter if we have a successful or an error response, because either way, we're done loading. And with that, if we save this, if I click fetch movies, we're loading, and then I get some output here. Found no movies, and then my error message here. Now that's not the error message I'm setting here, because actually here I'm calling JSON on the response, and this already fails because we're not getting back JSON data for this request for this invalid API endpoint. So actually I should check for the response being okay before I even try to parse the response body. Now the exact way of handling the error response depends on the API you're talking to. Some APIs also send back JSON data if the request was not successful. Other APIs like this one send back non-JSON data. So therefore here we need to handle this before we try to parse that. With that though, if I now click fetch movies, we see something went wrong. I also see found no movies, which of course is not what I want. I want to make sure that we only show this fallback text if we're not loading, we got no movies, and we got no error. So here I'll check that we have no error in addition to the other checks. And with that, if we now try this again, then we have this state. And if I fix this error by adding the S again here, and we now save this, we of course can successfully fetch movies again. And this is how we can handle all the different states we might have when sending HTTP requests. And this is important because no matter to which backend app you're talking, you will always have these different states. You will always be waiting for the response. You might always be getting errors. You might always be getting back your data, hopefully. And your data might always be empty. At least in most cases, it might be empty. And therefore, it's important that you know how to handle these different scenarios. Now, of course, instead of writing all these inline checks here, we could also write this more elegantly. We could add a new variable, content, which by default, let's say, is found no movies. And then we set it to something else depending on which state we have. So we can check if we're loading, for example, in which case we set content equal to loading or whatever you want to display when you're loading. Now we can also check before we check for loading, because this should override everything. So I check for it last. Before checking that, we can check if we have an error, if that is truthy. In that case, we can set content equal to error. And of course, we might also have our data. I mean, hopefully that is what we have in the end. So we can check for that first. We can check if movies.length is greater than 0, in which case content should be equal to this movie's list here. So let's grab that and set content equal to that here. And now we can replace all that inlined output down there with just rendering content, this content variable. And the value stored in the content variable will now differ based on the state we have. It's either found no movies, or loading, or our movies, or again, if I temporarily remove that S here, like this, then it can also be that error message. So that's how this works, and that's how we can handle these different states. So at this point, we already achieved quite a lot. But there's one thing which is unrealistic, at least in some applications. Currently, we're always fetching data when this button is pressed. Now, in a lot of applications, you want to fetch data as soon as a certain component loads, right? If a user visits the web page, you immediately want to start fetching data. And currently, we're not doing that here. We're just fetching it on demand when the button is pressed. Now, to immediately fetch it, we can use another concept we already learned about. We can use the useEffect hook. Because sending this HTTP request is a side effect which ultimately changes our component state. And you learned that such side effects should go into useEffect. Having them into a function is of course also fine, as long as you don't just call this function as part of your main component function. Because then you could create an infinite loop where you call this function, it updates the state, the component function re-renders or is re-evaluated, and therefore the function is called again, it updates the state, the component function is called again, and so on. We want to avoid that, and that's why we use useEffect for that. UseEffect is great if we have code that should be executed as part of the component render cycle, but maybe not always when the component re-renders. And therefore here, we can add useEffect and then define our effect function here, either as an arrow function or as a regular function with the function keyword. And here in useEffect, I can of course simply call fetchMoviesHandler. I can simply call this function like this. So now this function is still called if I click the button, but in addition also whenever this component is re-evaluated. Now, of course, I don't want to call it whenever this component is re-evaluated, because that would be this infinite task, which I don't want. Instead, we add our second argument here, which is this array of dependencies, where we define when this effect function should be executed again. It will only execute again if the dependencies listed here change. Now, as you can clearly tell, I didn't add any dependencies yet. So if I save it like this will never run again except for the very first time the component is loaded. So hence, if we reload this app, the data is fetched immediately. It's still fetched again if I click the button, but it's also fetched immediately when this loads for the first time, because of useEffect. Now technically, we're not executing this in a clean way though. You also learned that it is a good practice and a best practice to list all dependencies you use inside of the effect function here in the dependencies array. Now I am referring to the fetchMoviesHandler function here. That is a dependency of this effect. So we should add fetchMoviesHandler, a pointer at this function, as a dependency. Because if this function changes, this effect should be re-executed. And this function could change if we would be using some external state in here. We aren't doing that in this example, but in other examples we could be doing that. So we definitely want to list this function, a pointer at this function, as a dependency of this effect. The problem with that is that functions of course are objects, as you learned, and therefore this function will technically change whenever this component re-renders. So we will create an infinite loop if we add it as a dependency. One solution would be to omit it, because here that would indeed achieve the result we want. But it could introduce subtle bugs if our function would be using some external state. So the better solution is to use the useCallback hook and import that from React and wrap the fetchMoviesHandler with that. For this we need to transform it and turn it into a constant, which saves the result of useCallback, which then wraps this function, which is now written as an arrow function here, though we could also use the function keyword, like this. And we should add our dependencies array for a useCallback as well, and list any dependencies this function might have. This function, though, has no external dependencies. The fetch API is a global browser API, it's not a dependency, and other than that, we're not using anything special in here. These state updating functions, as you learned, don't need to be added as dependencies because React guarantees that they will never change. Now, I still changed something which would break the app, I removed the async keyword. We need to bring this back here, simply in front of this anonymous arrow function. Async, then any parameters we might be getting, then arrow, and then the function body. Alternatively, we can also write it in a non-arrow function way like this if we want to. That both works, and there is no difference here. I will go back to the slightly shorter syntax though. So now we ensure that this fetchMovies handler function is not recreated unnecessarily. So if we save that, it now crashes though, because the order is now wrong. With the function keyword, it was no problem because of hoisting. Now, since this is a const, calling it before this code has been parsed won't work, so we simply need to move this useEffect call after this function definition. And now it will work again. And it works as before, without an infinite loop, and we still can also reload manually. So that's how we can leverage useEffect to make sure that we send a HTTP request immediately when a component loads, and not just when a button is clicked, though we still can also do that. And you also learned how to use useEffect correctly then, and how to ensure that it will really always run when it needs to run, but not when it does not need to run. Now we know how to send a GET request, because that's what we're doing here. We're getting data by sending this fetch request to this URL. Now, in reality, in a lot of applications, you don't just want to fetch data. You also want to send data to a server, for example, because a new user was created. That's why I added a new component, and attached you find an updated project snapshot, which contains the new addMovie.js and addMovie module CSS files, and an adjusted app.js file, where I basically now also added this addMovie component here in my JSX code, and where I added this addMovieHandler function, which just logs the movie. In addMovie, I'm just rendering a form, and I'm gathering the user input, preventing the form default, the submission default, and then creating that movie object and passing it on through my prop here, through onAddMovie. Therefore, we get this form, and this would allow us to add a movie. Now, the Star Wars API, which we're using here, is really just a dummy API for getting data. We can't send post requests there, which is what we need to do to store new data. But this dummy Star Wars API, of course, is just some API which is there to play around with it. They don't want data to be submitted by anyone out there. So we can't send a post request here. That's why I'll now use another dummy API, another service. And that service is Firebase. Firebase is a service provided by Google, and it's in the end a backend which we can use without writing any code. Unlike the name implies, it's not some kind of database. It's a backend that comes together with a database, but it also gives us a full backend app, a complete REST API to which we can send requests. And the great thing is that we can get started for free here, also if you check their pricing pages, and we can play around with our dummy backend here for free, without writing any server-side code. Since this course is a React course, I of course want to focus on React. And here we will then be able to get data and to store data. For that, you need a Google account, and then you need to go here to the Firebase console after logging in with your Google account. Once you logged in, you can add a new project and give it any name of your choice. Here I'll name it React HTTP, but the name is up to you. Click continue. You can disable Google Analytics, we don't need them here. And this will now create our Firebase project. Now again, Firebase is a service offered by Google. It consists of many products and services that make up the overall service, and we will only use a fraction of that. We're not going to build some complex Firebase app here. I'm just using it because it's a free to use, no code needed backend, which we can start with. Now here I'm in the Firebase console, and for us, the real-time database is interesting. Now I did say that Firebase is not just a database, and it isn't. But part of its offerings is a database. They actually have two databases. Cloud Firestore is the more powerful one, but real-time database is the one which is easier to get started with, and since we just want a dummy backend, we'll use that. It also has the nicer REST API. Now once we click here, we can click on Create Database, and then, important, Start in test mode. Otherwise, you will not be able to send requests. Now this sets up a very simple database for you, and it gives you a URL which you can use to talk to that database, though that's deceiving. As I mentioned, our frontend won't directly talk to the database, and it's not doing that here either, even though it might look like it is. In the end, this here is a URL to some Firebase API, some Firebase REST API, which then takes incoming requests and does talk to some other database behind the scenes. It just might look like we're directly sending requests to a database here. Actually, we aren't. Now we can use this URL to send data to our Firebase backend and to our database, therefore. But of course, fetching movies from there won't really succeed. If we go to app.js, we can replace this Star Wars URL with this URL, and then actually add one extra segment here, which is movies.json. Now this name, movies in my case, is up to you. This basically will then just create a new node in that database, basically. It's a dynamic REST API, which you can configure here by using different segments to store data in different nodes of your database. So this name is up to you, and I choose movies because I want to store some movies. .json is important here. That's something Firebase specific. They need this .json at the end of the URL you are sending requests to, otherwise your requests will fail. Now we can get our data from there, but if I use this URL, indeed we'll fail to get our data. And we actually get an error because I try to read some results which we don't get. We are not making it into this if block here because we're not getting an error response code. We do get a 200 response code, but we won't have our results in there. We won't get any data at all. Of course, because currently we're not storing any data here. Now I did switch to this real-time database and to Firebase so that we can send post requests and that we can store data, because that's also something you often gotta do, and that's something I want to show you therefore. So how can we send a post request when we click Add Movie to submit that movie data we collected to Firebase? Well, we already got this Add Movie handler, which is in the end triggered when Add Movie is clicked. And there we get a movie object, which in the end contains a title, an opening text, and a release date. An ID will be added by Firebase automatically. So in the end here, it's in this Add Movie handler where we want to send another HTTP request by using the fetch API. And I mentioned, even though it's called fetch, it's not just there to fetch data. You can also use that same function to send data. Might sound strange, but that's just how it works. Of course, by the way, you could also outsource some code into separate functions, maybe also stored in other files, to keep this file lean. Here, for education purposes, I'll keep it all in one file. So back to Add Movie Handler. We want to send a request. And of course, I want to send it to the same URL which I use for getting my data. Otherwise, getting would never succeed. But I said that fetch by default sends a GET request. And here we now need a POST request. The fetch API works such that you can pass a second argument to fetch. And you can use that argument to configure this outgoing request. And for example, you can set the method key. By default, this is GET. But here we can set it to POST to send a POST request. And if you send a POST request to this endpoint at our Firebase service, Firebase will go ahead and create a resource in the database. Now, what happens exactly when sending a POST request to some URL always depends on the backend you're using. It's not set in stone that sending a POST request will always create a resource, even though it typically will. But it always depends on the concrete API. Here, for Firebase, sending a POST request will create a resource. So we also need to add that resource, which should be stored. And we do that with the body option here on this fetch API configuration object. Here I want to pass on my movie, though body doesn't want a JavaScript object like this. Instead, it wants JSON data. I mentioned before that JSON is this data format which is typically used for exchanging data between frontend and backend. Now, to convert a JavaScript object to JSON, we can use a utility method which exists in JavaScript. We can use the JSON object, which is built into browser-side JavaScript, and call stringify. And this basically takes a JavaScript object or array and turns it into JSON format. Now, last but not least, we need to add some headers, or to be precise, one header, which we do by adding the headers key and setting an object as a value. And that's the content type header written like this, which should be set to application JSON. Technically, this header is not required by Firebase. It would be able to handle the request even if that header is not set. But a lot of REST APIs to which you might be sending requests later might require this extra header, which describes the content that will be sent, and therefore setting it is not a bad idea. And I will set it here even though it's technically not required. And with that, we'll send a post request with that data to this URL. Again, this will be an asynchronous task and we get back a promise, so we can again use async await here to await our response. And then we can also get our response data by awaiting response.json, because Firebase also sends back data in JSON format. And for the moment, we can console log that data. Now, of course, we could also add error handling here, and also wrap this with try catch, and do the same as we did before. Set error if we get an error, and so on. I'll not do that here though, because I want to keep this short and focused, but we could do exactly the same as we did before for getting data. Now with that though, we hopefully do store some data. So if I now reload, I can try entering a title here, my first movie, and some text here, and some release date of our choice, doesn't matter at all, and click Add Movie. And now let's have a look at the Firebase backend. And here in the real-time database, you should see a new Movies node, because we sent this request to /movies here. And in that Movies node, you find this cryptic ID, which was auto-generated by Firebase, and there you find the data which was sent. So this worked. In the React app, if you open the developer tools, in the JavaScript console, you should also see the response object you got back from Firebase, and there Firebase replied with that auto-generated ID, which was stored in some name field. So this is how we can send a post request. Now, if we click Fetch Movies, it should be able to get back some movies, but of course our logic for transforming these movies doesn't work anymore. Previously, we expected that we have a results field in our result, but now actually that's not the case anymore. If I console log the data we get back here when fetching movies, if I console log that, you will see that if I reload, the data we get back is an object where we have the cryptic ID as a key, and then another nested object with the actual movie data. So we're not getting back an array, but an object, where the IDs are keys and then the data are nested objects. So we just need to transform this appropriately to again display our movies. So therefore here, we're not using map anymore. Instead now here, we could simply create an array, loaded movies, which initially is empty, and then create a for in loop to loop through all the keys in data, because data is now an object, as I just mentioned, and keys are the IDs of the movies, actually, as you saw here. And then we simply want to go to loaded movies and push a new object for every key value pair we got in the response data, and set ID equal to key, set title equal to data for the given key dot title. So here we're drilling into that nested object we got in the response. We're drilling into this object here. where we have a title, opening text, and release date. This is how we dynamically access a property in JavaScript. And we're doing that for the title, for the opening text, and then also, last but not least, for the release date. Here we also do that like this. And there would be other ways of writing that transformation logic, but this way is hopefully very easy to understand. So then we get our loaded movies, which now again is an array full of objects which have the structure we expect. And therefore we can now get rid of this code and set our movies here equal to loaded movies, which is this array we just built. And with that, if I reload, you see that data is now loaded. And if I now add a second movie with more text and a release date of 2022, sometime in August, I can click Add Movie, and if I fetch my movies thereafter, I get this second movie as well. And of course, you could now tweak this app. You could make sure that new movies are fetched automatically after a movie was submitted. You can add error handling in the Add Movie handler. You can do all of that, but this is just a demo to show you the core parts that are involved when it comes to sending HTTP requests. And you now saw how you can set a GET request here to get data, and how you can send a POST request to store data. Both matters in many applications, and now you know both. And you also know how you can handle different states and errors. We didn't do it here for Add Movie Handler, but it would work in exactly the same way as for getting our movies with Fetch Movies Handler. And that's it for this module. Now you learned that React is able to talk to a backend, but not to a database directly, for security and performance reasons. But you can send requests to backend APIs. Very often that will be REST APIs like we see it here. And then you can, for example, use the Fetch API or third-party libraries like Axios to perform that request, and to then also get the response, analyze the response, and maybe throw and generate an error if it's needed, and or work with the data you get back as part of the response. You learned how you can send both GET and POST requests, and you also learned how you can handle different states which are involved with sending requests. A loading and an error state, and the we have no data state, as well as the we do have data state. All of that is important and allows you to build rich user experiences, which you want to have in most of your applications, of course. Because sending HTTP requests is a crucial task, and here in this demo, you learned how it generally works. As you can probably tell by now, we are diving deeper and deeper into React. And in this module, we're going to have a look at another core concept which you will use in a lot of React apps you're going to build. And that will be custom hooks and how you can build your own custom hooks. Now, up to this point in this course, we already worked a lot with hooks, with the built-in React hooks React offers to us, like use state, use reducer, use effect, use context, and so on. So all these special React functions that start with use. You might remember that when I talked about the rules of hooks, I mentioned that you can only use React hooks in React component functions and in custom hooks. And I told you that those would be covered later. Well, now is later. Now we're going to explore how you can build your own hooks, why you might want to do that, how exactly you do that, of course, and we're going to do that at a concrete example or multiple examples. And we're also going to learn about the rules and practices and best practices that apply when you build your own custom hooks. So, what are custom hooks? And we need to clarify what they are before I can dive into the why. So, what are custom hooks? Custom hooks are in the end just regular functions, just as the built-in hooks like useState are in the end just functions, but they are functions which can contain stateful logic. You can build custom hooks, these custom hook functions, to outsource stateful logic into reusable functions. Unlike regular functions, custom hooks can use other React hooks, including other custom hooks, and they can therefore also leverage React state managed with useState or useReducer. They can access useEffect and so on. With custom hooks, you can outsource logic, which you might be using in different components, into a custom hook, which you can then call from all these various components. So it is simply a mechanism of reusing logic, just as regular functions are, with the special thing that in these custom hook functions, you can use React hooks and other hooks. And that might, of course, still be a bit abstract. So therefore, let me give you a concrete example which shows you why you might want to explore custom hooks and how you then build a custom hook step by step and how you use it. Here is an example application. Of course, you find it attached. And as you see, this application has, in the end, just two counters. One counter counting upwards, one counter counting backwards. And of course, that's not a fancy application. We're going to see another example later in this module, but this application allows me to explore custom hooks together with you, show you why we might want to build custom hooks and how we build custom hooks. So here's the code for this application, which again you find attached. And in here, we in the end just got three components: the backward counter and the forward counter, the card component, which is just a wrapper component providing some styling, and in app.js, I'm using the forward and the backward counter components, and these components do just what their name implies. The forward counter uses useState and useEffect to manage a state, and to create an interval which simply starts counting up and which then sets a new counter state every second, every 1000 milliseconds. And in the backward counter, I'm doing the exact same thing, but here I'm subtracting from the counter. But other than that, it's the same logic. So therefore, it is fair to say that these two components are fairly similar. Now, of course, we might be able to create one component instead and then use props to configure it differently, but it would also be realistic that in real applications, you have different components which, to a certain extent, might do related tasks. And it is fair to say that we therefore definitely have some code duplication in the forward and the backward counter. If we leave that small detail of subtracting or adding to the counter aside, it's exactly the same code in the end. And whenever you have code duplication in programming, you typically want to take that code and refactor it and create a function which holds the shared code. And that's exactly what we're going to do with custom hooks. Because the problem we face here is that the code which we want to reuse uses React hooks like useState and useEffect, and it updates the state by calling the state updating function. And as you learned with the rules of hooks, you are not allowed to use these React hooks in any random function. You must only use them in React component functions or custom hooks. So if we want to outsource that logic into a separate function, we need to build such a custom hook. And that's exactly what we're going to do here. So how do we build a custom hook then? Well, typically, just as with components, we store every hook in a standalone file. So I will start by creating a new hooks folder side by side to the components folder. And in there, I will add the use-counter.js file. Now, the file name is totally up to you. You don't have to name it useCounter. I do name it like this though, because there is a clear rule which we have to follow when it comes to the function name inside of that file. Because we are going to create a function here, either as a const which stores a function or with the function keyword. I'll go for the const approach, but both would work. And that function which you do create has to start with use in its name. That is a must do. That is a hard rule which you have to follow. It will be a normal function in the end, but the use at the beginning signals to React that it will be a custom hook, and it gives React the guarantee that you will use that function by respecting these rules of hooks, so that you will use this custom hook function just as you use the built-in hooks. And that is a guarantee React needs, because otherwise, if you start using React hooks in your custom hook, and you would use your custom hook in a forbidden place, you would implicitly also use the built-in hooks in a wrong place. And that's why we start with use here, because React can look out for that. And actually, this project setup will give you a warning if you have a function starting with use and you then start violating some of these rules of hooks. That's why this is a must do. Start with use in the function name. And thereafter, you can name it however you want. I will name it useCounter and then store a regular function in it. And because of that function name, I also named the file like this. But again, for the file name, there is no specific rule. You could name it however you want. Now, of course, ultimately, the goal is to use this function in another file. So therefore, I will export this function here. And then inside of this function, we can start adding that logic which we want to reuse. And in our case, if we start with the forward counter, in the end, we can just copy that code here. From the forward counter, that code where we use state and use effect, not the code where we return JSX, just the other code. Copy that and add it inside of that useCounter function. Now, since we are using use state and use effect now, we need to import these things from React, because you always need to import what you use. So here we import use state and use effect, like this. Now we got this logic in this custom hook function. But of course, in the end, we still want to utilize it in our forward counter and later also in the backward counter. How can we do that? Well, you are going to use a custom hook just as you use the built-in hooks. You are just calling it like a function because it is just a function. So therefore, we want to import useCounter here in the forward counter component. Import useCounter from going up one level, diving into the hooks folder, useCounter. And in the forward counter, we can then just call useCounter. Now that alone will not do everything we need to do, but it is a start. Now we are calling this custom hook function. So when this gets called, obviously all that code will execute. So that state will be registered and that effect will be fired. Now, if you call a custom hook in one of your components and that component, for example, registers a state or an effect as we do it here, then this state and effect will be tied to the component in which you use your custom hook. So if I call useCounter in the forward counter component, the state created here in useCounter will be tied to this forward counter. If we use a custom hook in multiple components, every component will receive its own state. So just because we use a custom hook does not mean that we share state or effects across components. Instead, for every component, the custom hook is executed again, and every component instance then receives its own state. So it's just the logic which is shared, not the concrete state. So therefore, in this case, since I call useCounter in the forward counter, this state is set up for the forward counter, and this effect is set up and fired for the forward counter component. But of course now, inside of the forward counter, I need access to the counter state, which is managed by the custom hook, because I want to output it here. And how can we do that? How can we make that happen? Well, just as we do it with the built-in hooks. For useState, this built-in React hook, this also does something behind the scenes. And it also creates and manages state, and then it does one important thing. It returns an array, which we are destructuring here. Custom hooks are just functions, and therefore they can return things. So here in the case of useCounter, to make that counter state available in the components that do use this custom hook, we can simply return it. We can simply return counter. You can return whatever you want to return in your custom hooks. That could be an array, or an object, or a number, or in this case, implicitly a number, because counter will hold a number. So now I'm returning this counter state here. So this state, which is managed or which is set up by that custom hook, I'm returning it here. And therefore, in the forward counter component, where I call useCounter, I can of course use that returned value. And here I can set up my counter constant, set it equal to calling useCounter. Since useCounter returns the counter, I can store it in a constant of this component. And now we can get rid of all that old code in here and slim down this component like this, get rid of the imports because we're not directly using useState or useEffect in this file anymore. And now we got this slim component. And if we now save that, you will see that if I reload here, this counter, this forward counter, still works as before, but now with a custom hook. And that is how we build custom hooks and why we do it. And when it comes to the how, the most important thing really is just the naming. You have to start with use. And then you can use stateful logic in there, you can use other React hooks in there, and that allows you to share this logic across components. And speaking of that, let's now make sure that we can use this custom hook also in the backward counter component. So in the backward counter component, we got the same logic as in the forward counter, but we are deducting here instead of adding. Nonetheless, we can use our custom hook here. We just need to do something which we often do with functions that we write. We make them reusable and configurable, you could say, by accepting arguments, parameters. Just as our components receive props, and just as any function in JavaScript or programming in general can accept parameters, custom hooks, since they are just functions, can also accept parameters. And for example, the built-in useState hook also accepts a parameter where we set the initial state. The built-in useEffect hook even accepts two parameters where we have our effect function as a first argument and our dependencies array as a second argument. So that is something which we do already implicitly and which we can now also do for our custom hook. So which parameter could we accept here? Well, in the end, we want some indicator that controls how the counter should be incremented. We could accept this entire updating function here to make this really flexible. So here we could have our counter update function as a parameter, and then in our custom hook, just execute counter update function like this, and expect that the argument we get here is then a function that can be executed, which gets the previous counter and accepts the new counter. Or we don't make our custom hook that flexible, but instead we accept some some flag, some Boolean flag here, which controls whether that should be a plus or a minus. So we could, for example, accept a forwards parameter, the name is up to you, which is true if we want to add and false if we want to subtract. And we could even set a default value so that this parameter is optional. And then here inside of set interval, we just check if forwards, if that is true, then we update set counter like this. Else, if it's not true, we update set counter by, well, basically just having the opposite logic of deducting. And that's the approach I will use here, but you could also accept the entire function. Either way, we now have a new dependency here in this effect in our custom hook. Because the parameter, which I'm using in here, that is a dependency. It's not defined inside of the effect function. It's not defined outside of our custom hook. Instead, it is a value that we get as a parameter here, and we have to add it as a dependency therefore. So we should add forwards as a dependency, so that this effect will rerun whenever this dependency changes. Of course, depending on the code we write in our components, where we use the custom hook later, this might never change. It might always be true or false and not change for one and the same component. But that's fine. If it never changes, this simply never runs again. We still have to add it as a dependency to follow all best practices and to ensure that if we would have a component where useCounter is used with different values for the argument, this effect would rerun if the argument changes. And that makes a lot of sense, by the way, because if we had a component where the counter can switch between forwards and backwards, we of course would want to restart the counter with the new logic if the value changed. But that's just some side theory here. For the moment, it doesn't matter too much. We can just go to the backward counter and import useCounter there as well, by going to the hooks folder and importing it. And then in there, in the backward counter, we call useCounter and we pass false as our argument here for our forwards parameter, because here we don't want to go forwards, we want to go backwards. We didn't need an argument in the forward counter. There we can call it like this because we got a default value in the custom hook. But if we want a different value than that default value, we have to pass it. Well, and with that, we can again extract our counter by using that return value, and then get rid of all that other logic in the backward counter component like this. And if we now save that, and we reload our application, we still have both counters working, but now with our custom hook. And of course, this was a made-up example here, and of course, besides the example on its own not being too realistic, you could definitely also find more ways of reusing logic here and working with one component instead of two counter components. But this was just there to introduce you to custom hooks. Now let's move on to a more realistic scenario where custom hooks can really shine. So here's a more realistic project. Attached you find this project where, after you downloaded it, you need to add in your Firebase links, and therefore, to understand what's going on here, you should make sure that you did not skip the HTTP course section, the section where I talk about connecting React apps to a backend. There I show how to set up Firebase as a dummy backend, and I show how sending HTTP requests works, which is of course something you need a lot in any kind of application you're building basically. So in this application here we are sending requests, and if you want to follow along on your system, you should therefore make sure that you have a Firebase account. You can get started for free, as shown in this HTTP course section, and that there you are using the real-time database, and you got your rules configured like this, set both read and write to true, or use the default test mode configuration, and then use this URL, which you find under data, and use that URL here instead of my URL. Keep the /tasks.json part though, you will need that. So that's what you should do to follow along. But what's this application doing? Once you updated the code and you installed all dependencies with npm install and you started the project with npm start, this is what you'll see on the screen. It's a simple tasks application, a very simple one actually, where initially the tasks are loaded, and if we have no tasks, we of course have to add some tasks first. For example, learn all about hooks. And you simply click add task, and now this is sent to Firebase. It's also displayed down there, and if you reload the application, it's loaded and displayed. And it's stored here on Firebase. Now I am only using what you learned in the HTTP course section, and this all works by sending a HTTP request with the fetch API, by handling errors and a loading state, by transforming the data when it arrives, and by then displaying the data. And we got various involved components, but most importantly, we got the app.js component where we are fetching tasks with this fetch task function, which is either executed because the component loaded due to use effect, or because inside of this tasks component a button was clicked, a button which is shown if we had an error, which allows us to try again. So that's when this fetch task function is triggered in the app component. And besides that, in the new task component, we got the enter task handler function where we also send a request, but here we are sending a post request with some data attached to store task data on Firebase. And this function is triggered whenever this task form is submitted in the end, which happens when this button is clicked and we verified the entered value. Now, feel free to pause the video and dig a bit deeper into the code, but that is what's going on here. And if you followed along in the HTTP course section, which you should have, then this is all basically just something you already saw. Now, I did create this basic yet more realistic example because here we also got another chance of adding at least one custom hook. And do you see where we could utilize a custom hook? Well, we got two similar kind of operations in two different parts of this application. And that would be here in the new task component when we send a request to store data, and in the app component when we send a request to get data. Now, regarding the details, the code is different. When we get the tasks, we configure the request like this. We send a GET request without a body and without headers. And we have some transformation logic, which we apply to the response. Whereas in the new task case, we send a POST request and we do add data, and we have a different transformation logic for the response. But even though these details are different, there are a lot of parts where the code is pretty much the same. For example, in both components, we are managing a loading and an error state, and we are setting the loading and error states in the same way. We are also having the same error handling logic here, and so on. So there are parts which are quite similar. And because that's the case, because we have some code duplication, some code reusage here, because of that, we might want to consider outsourcing this logic into a separate function. But since the logic, or at least parts of the logic, which is being reused, contains the usage of other React hooks and the usage of state, since that's the case, a regular function won't do the trick, because there we're not allowed to use React hooks. That's why here we have a great opportunity for building a custom hook where we outsource the HTTP logic, and then still in the end can reuse that stateful logic for the loading and error state. And that's therefore what we're going to do now. We're now going to apply our custom hook knowledge to build another custom hook, but this time a custom hook, which in the end encapsulates this HTTP logic. Definitely feel free to try this on your own first. It'll definitely be challenging, and there also will not just be one single way of doing this. Nonetheless, try it on your own first. In the next lecture, we're going to implement it together. So, were you successful? Let's try this together now. And for this, in the source folder, next to the components folder, I will add a hooks folder. This is just a convention, not something you have to do. You can name it differently, but I will follow this common convention. And then add a new file in there, which I'll name use.http.js. Again, this name is also up to you, but since I will create a HTTP-related custom hook in there, I think this is a fitting name. Now, the hook function itself, I will call that use.http, following this must-use pattern where your custom hook functions must start with the word use. And I will export this custom hook here because, of course, I want to be able to use it in other files. Now, regarding the content of this function, as I said, there will be more than one solution, and definitely feel free to share your alternatives in the Q&A section if you want to. I'm just showing you one possible approach which I came up with. And for that, let's have a look at the general logic we want to outsource. In the end, it is the loading and the error state, but then also the entire code where we send the request, where we evaluate the response. All of that should be outsourced. Also, this error handling here, where we then set the error state, that all should be part of the custom hook. And therefore, I think it is reasonable to go to the app component and grab this entire fetch tasks function and grab these states here, and in the end copy that into use HTTP into this custom hook function. Now here we can get rid of this tasks state here because that's a bit too specific. That's specific to the app component. That's not something I would want to put in the use HTTP custom hook itself, because this hook should not just be usable with tasks, but with any kind of data. But I will definitely keep the loading and error state in there. Now, of course, to use state in this file, as always, we should import use state from React. And I will rename this function here from fetch tasks to send request, so that this has a more generic name, because we will also tweak the logic in there to be more generic. This custom hook should not just be dealing with fetching data. It should also not just be dealing with fetching tasks specifically, because otherwise this hook would not be very reusable. It would be basically limited to one operation, fetching tasks. And that's not what I want here. Instead, this hook should be able to send any kind of request to any kind of URL and do any kind of data transformation, but it should always manage the same state, loading and error, and execute the same steps in the same order. That's the actual reusage we want here. And to make that hook that flexible, we of course also will need some parameters here. We will need some parameters to configure this hook. And what should be configurable here? Well, I would say the request logic. That needs to be configurable. The URL, but also the method, the body, the headers. This all needs to be flexible. So I do expect a request config parameter here. And this in turn then should be an object, let's say, which contains the URL and any kind of other configuration that might be needed. Now, therefore, here I will get rid of that URL of that hard-coded string here in use HTTP and instead refer to request config.url. Since we will be calling that hook, we then have to make sure that we pass in an object which has a URL property which holds the URL. This hook should also be usable for post requests, so therefore fetch should take a second argument here. And then there I pass my object where the method should be set to request_config.method, where the headers should be set to request_config.headers, and where the body should be set to JSON stringify request_config.body, so that we perform the JSON transformation inside of the hook, but the body itself is passed in from outside. And again, this is really just my approach here. You could make this more reusable, you could expect different parameters. That's all up to you. This is just one possible solution. Now this request and how this request is being sent is a bit more configurable. Of course, I want to then check the response like this, and I want to transform the response like this. I am assuming here that we're always working with JSON data, so I will not make this hook super generic to work with any kind of data. I will limit it to JSON data, because everything else would be far beyond the scope of this course. And therefore I will keep these steps here, but the transformation and so on, and what we do with the data in the end, that of course is then again highly specific and not something that should be part of this hook. Instead, I would imagine that we get the data here, and then maybe we execute a function which we get from the component that uses the hook, and pass that data to that function, so that the concrete transformation steps can be defined in the component where this hook is being used. So therefore here, instead of executing this code, I do expect to get another parameter here, and that's the, let's say, apply data function. The name is up to you. And then here, once we got the data, we simply call apply data and pass the data to it. So that in the hook, we just hand the data off to this apply data function, and the function itself and what happens in there is provided by the component that uses the custom hook. So that we have that reusability and that reused logic in the hook, but the specific steps that should be taken with the data in the component that uses the hook. This is a split which makes sense to me. Now, with that, we got the loading and the error state and the send request function in the custom hook, but ultimately these are all things which we will need in the component that uses the hook. That component should then have access to the loading and the error state, and it should have access to the send request function, so that it's the component which can trigger send request. Therefore, at the end of the custom hook, not at the end of send request, but at the end of the custom hook function, I want to return something to the component where the custom hook is used. And I mentioned before in this module that your custom hooks, of course, can return anything. Numbers, strings, arrays, objects. And here I will return an object. And there I will add a isLoading property, which points at the isLoading state constant. So this is the property name on the left side. This is the value on the right side. And that isLoading state, which is managed for the component by this custom hook. And I will also return an object with an error property, which holds the error state, just as the loading state. And then the send request property, which points at send request. So at this function here. And since I'm always using the same property names as variable names on the right side, we can also use a modern JavaScript shortcut here where we write this like that. That's the same result, or that will give us the same result as the code I had a couple of seconds ago. It's just a bit shorter, and it will be transformed to that longer syntax under the hood by JavaScript. So that's a shortcut we can use in modern JavaScript. And with that, we got our custom hook, at least the first version of it. Now let's see how we could use this custom hook. Back in the app component, I now want to use my custom hook. And therefore, first of all, we have to import it. So I import use HTTP from hooks use HTTP. Then we can get rid of the isLoading and the error states, because that's now a state which will be managed by the custom hook. So we can just call use HTTP here. Let me actually call this here after initializing the tasks state. Now, the custom hook needs some arguments, because we expect two parameters here, the request config and a function that is applied to that data, which we get back. So, therefore, we should pass that in. And for the request config, we pass in an object with a URL property, because inside of the custom hook, we are accessing a URL property here. And we then also later access method headers and body. And therefore, for the URL in the app component, I will pass in this string here. Now, in the custom hook, we also then expect a method headers and body. And the thing is that for app.js, I just want to get data, and therefore I want to send a GET request. I don't need any headers, and I don't need a body. And to be flexible enough and to not force all components to then pass in some dummy data or anything like that, I will go back to the custom hook and tweak this configuration here for the fetch request a bit. And in the case of the method here, check if request config method is set. And only if it is set, I apply it here. And otherwise, I set this to get as a default. For the headers, I will check if headers are provided on the request config. And if they are, I, of course, will apply them. Otherwise, I'll set headers to an empty object. And for the body, I'll check if request config body is set, in which case I will stringify it, so transform it to JSON, I mean. But if we got no body, I'll set this to null here. Now with that, the custom hook should be flexible enough so that use HTTP can just pass in an object that looks like this. Now that's not all though. We also need to provide a second argument, which is that function which receives the data here in the end. So therefore, I will define a function here. We could define it inline in the argument list, but to make it a bit more readable, I will define it here before I call use HTTP. And I will add a function which I'll name transform tasks. Here, I then expect to get my tasks object. And inside of transform tasks, I then want to apply the transformation logic which we had in use HTTP.js before. I deleted it there, but I still have it down here in app.js because I haven't deleted this code yet. So it's in the end this logic, lines 30 to 36 here in my case, which I want to copy and add here into transform tasks. And it's the tasks object through which I want to loop here with a for in loop, and which I use down there. And with that, we transform all the tasks from objects, which we get back from Firebase, into objects that have the structure and format we need for our frontend. And then we set our tasks state, which we can still do since we still have set tasks here. And we set our loaded task like this. And now it's the transform tasks function, a pointer at this function, which we pass as a second argument to use HTTP. And then this function will be called for us by the custom hook whenever we get a response. And this is the best of both worlds. With that, we have the main logic in the custom hook, but the data-specific logic in the component where we need the data. That alone still won't do the trick. Use HTTP does not just require parameters, it also returns something. It returns this object with the loading and error states and a pointer at the send request function, which we ultimately will need to call to trigger that request. So in app.js, I will get back my HTTP data here. You can name this constant however you want. And I will destructure it. by pointing at HTTP data, and we can pull out is loading, error, and send request. And of course, we can also do the destructuring right here and save that extra line. Now I will also assign an alias here, which is something we can do in JavaScript, by adding a colon here in this destructuring syntax and giving this a different name. And I will name it fetch tasks. So we're still pointing at the send request function from the custom hook. I'm just renaming it here inside of this component function. And with that, I will delete the old fetch tasks function in the app.js file. I will delete it like this, but I will keep useEffect here where I still call fetch tasks. Now here, however, I should add fetch tasks as a dependency now. We should have done this before, but before it wasn't really an issue because in the old fetch tasks function, I was only calling state updating functions, which are guaranteed by React to never change. And React noticed this and didn't warn me before. But React doesn't know this fetch tasks function, so this send request function at the end. It doesn't know what's going on in there, and therefore we have to add it as a dependency to rerun this effect whenever fetch tasks changes. At the moment, this would be a problem though, and therefore I will delete this dependency. We will re-add it later because this is not a good practice, but we will avoid this dependency for the moment because it would create an infinite loop right now, and we don't want that. And therefore with that, we now restructured the app component. We still get access to the isLoading and error states, which we pass on to tasks, to the tasks component down there. And we still get access to fetch tasks, but the logic for sending that request and handling errors and so on is now part of the custom hook. And therefore, if we save everything now, this should work again. And if I reload, it still loads all the tasks. And if I add a new task, that also still works. So that's now our custom hook being used. It isn't finished yet though, because as I mentioned, for example, here, we're not using it in a best practice way. Let's therefore do that in the next lecture. So we should add fetch tasks as a dependency here to useEffect, because you learned that basically every piece of data or function which is set up inside of a component function, which you are using in useEffect, should be added as a dependency. The problem with that, and therefore you shouldn't save this file yet, is that this would create an infinite loop. Why? Because we will call fetch tasks here, and this will then go ahead and execute this send request function in the custom hook, and that will then set some states. When the states are set, the component where we use the custom hook will be re-rendered. Because I explained that when you use a custom hook, which uses state, and you use that hook in a component, that component will implicitly use that state set up in the custom hook. So the state configured in the custom hook is attached to the component where you use the custom hook. So if we call set is loading and set error here in the send request function in the custom hook, this will trigger the app component to be re-evaluated because I'm using that custom hook here in that component. Now that, however, will then call the custom hook again when that component is re-evaluated. And when that custom hook is called again, I am indeed recreating the send request function, and I'm returning a new function object, and therefore useEffect will run again. And that happens because, as I explained earlier in the course, in the behind the scenes module, functions are objects in JavaScript, and every time a function is recreated, even if it contains the same logic, it's a brand new object in memory. And therefore useEffect would treat it as a new value, even if it's technically the same function, and it would re-execute it. So, to avoid this, we should go to use HTTP and wrap send request with use callback, which we can do also when we use async await in there. This is no problem. So we import use callback and then wrap this function here with use callback. Now use callback also needs a dependency array though, and this dependency array also should list everything which is being used in here. And in my case, that is, for example, that request config object, but also this apply data function which we're calling. Now, this poses yet another problem though. Since that is the case, we should add request config and apply data as dependencies here. But of course, both, again, are objects. Request config is a standard JavaScript object. Apply data is a function, which you learned also is an object. So back in the app component, where we're passing in this object and this function, we again have to ensure that these objects are not recreated all the time when this function runs again, which they currently would be. So here in app component, we also should import use callback and wrap transform tasks here with use callback, for example, and add our dependency array here. And here we don't have to add anything, because in here I'm not using anything external other than set tasks, which is a state updating function. And as explained multiple times in the course, these are guaranteed to never change. And if this is looking cumbersome, yeah, it can be tricky to get into. It might look like a lot of work, but it is something you're getting used to over time, and it is very logical in the end. It is simply related to how JavaScript works after all. Now with that, we're guaranteeing that transform tasks will not change all the time, but this object here will. We are recreating it here all the time whenever the app component is re-evaluated. So to work around that, we could look into use memo or anything like that to ensure that this object doesn't change all the time, or we change our custom hook again. Instead of accepting the request config here in the hook itself, why don't we expect it here in the send request function? After all, that is the function which is being called with that config. So we could expect this request config object not here in use HTTP, but here in send request. So here. Then we don't need to add it as a dependency here, because it's now a parameter of this wrapped function, not an external dependency. And therefore we got rid of this issue, and in app component, all we gotta do is take this object with the URL and remove it here, so that transform tasks is the only function we're passing to use HTTP. And we then go to fetch tasks, where we are sending the request in the end. Keep in mind that fetch tasks is just send requests because of this aliasing here. And we pass our config object here. That's something we could do. And of course, we could do something similar with the data transformation function. If using use callback here in app component is too cumbersome for you, if you don't like this approach, we can get rid of that and instead just pass transform tasks as a second argument to fetch tasks here and not to use HTTP, so that we call use HTTP without any arguments. And we actually create transform tasks. Whoops, get rid of the dependencies here. We create transform tasks like this inside of the effect. Then this also is no external dependency in the effect. And now we make sure that use HTTP, our custom hook, can be called without any dependencies or without any parameters, because we're passing the request specific configuration and the data transformation that should be applied after the request was sent directly to the request. And I showed both alternatives because both would be viable ways of doing it, and I also wanted to show you what the potential downfalls or disadvantages of the other approach are. Now, of course, we need to go to use HTTP and not expect apply data here as a parameter of the custom hook, but instead here for send request. And with that, of course, use callback here in our custom hook has no dependencies anymore, because all the data it's operating on is received as parameters in the wrapped functions. We got no external dependencies here. And with all of that, if we go back to app.js, we now have code that should run without an infinite loop and without any issues. If we now go back and reload, the tasks are still being fetched. And again, I'm fully aware of the fact that this can be confusing. I hope I could still explain why the different steps were needed. Of course, I could have shown you that final solution right from the start, but it is super important to understand that there are different ways of achieving this, and the other solution wasn't bad or wrong. This is just a solution which minimizes the number of dependencies, makes this a bit easier to manage, but the other solution would have been fine as well. And most importantly, I wanted to make it clear why we derived this solution now and why I'm going with this solution now. With all of that though, the hook is looking good and app.js works, but of course the main reason for adding the hook in the first place was to reuse logic across components. And here in the app component we're fine now, but we still got our new task component, where we also are sending a request. So let's use our custom hook there as a next step. So here in new task, I also want to use my custom hook. And therefore, first of all, we should import use HTTP from hooks use HTTP. Then we can call use HTTP, and we no longer need to pass in any parameters because of the refactoring work we did in the last lecture. Now we still get back an object though, which we can destructure, where we get access to isLoading, to the error, and to send request. And here I will rename send request to send task request. But that of course is up to you. We can get rid of the two states here now and of the use state import therefore, because we're using our custom hook for this now. Now in the enter task handler, we in the end want to call send task request now. We want to call that here because we want to send that request whenever enter task handler is triggered, which happens when that form was submitted in the end. Therefore, we will soon delete all that code, but before we do that, we need to ensure that we pass the proper configuration and data handling function to send request. And for this, let's start with the config object. I pass in a new object where the URL is set to this URL. And here now, since I want to set a post request, I'll also set the method to post. And I'll set the headers here to the headers object, which I got down there, like this. And I will, of course, also add a body, however, not as JSON, because we're doing that JSON transformation inside of the custom hook here. But instead, I will therefore just send in this object here, which I previously changed to JSON in the new task component. So that's my request config object now. The second argument is a function which takes the response data and does something with it. And the something I want to do with it is in the end this down here. I want to extract the generated ID, which Firebase gives me automatically. I want to create a task object which incorporates that ID, and I then want to call props on add task. So we could either create this function on the fly here, or we create it in advance, like this here, the create task function, let's say. And here I get my data, my task data as an argument. And then we grab this logic from down there, this logic, copy that, and add this here in create task. And data is now renamed to task data like this. And we now use create task to pass this as a second argument here to send task request. We don't need to work with use callback or anything like this here, Because we are only calling send task request in the enter task handler, not inside of use effect or anything like that. Therefore, here we won't have the problem of an infinite loop, because this request will not be sent whenever the component is re-evaluated, but only when this function runs, which happens when the form is submitted. That was different in the app component. There we sent the request inside of use effect, and therefore we had the danger of sending the request too often. In new task, we should be fine now. And therefore we can grab this old code here and get rid of all of that, so that inside of the enter task handler, I'm now only calling send task request, and we're configuring it like this. Now in my create task function, I'm missing the task text though. That's a problem. I'm missing the text which was, passed from the form to that HTTP request. We do have that text available here inside of enter task handler. To make it available inside of this create task function, which we pass to send task request, we got two main options. We could either grab this function and define it here inside of enter task handler to have a nested function inside of a nested function inside of the component function. And that would work. Due to how JavaScript scoping works, we now do have access to the entered task text. Or alternatively, we leave it like this to avoid this deep nesting, and we instead expect to get the task text as an argument here, as a parameter in create task text. And therefore we want two parameters here when actually our custom hook, which is calling create task in the end, only passes in one parameter. It only passes in data. To work around that, we could use the bind method in JavaScript. We could call bind here on create task when we pass it to send task request, and the bind method allows us to pre-configure a function. It does not execute the function right away. Instead, it's a default JavaScript method which you can use on any function object to pre-configure that function. The first argument you pass to bind then allows you to set the this keyword in the to be executed function, which does not matter to us here, hence we can set this to null. But the second argument you pass to bind will then be the first argument received by that to be called function. So if we want to pass in the task text here, we can set this to task text here, because that will then refer to the task text we're getting from the form submission. Now, the other argument, task data, will still be received here, because this is our pre-configuration. Any other arguments which might be passed by the place where the function is then actually being called, which happens in use HTTP, will then simply be appended to the end of the parameter list. So the data, which we pass here as the only argument to apply data in the custom hook, will be appended as a second argument on create task because of us calling bind here. So when it's being called, this receives all the data which is needed. And this is all just regular JavaScript. This has nothing to do with React or with hooks or anything like that. That's just regular JavaScript. You can learn more about the bind method and about pre-configuring functions with a resource which you find attached to this lecture. And therefore now, if I save this, we can reload and still load all tasks. But if I now send another task, if I click add task, we see sending here. And then we see, does this work? So if I reload, it's also still there. We can also see all that data on Firebase. Now if I open the console, I also got no errors there. And if we go to the network tab, we also see that indeed we are not sending an infinite amount of requests or anything like that. Instead, if I clear this and I test this, we are in the end just sending one request. It looks like two, but this is just a side request which is sent along the way. And therefore, this is all looking good. And that is how we can build a custom hook for sending HTTP requests. It definitely had its tricky parts, but with it, We now have this custom hook which outsources or which holds a lot of the duplicate logic, especially all that stateful logic, and we can use it in different components to send different kinds of requests and do different kinds of things with the response data and still utilize this shared loading and error state and this shared logic. This course section will be about forms and handling user input. Now, this might sound trivial, but once you take a closer look, you will see that a lot of web applications out there are all about forms. You are fetching user input basically everywhere if you take a closer look. And B, that can be more difficult than it first seems, especially providing feedback to the user. So making the user aware of some invalid input value and so on. All of that can be quite complex, especially, of course, if you want to get it right and provide a good user experience. Therefore, this course section is all about that. And we're not going to learn new React features, but we are instead going to apply what we learned over this entire course up to this point to build forms that feel great from a user experience and still have code that we can manage as a developer. Therefore, we'll first of all explore what exactly is complex about forms. We're then going to dive into how we may handle form input values and validation and forms overall with React. And we're also going to have a look at some tools and approaches that can make our life easier as a developer, because you will see that there is more complexity inherent to this concept than you maybe might have thought at first. Now, for this course section, attached you find a starting project which you can download, extract, and then run npm install in the extracted folder to install all the dependencies this project needs, and then npm start to start up that development server. And once you do that, you'll be greeted with this basic form, with this basic input. And that's what we're going to get started with. It's this simple input component which you're seeing. We also have a basic form component, at which we'll take a look later, but we're going to start with this simple input. And that is just a regular React component returning some JSX. To be precise, returning a form element, a form tag, and then one form input in there with a label and a button. Now, this course section will not be about how to write forms when it comes to HTML. So we're not going to dive into which HTML elements you could use, and we're not going to talk about accessibility here. We're also not going to dive into styling. I provide some basic styling here for you in this index.css file, which gives us this look here. But beyond that, it's up to you to, of course, style this and structure this however you want. In this course section, I really want to focus on React and what we do with React when it comes to forms. Because after all, this is a React course. So what's difficult about forms though? Forms might seem simple and trivial, but they are not. Forms can actually be complex from a developer's point of view, because forms and their inputs can assume a broad variety of different states. One or more inputs could be invalid or valid. And these are only two states. It's even possible that you could have forms where the state is unknown, because maybe you have some asynchronous validation where you need to send a request to a server behind the scenes to check something to find out if a certain value is available, let's say an email address, to then find out whether the input is valid or not. So it could be even more complex than shown here, but even here we have two states. And you must not forget that these states, valid and invalid, don't just apply to the overall form, but to every individual input in the form. And it's then the sum of the states of those inputs that make up the overall form state. Now, when a form and its inputs are invalid, you might want to output input-specific error messages and highlight the problematic inputs. And you also want to ensure that the form can't be submitted or saved if one or more inputs are invalid. If the inputs are valid, though, you of course want to make sure that it can be submitted and saved. Now, when we dive into showing error messages and highlighting invalid inputs, things get even more complex. Because the question then is when to validate. When should you check the user input? You can validate the user input when the form is submitted as a whole. You can also check the value entered by a user once an input loses focus, to then check what the user did enter there and find out if it is valid. And you can, of course, also do that on every keystroke or on every change the user makes to an input. Now, when you validate once the form is submitted as a whole, you, of course, allow the user to enter a valid value before possibly warning him or her. That means if the user starts typing in, let's say, the email field, you don't tell the user that the entered email address is wrong before the user even had a chance of entering one. So that's good. You wait until the user is done, and then you possibly show an error. So this avoids unnecessary warnings, but as a downside, the feedback might come a little bit too late. If I press submit, and you then tell me that something's wrong, I have to go back to that input where something was wrong and enter my value again. It's not the end of the world, but maybe not the final user experience we might want to offer. Now, when we validate an input when it loses focus, the good thing also is that we allow the user to enter a valid value before warning him or her, just as when we waited for the overall form. But we already do show an error then once the user is done with that specific input. So we don't wait for the overall form submission, but we just wait until the user is done with one specific input. This can be very useful for untouched forms, so where the user hasn't entered anything yet. The downside with this approach, however, if you only validate on losing focus, is that if an input was invalid, so if the user did already enter something invalid and now comes back to fix it, you don't tell the user if it's now valid or not until he or she is done entering an input. That's where on keystroke validation might be better. There you provide direct feedback to the user on whether the input is valid or not on every keystroke. But as a downside, you here warn the user before he or she even had a chance of entering valid values. So if you visit a forum for the first time and you haven't entered anything, you would be greeted with tons of errors if we only validate on keystroke, because initially everything is invalid, of course, and we haven't given the user any chance of entering anything valid. If, on the other hand, we combine this with the other methods somehow, and we only validate on keystroke if the input was invalid before, then we can provide direct feedback and therefore tell the user once the input is valid. And if this is all a little abstract, that's no problem. We're now going to explore these different approaches in great detail in this module, and we're going to see how things behave and how we can fine-tune this to come up with the best possible solution. Now, for all of that, let's come back to this simple input component. And let's start with getting the user input here. And let's then also validate that input and potentially show an error message to the user. And then we're going to explore the different ways of validating, so the different triggers for validating, to find out where the differences are and how we might best be able to combine everything. So let's start with fetching the entered value, the user input. And there are two main ways for doing that. We can listen on every keystroke and store the value in some state variable, so to say. Or we use a ref to fetch the input once the user is done typing in a value. And I'll show both here. Of course, in reality, you would only use one of the two approaches. But here I'll use both, and hence I will import useRef and useState from React. And then here we'll start with state. I can set up a new state, my entered name, let's say, by calling useState, and initially it's an empty string. And then we can update this entered name with setEnteredName on every keystroke or on every change that occurs here on this input element. So here we can add a name input change handler, such a function, which receives the default event object. That's how JavaScript in the browser behaves. Once we bind this function to the onChange event on the input, we automatically get an event object describing the event, and from there we can get the entered value. And therefore, we'll be able to set the entered name to event.target.value. And that's vanilla JavaScript, that we have access to this entered value on the event target, which will be this input. And event target will be this input because we can now bind the name input change handler here to the onChange event, so that on every keystroke this is fired, and hence the entered name state is updated. Then we can add a second function here, the form submission handler, and this, as the name implies, is triggered once the form is submitted. And there we also will get an event object, because I'll bind this function to onSubmit on this form, like this. Now here's one very important thing here you have to watch out for, and that is that on event, you should call prevent default here. Because again, we're dealing with some vanilla JavaScript and browser behavior, and the default behavior by the browser is that if a form is submitted with a button instead of a form, a HTTP request is sent to the server serving this website. That happens automatically. The browser does this automatically. It sends an HTTP request to the server which is serving this website. The problem with that is that here we don't really have a server that wants to do anything with that request. We just have a static server that serves our JavaScript and HTML files. So we don't want this request to be sent. And hence on this event object, which we get automatically passed into this function since we bound it to onSubmit, on this event object, we can call prevent default to tell the browser to not do that default behavior, to not send this HTTP request, and instead to do nothing. And we need to do that because if that HTTP request would be sent, it would lead to the page being reloaded in the end, and we definitely don't want that, because that would restart the entire React application, we would lose all our state, and we would definitely not have the behavior we want. So that's important. Then as a next step, now that we can guarantee that the page won't be reloaded and the app won't be restarted, we can console log the entered name. So the last name we stored because of our input change handler. And if we now save that all, and I go to my console here, I can type Maximilian here, and if I hit submit, that gets logged to the console. Now the alternative approach would have been to just set a ref on the input and read the value from the input when we need it. So since I'm importing useRef, we can implement this by adding a name input ref constant, for example, and assigning the value of calling useRef to it. And then we set name input ref as a ref to this input with the special ref prop, which React allows us to set on any HTML element. And here I then set name input ref as a ref. And now with that ref set up, when the form is submitted, we could have also gotten this entered value by reaching out to the name input ref and accessing current. On React refs, you always have a current property because refs are always objects with a current property, and it's this current property which then holds the value you assigned to this ref. So in this case, a pointer at this input element, that would be stored in current. So since the value in current is that pointer at the input element, we can also access .value here, because input elements in JavaScript, the JavaScript objects representing these HTML input elements, always have a value property which holds the value currently entered in that input. So that's how we can read that entered value from that input. And we can store this in entered value, and then simply output this here. And if I do that, and I reload, and I type max, we see max twice. The first output is coming from our state, the second output from our ref. Now, in reality, you of course wouldn't do both. You would do one of the two approaches. Either every keystroke logging with the state, or something similar, or you use a ref to read the value when you need it. Now, how do you decide which one to use? It depends what you plan to do with the entered value. If you are only interested in it once, when the form is submitted, a ref might be better, because logging and updating the state value with every keystroke is a bit overkill then. You don't need to do that if you only want the value once. However, if you of course need the value, the entered value, after every keystroke, for example for instant validation, then using the state is better, because with a ref you can't really do that. Another reason for using a state instead of a ref could be if you want to reset the entered input. Let's say here at the end of the form submission handler. There we can reset the entered name by calling setEnteredName and setting this to an empty string. And all we now need to do is bind the entered value back to the input through the value prop. The entered name is now bound to the value prop on input, and hence if we update the entered name, that will be reflected here. This works great when using state, but it's not really possible with refs, at least not as elegant. With refs, you could also use your ref and access the input element which is stored in that ref and set value equal to an empty string, but this is not an ideal way of doing it. It works, if I comment out this, it works as you can tell, but it's not ideal because we are directly manipulating the DOM here. We're using some vanilla JavaScript code to directly reach out to the DOM and change something there, and that is typically not something you should do. You should leave that up to React. React should be the only thing manipulating the DOM, and therefore this is not ideal. Don't manipulate the DOM. You can do it, and it might be okay. It's up to you ultimately, but it's not a very clean way of using React. So that could be another reason for using state, which you potentially update on every keystroke, because maybe you want to reset the entered value. But that's not even the main topic of this module. Now we know how we can get the entered value and when we might want to get it. But this module is about more than that. It is mainly also about validation. And that's something I want to dive in next. How can we validate this user input, and how do we best do that? So in this input here, we might want to add some validation, so that, for example, I can't submit this form when the input is empty, because then I would get 2 empty logs here, and whilst we only have logs here, in most cases we would probably send that data to a server, and we don't want to send empty data to the server. Though I also already want to say, the client-side validation which we're doing here, where we validate in the browser, isn't everything you should be doing. If you have a real website, a real web application which you're building, then validating in the browser, as we are about to add it here, is great for the user experience, because you give the user a direct feedback. But you also always should validate the input on the server, because this code here on the browser, this can all be edited by your users. I can dive into the source code and change this raw JavaScript code. So this is not reliable. It's just there for providing a good user experience. It's not a security mechanism or anything like that. And I have an article and video on that, which you'll find attached, which also might be helpful when it comes to JavaScript in the browser and the security implications of doing things in JavaScript in the browser. But that's a side note. Let's come back to how we could validate this. How could we make sure that we, for example, show an error and don't log the values to the console if we try to submit an empty field? Well, of course, we can go to the form submission handler, and there we can add a if check. Here we can add a if check, and we can then simply check if the entered name, and here I'll go with that state value now, if that entered name is empty maybe. We also might want to call trim on that entered name string to remove any excess white space at the beginning and end. Now, of course, the exact validation logic you need depends on the form input value you are expecting. If it's just some name, you might be fine with just checking that it's not empty. For an email address, you might want to validate that it's a valid email. But I want to keep it simple here, so I'm just checking for it being empty or not. Now, if it is empty, if we have an empty string here, then I don't want to continue with the next lines of code. Because here we are using the entered value, and I don't want to do that if that value is empty. Hence here, I want to return, which returns from this overall function and therefore cancels the function execution. Now, the rest of this function will not be executed. So if we save this, and I reload to clear my log, if I now hit submit here, you see nothing gets added here. Not even empty console logs. There's nothing here. If I do enter something though, we still see that. So that's working. But what we're not doing is we're not showing the user feedback. We're not showing the user that something went wrong. Of course, users don't have the developer tools open, so if I'm a user visiting this page and I click submit, I don't know if anything happened or if my input here is invalid. I might be able to guess that an empty input is invalid, but I get no feedback from the app. So that's why we might want to show some error feedback. And we can, of course, implement such a functionality with React as well. To add some basic validation, we can manage more state. We can add a entered name is valid state and a set entered name is valid state updating function, which we get from use state. And here we now want to start with false, so that initially the entered name is not valid. And we can then set this to true if the entered name is valid. So therefore, here in the form submission handler, if the input is invalid, then I want to set entered name is valid to false, because it is not valid here. If we make it past this if check, we can set entered name is valid to true, because if we make it past this if check, the value is valid. And now we could use entered name is valid to show an error message. Here, below this input, inside this form control div, we could add a paragraph where we, for example, say name must not be empty. And I only want to show this paragraph if entered name is valid is false, so if it's not valid. Now we of course learned how we can show content conditionally in React, and hence here we can apply what we learned. We can check if not, hence the exclamation mark, entered name is valid, and if that's the case, we output this paragraph, otherwise we don't do anything. And we can give this paragraph a class name of error text, because that's one of the predefined CSS classes I added here in index.css for some basic styling. With that, I get this error. But now I also get this error before I even start typing. So maybe we instead want to start with setting this to true initially, so that entered name is valid is true initially. With that, if I save here, we don't see the error message initially, but if I click submit, it now shows up. So this would be one way of adding basic validation to this form and of making sure that we give the user some feedback if things go wrong. Now I actually prepared more validation feedback which we can add, and that affects this CSS class which is added on that div, that form control class. I'm not using CSS modules here, but old school CSS classes which are set up globally and then simply used here. I did prepare a special invalid CSS class which affects the input look, and therefore I want to swap form control for form control and invalid if this input is invalid. So here I could add a const name input classes, and that depends on whether the entered name is valid. If that's true, then I want to add just form control as a class. Otherwise, I want to add form-control and invalid as classes. And now class name here is dynamic and points at name input classes. Name input classes. So these classes which we're deriving here. And with that, if I save this, if I reload, we got this look. If I submit this empty form, I get this look, which looks a bit better. Now that is some perfectly fine validation which we could add, but it has some downsides at which I now want to take a closer look. One downside of the validation we added thus far is our code, specifically this line. We have this entered name is valid state, and we start with true here, which implies that initially we treat this as valid. And it turns out that that's not really the case. We just set it to true to not show this error state here ahead of time. But actually we're cheating a bit here. We're setting this state to a value that's not correct because we know that we're not going to really need that state for anything else than outputting whether this is valid or not. Now, why could this be a problem? Well, imagine you had some useEffect call in there where you do something whenever entered name is valid changes, and specifically you do something if entered name is valid is true. So if it's true, you want to do something. You want to, in this case, log name input is valid. In a real application, you might want to send an HTTP request here. So let's say we add this, and for this I import useEffect. If I do that and open the developer tools, you see that this gets logged right at the beginning before I did anything. Because of what I just explained, we incorrectly set this state here to true. And it isn't valid at the beginning. That's just not correct. We just did this as a workaround to correctly show the error feedback. Now, if you don't have this useEffect case here, you of course might be good with that, because then you have no real disadvantage of using this trick. But even then, I don't think this code reads nicely. Entered name is valid is true? Really? At the beginning? It might be nitpicking, but I'm not too happy with that. I think it makes more sense to set this to false initially, because the input is invalid initially. Hence, we might want to add a third state here, the entered name touched state maybe, and set entered name touched, where we basically control whether the user already did edit the entered name input field. And this also is false initially, because initially this input field is untouched. The user didn't do anything with it. So now we can use entered name touched in combination with entered name is valid to show this error message and to add this invalid class. Because now we don't just care about whether the input is invalid or not, but we also care about whether the user had a chance of editing it Because if the user didn't have a chance yet, because the user didn't touch any input yet, then of course there is no reason to present this error. For this, I'll add a new constant here. Name input is invalid. And for this, I'll check if not entered name is valid. So that's the check we also have down there. But I'll combine this with checking if entered name touched is true. Because only if it was touched and it then is invalid, I want to treat it as invalid. And now it's this name input is invalid boolean, which I can use in this condition here and also down here. Though now we have to be careful, since this is now name input is invalid, we of course need to invert our logic here. Here we don't check if it's not invalid, but if it is invalid. Hence I removed the exclamation mark. And here I of course want to set this invalid class if name input is invalid and not set it otherwise, like this. With that, if we go back and we reload, initially this is not showing this error state, but if I click submit, it's also not doing that. And of course it's not doing that because we never changed this touched state. We now need to do that. And it's now up to us how we want to change this. And one change definitely is the form submission. If the form is submitted, all inputs are treated as touched. Even if the user didn't type into them, the user submitted the overall form, which basically means the user confirms the overall form. So we could treat all inputs as touched in this case. So whenever the form is submitted, before checking the validity, just when it's submitted, I'll set entered name touched to true. Because all the inputs, and in this case we just have one input, are touched, are confirmed by the user when the form is submitted. With this added, if we now click submit, we get this error state once we submit. And this is now a little bit of a better code. It's more code arguably, but it's cleaner. And it allows us to handle more use cases. And it also allows us to ensure that code like this here works correctly and doesn't run unexpectedly just because of some strange workaround. Now, up to this point, we're still on the left side of this slide. We are always validating when a form is submitted. We're not validating when an input lost focus or on every keystroke. Now, of course, that could be fine. That could be exactly the behavior you want. But let's now explore why we still might want to tweak that behavior in regards to certain aspects. We have the entered name is valid state, the entered name value state, so to say, and the entered name touch state. And still, this behavior isn't fully there where I want it to be. It's good that on submission it now shows us this error, but for example, it doesn't show us an error if I click in there, maybe type something, but then remove everything and click out of there. We know that this is invalid because an empty input is not allowed, but we only show the user this error message when submit is clicked. And that might be too late. That might not be the best possible user experience. I think it's better to show the user this error when the user had a chance of working on this. So if I click in there and click out of there and I leave it empty, I want to see that error that tells me that this is then not allowed. Because I had a chance of editing it, I didn't do that, now I should probably get that error that tells me, hey, you need to enter something here. So therefore, we might want to also validate on blur, as it's called, which means when the input loses focus. And that's not too difficult. Besides the onChange handler, we can also add the onBlur handler. And that's a built-in event which fires whenever this input loses focus. Hence, we can add a new function here. Let's say the name input blur handler, where we also get the default event. And then I want to bind this name input blur handler to my input here. Now in the name input blur handler, I want to do two things. For one, I want to set entered name touched to true, because if our input loses focus, it definitely was touched. The user had a chance of working on it. But in addition, we might want to start validation here. So we might want to run this logic again. So we can copy this code here and add that in the name input blur handler, so that we check the entered name, which we update with every keystroke still, and we set entered name is valid false if that name is invalid. Now we do have code duplication here, and we'll take care about that in a second, but for the moment let's take this approach here. Let's duplicate the code. It's fine for a second. So now with that, if I click in there and click out of there, I also get my warning here, which I would say is a better user experience. But now we maybe want to give the user a chance of fixing this error. And if I now start typing here, it would be great if this error disappears as soon as I entered a valid value, so that I as a user know once I did reach a valid value, once I can stop typing, for example. And that's why we also might want to validate on every keystroke now, but only in combination with the other validation steps we integrated before. Because just validating on every keystroke alone would probably not be good. We would be throwing errors at users without them having a chance of providing something valid first. But now that we do actually allow the user to provide a valid value first by listening to the lost focus and the form submission, now that we're doing that, we also want to give the user a chance of getting immediate feedback, direct feedback on every keystroke when it comes to fixing that invalid value. So that's what we're going to do now. So now I also want to validate on every keystroke. Hence, we can also copy this validation logic to the name input change handler. But actually, doing it like that would be incorrect, because here we check if it's not valid and set this to not valid if it is. But actually, of course, I want to check if it is valid on every keystroke to get rid of that validation error as quickly as possible. Hence, here, I want to check if it's not equal to an empty string and then set entered name is valid to true. And we don't need to return here, by the way, because there is no code to execute after the if statement. The same here in the blur handler. We can get rid of return there. So now in name input change handler, we are validating the input. We are setting this to true as soon as we do detect a valid input. Though here, as a side note, we shouldn't use the entered name state, but instead event target value, because we do update the entered name state with this line, but as you learned, such state updates are then scheduled by React. They are not processed immediately, so in the next line thereafter, you don't have that latest state yet. Hence here, you would be referring to an old state if you used entered name. So therefore, instead of doing that, we should use the same state data source we used for updating the state in the line before, which is the event target value here. Now with that, if we save this, if we start typing here, with every keystroke, we update this. So now we might have the best possible solution here. Now we get this instant validation once it blurs or once we submit. But then if we have an error, so if we do, for example, blur with an invalid value, we do give immediate feedback and allow the user to directly fix this with every keystroke. And I think this is a rather good user experience. What's not so good, though, is our code, because we wrote a lot of code for just one input. Now, there will be ways of reusing logic, and I'll come back to those, but I want to start with cleaning up that code here a bit, because that is definitely not the code we want to write to achieve this behavior. So what's problematic about this code? Well, we have a lot of repetition, and we have a lot of code in general just to handle this, and it just doesn't feel like the shortest possible way of writing this. And indeed, it isn't. Now, of course, one tiny piece of code we can get rid of is that code here where I use my input ref, because I am using state here to get the value, There is no need to keep the input ref around. But that's just a small thing, I will nonetheless remove it. But that's not the main thing I want to change. Though here I will therefore also delete name input ref, remove the use ref import, and down in the JSX code, remove this ref assignment. But again, that was not the main thing. The main thing instead is this general validation logic with all those different event handler functions and what they're doing. I think it doesn't have to be that complex. In the end, we must not forget that it is all about finding out whether the input is valid and if it was touched. And if it's invalid and was touched, we want to show the user an error. Otherwise, we don't want to do that. Since that is the goal, we actually don't necessarily have to manage a separate entered name is valid state. Instead, let me get rid of that dummy useEffect call. We don't need it here. Instead, we could add a derived entered name is valid constant here and get rid of that state here and just work with the value and the touched state. Because entered name is valid is simply something we can derive from the entered name state. And since this entire component function will re-execute whenever a new value is entered, we ensure that this constant will always take into account the latest value and touched state. Because whenever one of these two states changes, this component function gets re-rendered. So here in entered name is valid, I want to store the result of checking entered name, so this entered name state here, dot trim being equal or not equal to an empty string. Because this is entered name is valid, and that should be true if this here yields true. If the trimmed entered name is not empty, then entered name is valid. This means that we can get rid of all the parts of the code where we set entered name is valid, because deriving this result from the already existing states like this is enough. And here I do set entered name, hence we ensure that the component function gets re-rendered and gets re-evaluated on every keystroke, which is exactly what we want here. Now what about this name input blur handler? Well, in the end here, I also don't need to validate this. Instead, we can delete this and we can rely on this inferred state combined with this inferred value down there. Name input is invalid, which takes this inferred constant into account. The entered name is valid, which is based on the entered name value, and combines that with entered name touched. And to make this a bit easier, I'll move that constant right below entered name is valid. So these two lines of code now work together. We first find out if the entered name was valid, and we then check if it's not valid and combine that information with entered name touched. So now we still get these values, but we have to manage one state slice less. We don't have to manage the state validity. Now in the form submission handler, we of course still want to keep this if check around though to cancel the form submission if the input is invalid. But here we don't need to set the validity. Instead here we can simply check if entered name is valid is false. So this inferred variable, if that's false. If it's not valid, I want to return. I can do this here because this function, this form submission function, this handler function also gets recreated when the component function is re-evaluated. So this form submission handler function will have access to that latest inferred entered name is valid value here. And here where I then set entered name is valid to true, that is also not needed here because we got all the code related to that which we need already in place. Now, with all of that, if we give this a try and reload, if I submit, we still see that it's invalid. If I click in there and out of there, we see this. If I enter something, this behaves correctly. But if I then submit, if I submit a correct value, it jumps back to showing me that this is invalid. And that's not a bug, but simply a result from the code we wrote here, where we set entered name to an empty string, and that indeed does result in entered name being not valid. But the fix is simple. We just also want to reset the touched state once we submit the form. So after set entered name and setting this back to an empty string, I want to set entered name touched back to false to reset the touch state. Because once the form is submitted, it of course should again act as if it wasn't touched at all, because it's a brand new form now in the end. So if we add this and then go back, now if I submit this form, it's not showing me the error again. And we now definitely slimmed down that code and have a way more readable and manageable code. And I know that it took quite a lot of steps to get there, but I wanted to make it clear what the thought process is here and why we are doing it like that. And let me get rid of that useEffect import, which we don't need anymore. With that, we have a relatively lean component here, which manages the input value and the touch state, and then derives the validity from those states. So I'm happy with my form behavior here, or with the behavior of this input, but there's one thing which we must not forget. This is one input of an overall form, and in this case, of course, it's the only input. But often you would have more than one input, as we're also soon going to see in the basic form JavaScript file. And for such scenarios, of course, it would be good if we also could find out if the overall form is valid. In the one input case, the overall form is always valid if the one input is valid. But if it's a form with multiple inputs, that's of course not the case. Then 3 of 4 inputs might be valid, 1 input might be invalid, and the overall form then also would be invalid. Because the overall form is only valid if all form inputs are valid. And as soon as at least one form input is invalid, the overall form is invalid. And that's therefore something we should take into account and also incorporate into our logic. But how can we do that now? Well, here's one way of doing that. We can add a new state, which is form is valid, and it has a set form is valid state updating function. And initially that's false, because initially that form isn't valid. Now I want to update this overall form is valid updating function whenever one of the form inputs changes. And for that we could again use useEffect. So I'll bring back that import, and I'll then add a useEffect call here below those 2 constants here. And in this useEffect call here, I want to set the overall form validity. For this, I'm interested in the validity of my form inputs, and hence I'll add all the form input validities I have in this form here. So for example, the entered name is valid, constant. If we had 2 form inputs here, we would have another constant. For example, for the entered age is valid. And then I would enter entered age as is valid as another dependency here. But we don't have that here, hence it's only one entry. Now that's the dependency of useEffect, and as you learned, whenever the value in such a dependency changes, this effect runs again. And it also runs for the very first time this component is evaluated. So in this useEffect call, I then basically want to combine all my dependencies and check if they are all valid, and if they are, I want to set the overall form to valid. So here I'll check if entered name is valid, and I would add other validities if we had them, like entered age is valid, and check if that's true as well, but we don't have that here. And if it is valid, then I'll set my overall form as valid. Else, if at least one of my inputs is invalid, I'll set my overall form to invalid. So I'll set form is valid to false. And then we could use this value as well. For example, if we wanted to disable this button. Here we could set disabled equal to not form is valid. So the button is disabled if the form is not valid. Now for this, I'll quickly add a style for this. So on the button here, I'll just set a disable style, which also should apply if the button is then hovered or set as active. And I'll simply add a background color of a light gray here, and a text color of a slightly darker gray, like this, and a border color of that light gray as well. And I'll set the cursor to not allowed. But that's just some CSS styling for this. With that added though, and with disabled being set, you see this button is disabled at the start. It also stays disabled, but if I enter at least one valid character, it becomes enabled. If I invalidate again, it's now disabled again. Now also the form can't even be submitted anymore if it's invalid. Now it's up to you whether you want to disable the button or not. You'll find opinions in both directions out there in the web. There are also people which argue that you should allow your users to submit an invalid form, to not restrict them without them knowing what they have to enter, but that is up to you. I just want to show you how you could build something like this and how you could manage the overall form validity in addition to the validity of the individual inputs, because that can also matter. Of course, if we take a closer look at this useEffect function here though, we don't even need useEffect. We're not performing any side effect in there. We're doing nothing that would be a problem if we would do it without using useEffect. All we're doing is deriving a new value, just as we're already doing it in lines 7 and 8 with entered name is valid and name input is invalid. So we're basically doing the same here, just for deriving the overall form validity. And of course there is no reason to use useEffect here for that. We can, but it really doesn't add anything, it just adds extra component re-evaluation cycles. And that's of course not an advantage. Instead, we can get rid of that form is valid state, and we can get rid of useEffect, and just check if entered name is valid, and any other properties we might have here, like a entered age if we had that. And then we simply add a new variable here, form is valid, which by default is false, let's say, which we then set to true here in this if case, and which we set to false here in the else case. And actually we don't even need the else case now, because that is our default. And we only override this with true if all our input states are valid. So this again allows us to slim this down even further. And I'm showing this because thinking about possibilities like this is also worth it and is a good thing to do, because it allows you to write slimmer code and maybe even more performant code. So with that, we still got the same behavior as before, but now with less code. So as mentioned at the end of last lecture, we have a working code here, but we have a lot of duplication. We're not duplicating the exact same words. These constants are named differently. This logic here is different. But the overall logic, the overall structure is of course exactly the same. And if we think about a more complex form like this one, which actually isn't too complex, but which has at least 3 inputs, then we would be repeating that same structure, that same code in the end, 3 times. And that's not what we want to do. So instead, we typically want to outsource some logic somewhere. We don't want to retype and repeat it all the time. And how can we best do that? You could consider creating a separate input component so that you replace this code down there with the input component, and inside of that input component, you then have that logic for validating it, for checking its touch status, and so on. And that would probably work. That is something you could do. The only thing that could become a bit more tricky then, or where you would need to find a solution, would be for managing the overall form validity. Because if you manage every input as an individual closed thing, and you know if the input is valid or not, you then also need a way of letting the overall form know if it's valid or not. And that could certainly be done with props and passing functions to props and calling them from inside the input component and so on. But there also is another approach which I tend to prefer here, and that would be a custom hook. We can use a custom hook to manage all that state logic in there. And let me show you how we could do that. For this, I'll add a new folder in this project here. I'll name it hooks next to components. And I'll then add a useinput.js file because it will be a hook for managing the state and the logic for an input. So in here, I'll add my useinput hook function, and I will export it as a default here. And now in this hook function, I want to manage the value of a given input, the touched state. I want to infer its validity, also combined, of course, with the touched state. Now, of course, this hook should then also be flexible, though. The concrete validation logic should be passed into the hook from outside. But that is something we can build. And I'll start by copying the entered name and entered name touched states here and add them in the useinput function. For this, of course, here in this useinput.js file, we need to import useState from React. Then I'll rename this here to entered value and set entered value to make it more generic. And that here is touched and set is touched. Now, as a next step, we can copy our inferred state here, so to say. So these two constants, entered name is valid and name input is invalid. I'll copy those and also give those better names. I'll name the first one value is valid, and the second one could get a name of has error, because in the end here we control whether an error should be shown or not. Now for value is valid, I check the entered value here, and for has error, I then use value is valid, and if it's not valid, combined with is touched, I find out whether we want to show an error or not. Now this validation logic, however, shouldn't be hard-coded here. Instead, I want to get the logic for that from outside, where this hook gets used. But that's no problem. We can expect a function as an argument to this custom hook function. Let's say the validate value function. So I expect that this parameter receives a function as a value. So that here, for value is valid, I can execute validate value and just pass in the entered value we currently have. And then this hook could return something. It could return an object, could also be an array, but one of the two because I want to return more than one thing. And in this object, I'll return the value, which is the entered value. I'll return has error, which holds the result stored in has error. And since we got the same names here, we can use the modern JavaScript syntax of just listing this once, and it'll automatically be expanded to this here behind the scenes. And we will also need a way of letting the component that uses this hook set the entered value and set the touched state thereafter. Now, for that, we could go back to simple input and copy the name input change handler into useinput as a function, and copy the name input blur handler into our hook function. And rename the functions to value change handler and call set entered value here. And then also input blur handler and call set is touched here. And when we return, I want to expose those functions. So I'll expose the value change handler and the input blur handler, so that these functions, which are defined in the hook, can be called from the place where the hook is being used. So can be called from the component that uses that hook. Now with that, we can use this custom hook in the simple input component. There, we can now import use input from, going up one level, hooks use input, and then call use input here, and then extract values from the result returned by use input. Use input returns such an object, hence we can use object destructuring to pull out those keys from that returned object and store the values in brand new constants. So we can, for example, extract the value and then also assign an alias with the colon here and name this entered name, and also pull out the has error state and maybe name this name input has error. Those aliases, of course, are up to you. And also extract the value change handler and give this an alias of name changed handler, and get access to the input blur handler and give it an alias of name blur handler, or something like this. So that this is how we use the hook. But we also need to pass a value into the hook, and that's this validate value function which we call here. So for this, we could define an inline function here where we get some value and then return the result of calling trim on that value and comparing it with an empty string. So the logic we have down there, just with value instead of entered name. Now this is an anonymous arrow function, which is not executed here, but defined here in line, which is then passed to use input. So it's received on this validate value parameter. And then this function here, which we define here, is actually executed in this line here. That's where it's being called. And the entered value, which is this state we're managing here, is the value passed into this function. Can be a bit tricky to wrap your head around, but in the end, it's just regular JavaScript where we are passing a function as a value to another function. And with that, we can customize the validation logic in the component where we need this hook and still execute it inside of the hook. And that now allows us to get rid of these two state slices here for the entered name. It allows us to get rid of these two constants here. Entered name is valid and name input is invalid. And instead use these pulled out constants here. And for example, here we are then actually missing information about the validity. We know if there is an error or not, but that's not just the validity, but the validity combined with the touched state. And therefore, to expose just the validity of an input to the component, I will actually also return value is valid here. Maybe on a is valid key, so that we also expose that information from the hook to the component where we use it. And then in the component, we can also extract is valid and store this in a entered name is valid constant by assigning this alias. And then entered name is valid can be used here again. Now we can get rid of the name input change handler function here and of the name input blur handler. And instead we'll use the name changed handler and the name blur handler, which we're getting out of the hook. So down there in JSX, I connect the name change handler and the name blur handler. Here, instead of using name input is invalid, I will use name has error, name input has error, which we're also getting from the custom hook. And then here, for the form submission handler, where I want to change the touch status and where I want to reset the form, we can get rid of this line of code because the form can't be submitted if the inputs are invalid anyways. So we don't need to mark the inputs as touched here. But of course, we want to be able to reset the form, and therefore we can go back to the custom hook and add a third function here, a reset function, where we simply call set entered value and set this to an empty string, and set is touched and set this to false. And then we just need to expose that so that we also return the reset function as a value in a reset key in that overall returned object. And in simple input.js, we can then get access to this reset function and maybe name it reset name input, give it this alias, and in the form submission handler, we can then just call reset name input here. Now down there, where we infer the CSS classes, I now want to use the name input has error data piece, which we get from the hook. And with that, if we reload, this name behaves just like before, and the overall form also behaves just like before. If I enter something valid here, we can submit it. If this is invalid, we can't. If I reload, if I click in there and out of there, it's invalid. This all works like before, but now with a custom hook, and now we can therefore also replace the email state, the entered email state, with our custom hook. Feel free to try this on your own. We're going to do it together in the next lecture. So let's now also use the custom hook for the entered email. For this, I'll call useInput here, and we get back this object with all that data we can pull out and use here. For example, the value which I'll assign to a entered email alias. The isValid value which I'll assign to a entered email isValid alias. We'll get hasError, which I'll assign to the email input hasError alias, and reformat this to make it easier to read. We'll get the value change handler, which I'll assign to email change handler, and the same for the input blur handler, which I assign to email blur handler, and then reset, which I'll assign to reset email input. We also need to pass in our validation function, and hence I'll grab this logic, and then again, define a function here, inline, which gets a value, which will be passed in from inside the hook, where I then return the result of calling includes at on this value. This determines whether this is valid or not. With that, I can get rid of these two lines of code. We can get rid of these two lines of code here. And then here, for the overall form validity, we already are using entered email is valid, so that works. We can get rid of the email input change handler and the email input blur handlers. Here in the form submission handler, we also, of course, want to reset the email input. And then here, I want to use the email input hasError field to determine the CSS classes. And if we scroll down to the JSX code, here I want to use the email change handler and the email blur handler and the email input hasError field here. And with that, we're using this hook for the email input as well. We can also get rid of the use state import now, because here I'm now not using use state anymore. And with that again, if I reload here, this both behaves as it did before, but now with less code duplication here. Now we have a working code here with help of our custom hook, which we can call and pull out the values which we need, where all the logic then resides inside of that hook, and hence our component can stay a bit leaner and can focus mostly on the JSX, on validating the overall form, which is fairly simple, and on handling the form submission. Now, again, let's practice what we learned. We have this basic form component here. Let's go to app.js and swap this simple input here for the basic form component. And of course, therefore also add the import here to basic form from /components basic form, so that if we save that, we got this form. Now, this is still a form, still not too fancy, but it of course now has 3 inputs instead of 2, and it's a brand new form without any validation at all. And I now want you to again apply what we learned If possible, of course, without looking at simple input, at least not in great detail. And use our custom hook here, or if you're feeling super fancy, try building up that custom hook from scratch again, to again practice what we did over the last lectures. So start with the validation here by using state in the basic form, start with validation for the individual inputs, then build your custom hook, and then start using that hook for the inputs. If you're getting stuck with that, simply go back to the previous lectures to see how we built up the validation logic and the custom hook step by step there, and then try it on your own again. Once you're done with that, continue with the next lecture, because there I will wire up this brand new form to our custom hook and then take it from there. Were you successful? I really recommend that you have a look at those last lectures again to fully understand how you manage entered values, validity, and touch state, and combine that all with different event handlers to make sure that you deliver the user experience you wanna deliver. Now here, in this case, I will continue with that finished custom hook which we built already. I will not build up that entire logic again from scratch, because I feel like I would basically just be wasting your time if I did that, because it's just what we did in the previous lectures. But I do want to apply the custom hook here one more time to really show you how you could do that in a brand new empty form. And therefore, we start by importing use input from, going up one level, hooks use input. And we then, of course, call use input here. And we call it 3 times because we have 3 inputs here. Now, the validation logic for these 3 inputs is up to you. I didn't give you any restrictions or guidance there, but it makes sense to ensure that these inputs aren't empty and that the email address is an email address. So for that, for the first 2 inputs, I'll check if the value we're getting is not empty if we trim it. And since I'll use the same function here, rather than copy and pasting it like this, I will create a new function outside of the component function, because that's not a function that needs to be rebuilt if the component is rebuilt. And I will name it isNotEmpty, store my function in this constant, and then just pass this constant here, which holds this function in the end. So this is really just the function outsourced into a separate constant. And I can do something similar for the email, isEmail. And here I get a value and check that this includes an @ symbol. And then I pass isEmail to the third use input call. Now the custom hook returns an object, as we learned, and that object is full of data which we can use. For example, it contains the value. And we might want to use the value here to be able to reset it once the form is submitted. So here, this is for my first input. I'll have the first name value. Then we get isValid, so this is first name is valid. And I'm assigning these aliases here because I'm going to extract the same keys 2 more times. So we need aliases to avoid name clashes. And here we also get the value change handler, which I'll alias with first name change handler. I get the input blur handler, which I pull out, which I alias with first name blur handler, and the reset function, which I'll alias with reset first name, like this. And then I'll copy this here, this code, and repeat this here for the second use input call. But of course here it's the last name value and the last name is valid. And here it's therefore also last name change handler and last name blur handler and reset last name. And then copy and paste it one more time for the last input. And that's the email value, and the email is valid. And here it's the email change handler and the email blur handler. And here is reset email. And now with that all done, we can go down to the JSX code. And on the first input, for example, bind our first name value. For onChange, we bind first name change handler. And for onBlur, we bind the first name blur handler, like this. Then for the second input, we bind value to last name value, onChange to last name change handler, and onBlur, unsurprisingly, to last name blur handler. And then here for this input, I bind my value to email value, onChange to the email change handler, and onBlur to the email blur handler. Now, I also want to show error messages if appropriate, and I want to show different class names or add different class names, and I also want to disable the submit button if the form is invalid. So let's start with the class names and the error texts. For this, there's one other field we can extract, and that's the hasError field, which I'll store in a first name hasError alias. And here on the second use input call, it's last name hasError. And here on the third custom hook usage, it's email hasError. And it's this hasError field which we can now use, because now we can infer those class names, for example. Here I have my first name classes, and for that I'll take my first name hasError key, and if I have an error, I'll add a class of form-control invalid, otherwise just form control, and I will repeat this error for last name classes and email classes. And here we then have the last name hasError and email hasError. And then here we bind our first name classes, and on the second div we bind the last name classes, and on that last div we bind the email classes. Now for the error messages, we simply go to the first input where we might need an error message like, please enter a first name. And here we check if first name hasError, and if that's the case, we show this paragraph, otherwise not. And I then copy that logic to the second input where I say, please enter a last name, and I check for last name hasError. And we copy it one more time to the email address where I check for email hasError, and I say, please enter a valid email address. So now that's all wired up. Now for the overall form validity, we can again derive that state. We can add a form is valid state, which initially is false. And then we check if the first name is valid and the last name is valid and the email is valid, and all three have to be valid, and only if they are all three valid, I'll set form is valid to true. If at least one of them is not valid, the form will stay invalid. So now we have the form is valid state. We can use that to disable the button, for example, to set disabled to not form is valid. If the form is not valid, the button is disabled. Last but not least, for the form submission, which I also want to add here, I'll add the onSubmit handler and then simply add a new function here. Submit handler could be the name, where I get an event. And as you learned, we call event prevent default here to prevent that browser default of sending a request. And then I check if the form is not valid. And if it's not valid, I return. And that's, by the way, new. In simple input, I didn't do that in the form submission handler. There, I was still checking for the entered name only. And that was an oversight from my side, but of course we can't even reach that handler since the button is disabled anyways. Nonetheless, adding that extra check here might make sense because the user could theoretically enable the button with the dev tools, which of course is not really what the user should do, but it could be done. So having the extra validation step in here still also could make sense. And then thereafter, if the form is valid and we made it past this check, I will console log submitted, and then also console log my values. So the first name value, the last name value, and the email value. And then I will call reset first name, reset last name, and reset email. Now we can wire up the submit handler here, and we should be good to go. If we save everything and go back here, the button is grayed out by default. If I click in there, I get this error, and this error, and this error, and the errors are not red because I forgot to assign the right CSS class here. On these paragraphs, we should add a CSS class of error-text. So make sure you add this on the first name error paragraph and the last name paragraph and the email error paragraph. Now they are red. And of course, if I enter valid values here, then this becomes submittable. And if we open the DevTools and I click submit, I see submitted, I see the entered values, and it's reset. And again, it's working as before now. So this is looking good now. And now we applied our custom hook and what we learned to this new form as well. Now let's talk about simplifications and what else we could do. Now you could definitely try to outsource more logic. You could try to build individual input components which contain some validation logic or whatever. You could build an overall form component which handles a lot of that. You could build more custom hooks which, for example, return entirely pre-configured inputs or forms. And attached you find an article on that which might also be interesting to you, where we also build a complete use form hook which even spits out readily configured input elements which you can use in JSX. I want to focus on the basics here though, and that is already a long module. For me, it mattered to explain how we can use what we learned about React to build great user experiences and to build forms and form behaviors that make sense to our users, that feel good to our users. And at the same time, I of course also wanted to show you that this can lead to a lot of unnecessary code, and therefore building something like this custom use input hook can reduce code duplication and allows us to reuse logic. Even though we now of course still have some replicated code, but it is distinct enough, I would argue. Nonetheless, you can dive into building more elaborate custom hooks, and this attached article might be interesting for that. In addition, there also are third-party libraries that could be interesting to you. For example, Formic. Formic is a very popular third-party library for working with forms, and you can dive into the official docs to learn more about it. It's not really using hooks that much. It's more using components and patterns we know from older versions of React, so to say. But nonetheless, it's a great library when it comes to rendering forms and dealing with more complex forms and validation. Again, you can explore the official docs to learn how it works. The core idea is that you don't have to write much state management logic, but that instead you write your validation logic, you define your fields, and then let Formic do the rest. A little bit as we did it with our custom use input hook. There we also focus on passing in the validation logic, and the hook then manages the state for us. Formic then just has more use cases and outsources even more logic, or allows us to outsource even more logic to it. So that might definitely be worth a look. Now for this course though, I'm happy with this approach. You again got more practice with working with custom hooks, and you really see what's going on behind the scenes. Now you are definitely well prepared to handle forms and user input in your next projects. And of course, we are also going to work a bit more with forms in the course projects you'll find in the rest of this course. Now, as kind of a bonus, you could say, to this module, we can also practice working with useReducer again. Because what did we learn about useReducer? When does it shine, or when is it worth considering using it? We learned that it's great to use useReducer, or that it's worth a thought to use useReducer if we need more power. So if we have a lot of different possible state values and a lot of complex state updating logic, but also if we have related pieces of state which are managed in individual states, especially if those states depend on each other. Now, arguably, that's not really the case here. We neither have a lot of different state values nor a very complex state updating logic here. And in addition, we do have multiple states that kind of belong together, the value and the touched state. They both kind of represent the state of the input element, but they don't really depend on each other. That would not really be true to state this. Nonetheless, to practice working with useReducer again, I will import useReducer here now, instead of useState, and now use useReducer for managing these two state pieces here. But again, it's not strictly required, it's mainly another practice for useReducer. So I'll start by adding a reducer function, input state reducer function, we could say. And you learned that this reducer function takes two main arguments. The previous state snapshot, which will be provided and passed in automatically by React, and an action, which will also be passed into this function automatically by React, but which is the action you dispatched somewhere in your code. And then ultimately you have to return a new state snapshot here. And we can return a default state snapshot, which we always return unless we change it in code we're about to add. And that could contain our value, so the value for this input, which initially is an empty string, and the isTouched state, which initially is false. And then here in the useInput hook, we can call useReducer and pass our input state reducer function to useReducer, and also provide our initial state, which is basically this state here, and hence I'll add another constant, initial input state, which simply holds this object, and I return this object here, and I also set this here as an initial state, so the initial input state. Now, useReducer, as you learned, returns an array with exactly two elements, just like useState, and the first element is always the state managed by the reducer, so the input state as we could call it. And the second element is always a dispatch function, which allows you to dispatch actions against that reducer. So I'll name it dispatch, but you can of course pick any name you want here. Now we can get rid of these two state slices here now, and now instead start working with input state and dispatch. For example here, for validating the value, there we can now use input state dot value. We know that our input state will have a value property because that is the structure our state here will have, the state managed by this reducer. We can also get the touched state from there. Input state is touched. Now, when value change handler executes, we want to dispatch an action against our reducer, and you learned that it's totally up to you how such an action looks like, but it often is an object with a type property, which identifies the action. And here I'll set type to a string called input. And it can also carry a payload. And here I'll add a value property to this object, which holds event target value as a value. And then I can get rid of this line here where we set entered value. Now we also want to dispatch in the input blur handler. And there we could use the identifier blur. And we can also provide a value here, but we're not actually interested in the value here. So there instead I can also just pass in an action like this. Now when we reset, we can dispatch an object where the type is reset, for example. Now when we return, I want to return the value, and that would be input state.value, and that is already it. With that, we're good here. So now we just need to handle these three action types, input, blur, and reset, in this reducer. So we can check if action.type is equal to input, or if action type is equal to blur, or if action type is equal to reset. Now, if it is equal to input, then I want to return a new state object where I, in the end, set value to action.value. Because in the input action case here, we will have a value property on the action object, which carries the entered value. And I want to set this then. Now, I don't want to set isTouched to true, because whilst we have a keystroke, the user didn't finish typing yet. So I don't want to set isTouched to true, otherwise we would kind of break the behavior we built over this module, where we only present error messages once the user is really done. Hence here, instead I want to copy the existing state, so I will set isTouched here to state.isTouched, using the previous state's isTouched value. Now in the blur case, I want to return a new object as well. And here I want to set isTouched to true, because that is what we do when the input blurs. It should now be marked as touched. On the other hand here, I don't care about the value. We could update it, we could get it from this event object in the input blur handler, but we don't really need to do that since we're updating the value on every keystroke anyways. So hence here I can set value to state.value, simply using the existing value. And if we reset, I return an object where I set isTouched to false and value back to an empty string to reset this. And this is now our custom hook using useReducer. If you now check this again here, you still get the same behavior as before, where we can fill out the form to make it work, and where we still also get errors if we, well, have errors. So that all still works as before, but now with useReducer, simply as a little extra exercise. It is again time to apply what we learned. In the last course sections, we did learn about sending HTTP requests, and we did learn about forms and handling user input. In this course section, we'll continue working on this food order application, on this food delivery application, on which we started working a couple of sections ago already, and we are going to add a form and we are going to add HTTP requests, because this course section is about applying what we learned to this food order app. And therefore, we are going to add a basic checkout form where we can enter our name and address once we click on the order button. We also then want to submit that entered data to a backend, so to a server with a HTTP request. We probably also want to validate the user input on the client before we submit it. And we also want to fetch some data from a server, from a backend. We want to fetch the meals data. So the data here for these dummy meals which we got, which is currently hard-coded into the JavaScript files, that data should move to a backend as well and should be fetched from there. Now, when I say backend, I still mean Firebase, of course. We used this as a dummy backend before, and we can still use it here. Here I will use my existing project which I got, and I'll use the real-time database there. If you create a new project, make sure that you also do start with the real-time database. And of course, make sure that you did go through the HTTP section and so on. There I'll clear any existing data which I have. And you want to make sure that under rules, you have read and write set to true so that you can send requests to that database successfully. Now, how to work with the database, that is something I did show before in the HTTP section. Now, in this module, we are going to implement these features here step by step together, but this also is a great chance for you to practice what you learned. So definitely try that on your own first. Try implementing all those features on your own first. Move that dummy data to Firebase manually. You can add data manually here to Firebase. So move that dummy data to Firebase. And once the data is there, implement these 3 main features to this food delivery app on your own. Try it on your own first. And thereafter, from the next lecture on, you can check my approach to compare it to yours, to solve problems if you got stuck in between, and to then simply build this together with me. So, were you successful? If you didn't try it on your own, definitely consider trying it on your own. Practicing what you learned is an important aspect of learning React. Either way, we're now going to implement these features together. And I will actually start with fetching the meals data, even though that's the bottommost point here. But I will start with that because I think it makes sense that we are able to load that data from a server, from a backend. For this, in the Firebase real-time database console, I'll add a new node manually, and I will name it meals. And then click this plus again here to add some nested data. And then I just want to add my meals data to Firebase here. Now for this, I'll start by giving every meal an ID here. So I'll just use M1 as a key. And then the value for that will be the nested data for that meal. With that, I'm kind of replicating that Firebase data structure we saw in the HTTP section for the dummy data I got here. So for the meal with the ID M1, I want to have a name field and a value of sushi, a description field with this value, and a price field with this value. So let's start with the name field here and enter sushi as a value and click add. And now this entry was added. Now we can add more nested data to this M1 meal by clicking this plus and adding the description field, where I then enter a description like this and click add, and add a price field, which is this value, which has this value. So let's enter that. Okay, so with that we got the first meal. Now let's click on the plus here next to meals, and let's add a new meal with a different ID, M2, and then click on this plus here to add the nested data like the name, and that will then be schnitzel here in my case. Click add, and then add the description here, which is this text here, like this, and let's add the price field with a value of 16.5. So now we got the second meal added. And I'll continue doing that You can, of course, fast forward here if I'm boring you. I will now add the third meal with a name of barbecue burger, like that. Click add, and then also add the description here. American, raw, and meaty. And also add a price for that third meal here. So let's add a price field like this. And now there's only one more meal to go, the green bowl. For that, I'll add a new meal with an ID of M4. Click the plus. And for the name field, it's now green bowl. For the description field, I will now add this description here, like this. And then last but not least, for the price field, it's $18.99. And with that, all the data is on this Firebase server. And of course, if we were the owner of this food delivery service, we could be administrating the data here. Now let's work on this front end and let's fetch that data from that server. So here in available meals, I now no longer want to use the dummy meals array. So I now want to get rid here of dummy meals and instead fetch data from Firebase. And we learned how that works. For this, we can use the built-in fetch API, which is built into the browser. So this fetch function exists out of the box. We could also use a custom HTTP hook, for example, the one which we built in the HTTP section, but here I will build it from scratch again. Though if you want to use a custom hook or want to build a custom hook or use some third-party HTTP hook package, that would of course also be okay. But I want to build it from scratch here, so I'll write the fetch function from scratch, and I want to fetch my meals data when this component is loaded. And we learned that we can utilize the useEffect hook for this. So we can import useEffect from React to trigger a side effect like fetching data from the web when some data changes, or for example, when that component is loaded for the first time. So here I'll set up useEffect and the effect function that should be triggered. And then in there we can call fetch like this. Now here we want to send an HTTP request to this meals node here. So to this Firebase URL and then this meals node. So the full URL is this Firebase URL, which I grabbed here, and then meals.json. .json is something Firebase specific, which we have to add. So with that, we're sending a request to this REST API endpoint, which Firebase exposes here, and we're sending this request to fetch the meals. We could configure this request, as you learned, with a second argument passed to fetch, but there we could, for example, change the HTTP method and so on, and we don't really want to do that here. We want to stick to the default GET request, so this is fine. Now, fetch returns a promise, since sending such a HTTP request is an asynchronous task. Hence, we can add then here to provide a function, this function here, which is triggered when the request is done, once we got a response. Or we use async await. For this, we need to turn this into an async function so that we can use the await keyword here. But here we have to be careful. And actually, we even get a warning here. At least you might get one depending on your project setup. The function you pass to useEffect should not return a promise. Instead, you learned that the function you pass to useEffect may return a cleanup function which can be executed. You learned about that in the module where I introduced useEffect. That cleanup function should run synchronously though. It should not return a promise or anything like this. Hence, this overall function which we pass to useEffect must not be turned into an async function. Instead, if you want to use async await instead of useEffect, simply create a new function in here, fetch meals, like this, and use async here, and put your code, this line of code, into this nested inner function. and then just execute fetch meals as part of useEffect. By doing it that way, this function is still executed and you can still use async await, but the overall useEffect function does now not return a promise. It's now not an async function because we have not added async here, which would not be allowed. So that's a little workaround around that restriction, which is absolutely fine though. So now with that, we can use async await to get a response here for fetching our meals. And then you learned that for fetch, we can parse data. We get our response data by calling response.json, which also returns a promise. Hence, we also have the await keyword here. So that's how we can get the response data which we're fetching, and then we can utilize that response data. Now, the response data we're getting in the case of Firebase, and that's something Firebase specific, will always be an object where these IDs here, M1, M2, M3, M4, will be keys, and then the values for those keys will be nested objects with those properties. Hence, what we get back here, response data, will be an object, and I want an array. Therefore, we need to transform this. So we can create a new constant loaded meals, which is an empty array. And then we use a for in loop to go through all the keys in response data. So in this response data object. And the keys will be these IDs here. And the values for those keys will then be the nested objects, as I just explained. So here we then want to reach out to loaded meals and push a new object into this initially empty array, where we, for example, set the ID property. We need to set ID here because we do expect our meals to have an ID field. So we should make sure that we transform the loaded data such that we do have an ID field. And then we can set ID equal to key because, as I just mentioned, the key will be the ID of the individual meals we're fetching. Now, we also need to set a name, the description and price fields, and name can be pulled out of the response data for the given key. With that, we access the nested object in there, and then that nested object will have a name field, as I just showed you. We're now accessing this nested name field here, for example. And we don't just do that for the name, we also replicate this for the description here. And then also one more time for the price. Like that. And with that, we're transforming the fetched data. Now we need to expose that fetched data to the rest of our component, and we want to re-render the component once the fetching is done, because that's an asynchronous task which is only started after the component loaded for the first time, and therefore initially there will be no data, and we want to update the component once the data is there. Now, when we have data that changes and where a component should be re-evaluated once it did change, whenever we have a use case like this, we need state. So we should also import use state here from React, and then set up some state in this component by calling use state. And here we initially might have an empty array, because this state will be our meals and the set meals state updating function. It's now the meals which I want to use down there instead of dummy meals to render the meal items. And initially that's an empty array again, but that will change once the loaded data is there. And therefore here, after this for loop, once we filled our loaded meals helper constant here with the transformed data, I want to call set meals. So I want to call that state updating function and pass in the loaded meals. So that array which we populated here. With that, we're setting the data, and therefore then this component should update. Now for this useEffect function here, currently our dependency array is an empty array. So we have no dependencies, which means this useEffect function, this function here, will only run when the component was first loaded. It will never run again thereafter. And that sounds about right to me. We indeed have no dependencies in there. We're not using any external component-specific data. We're not using any props in there or anything like that. And therefore, only running this when the component is first loaded makes a lot of sense. So we don't need to change this dependencies array. And therefore, with all of that, if we save this, we go back to our project. If I reload, you see initially that list is empty, but then the data arrives quickly. Now, of course, we can show some loading spinner or some loading state instead if we want to, though currently the experience also isn't too bad, I would argue. But still, handling a loading state and a potential error state is something we're going to dive in next. So we are fetching our data, but as I mentioned at the end of the last lecture, we are of course not showing any loading or error state at the moment. And that's not necessarily the behavior we want. Instead, we might want to only load this list of meals here once we really got a list of meals. And to achieve this, we need to manage more state. And now, since we will have related state, we could also consider using useReducer for that. But I'll stick to 3 individual use state pieces. I will add a isLoading state and a setIsLoading state updating function. And initially it's false. Initially we're not loading. But in useEffect, at the beginning of this fetchMeals function, I want to call setIsLoading and set this to true, because now we clearly are loading. Of course, since we know that right when this component will be rendered, we will be loading, we could also consider not setting isLoading to true here, but instead setting the initial state to true. Because we know that we always will start with loading data in this component when the component is rendered. And therefore, in this case, that's fine. Of course, if you have a component where that's not necessarily the case, where you're not necessarily loading just because the component was created for the first time, there you might not want to set this. But here it should be fine. Now we want to set isLoading to false once we're done. So in the end, once we also set the meals, we want to set isLoading to false, because we now definitely are done loading. And now we can use setIsLoading to control what we render. And we could say that we don't want to render our meals at all. So this entire section should not be rendered at all if we're loading. So for that, we can simply check if isLoading is true. And I check this before I try to map my meals. Before I do any of that, I check if isLoading is true. And if it is true, I will return something else in this functional component. So then we don't even make it to the code down there. And I'll return a section here where I simply have a paragraph where I say loading. Like this. If we add that code, you will see there is this loading text on the left, briefly showing up when we reload this. And that's, of course, not the best way to show it. And therefore, let's style it by adding a class name here of classes meals loading, written like this maybe. And then we can dive into this available meals module CSS file and add this quickly, add a class selector for the meals loading class, where we set text align to center and set the color to white. Of course, you can definitely give this a more elaborate styling, but it's better than nothing. Because with this class added here and assigned here to this section, with those changes made, if I reload, we at least have the loading text here. And it's still only flashing for a brief moment because Firebase is a quick backend, but it's better than nothing. Of course, here we could consider omitting this loading state since the data is loading rather quickly. But of course, we don't know which internet connection our end users might have, so showing this loading state might not be too bad. Actually, there it was showing up a bit longer. So that is not too bad. But what if we have an error? We should also work on that. Let's simulate an error. And for that, we can, for example, remove .json, something Firebase doesn't like. And if we do it and I reload, we therefore fail to load the data. We don't see anything here in our app, but we see it if I open the developer tools. There we see that we have an error. We failed to fetch the data. And of course, our typical users will not check that console. Therefore, we want to show the error also here on this screen. And it's up to you how you want to show it. I at least want to show an error message down here instead of loading. Hence, we need a third state. We need a state that determines whether we have an error or not. So an HTTP error, for example, but the state name is up to you. So here we have that. And initially, the value here is false or maybe null or simply undefined. Because it's not just a true false value, later instead I want to have the error message here, and initially I don't want to have any value. So an undefined value, so not passing any default value like this should be fine. We could also set it to null to be more explicit about our goal of not having any value initially. But I'll go with undefined. Now when we fetch data and we fail, I want to, set my error. For this, we first of all need to find out if we failed. Now for this, I want to check if response OK is falsy. So if it's not OK, hence the exclamation mark. And we'll make it into this if check if we have some error status code reported back by the server. And if that should be the case, I want to throw a new error here where I say something went wrong. And we could also look into the error response and see if the server gave us a more useful error string, but here I'll just stick to this generic error message. And I'm throwing it as a new error, which means that the lines thereafter won't execute. Instead, now we want to handle this error, and that's another advantage of using a separate function for wrapping this fetch logic. This fetch_metals function will now throw an error if something goes wrong with sending that request. Therefore, we can go to the place where we call fetch_metals, which is still inside of useEffect, but outside of the fetch_metals function, of course. And we can simply wrap this with try catch. So we can try and catch here. So we try calling fetch_metals, but if inside of that function an error is thrown, as is the case here, then we make it into this catch block, which is still inside of the effect function, but outside of the fetch_metals function. And then here we can do whatever we want to do. I want to set is loading to false because we're not loading anymore. Even if it's an error, we're done loading. And I want to set HTTP error to the error we caught. So we do get access to that error here when using try catch, and therefore I can set the HTTP error to the error we're getting, or to be precise, to the error message. We'll get an error object here, and that object by default has a message property. When we generate an error like this, and we pass a string to the constructor, that string will be stored in the message property of the created error object. And with that, we should be setting this error state. Now we can also utilize that, and we can check, maybe after we checked for whether we're loading, we can check if HTTP error is truthy. So if it has a string with some text inside of it, for example. And in that case, return yet another state. In that case, I want to return a section with a text of HTTP error. So where I output my error text. And I'll give this a class of meals error, which we have yet to add. And we can quickly add this together. Meals error. Here I'll also set this to text align center, but set the color to red. And that will not be too beautiful. I just want to have this little bit more error-ish style. You can, of course, fine-tune the styling exactly as you want it. So now with that, if we save this and I reload here, we'll notice something interesting. it still only says loading here. Now, that can be tricky to spot. The reason for that is that we're using try-catch, but keep in mind that fetch meals is an async function. And therefore, it always returns a promise. Now, if we throw an error inside of a promise, that error will cause that promise to reject. So we can't use try-catch to wrap it unless we also await this, for which we would need to turn our effect function here into an async function, which we're not allowed to do. Now, we could still work around that by putting that into a separate function, which we call thereafter, so that we have two separate functions, one for sending the HTTP request and one for error handling, and that would be absolutely fine. But here I think it's a bit easier to simply use the fact that it's a promise and add the catch method on it. Since that returns a promise, we can add then to handle success cases when the promise fulfills successfully, and we can add catch to handle errors coming up inside of the promise. And therefore, instead of try catch here, we want to catch the error we're getting and move that code here into this catch block. And that's the traditional promise-only way of handling an error inside of a promise. And I hope I could make it clear why we need this here. With that, if we save this, if I reload, we see loading briefly and then failed to fetch. And again, of course, we can definitely improve the error handling here. We can show a more useful error message, but here my focus is to show you how it generally works. Because what you now render on the screen, that's of course not related to HTTP requests or anything like that. Here you can now build any user interface you want. But that therefore is how we could also handle errors. And with that, I'll re-add .json here to get rid of that error. And once we do that and we reload, we of course do load the data successfully again. And therefore, with that, we now implemented this third feature here, fetching meals data. Now let's work on a checkout and order form so that we can fetch some user data, which we then, as a last step, also submit to the server as an order. So now we added a couple of items to our cart. It would now be nice if we could order them. For this we have the order button, but currently that's not doing anything. I want to make sure that when we click this order button, we kind of expand this modal, and we also show a form where the user should enter the address and the name, and thereafter we can confirm that input to send off that order to the backend. And therefore the first step is to add that form and to add validation to that form. For this, let's go back to the code, and there, into the cart folder, where we have this cart component, which renders this modal with our cart data, with the total, and with those buttons. And here, below the total, above those buttons, I now want to render the form where we enter our data. And for that, I'll add a new component, and I'll name it checkout.js, because it will be the checkout form. And we'll also need a checkout.module.css file for the styling, though I'll provide the styling to you once we're done setting up that form. So here, in the checkout component, we now want to create a new functional component. So we create our component as we always did. We can import React. Depends on your project setup if you need that or not. I don't need it here, so I'll omit it. And I will already import classes from /checkout.module.css. Now in here, we want to return a form. We want to return a form with the various inputs for the different values we want to fetch. For this, I'll wrap every input into a div with a class name of classes.control. And in there, we can have a label, let's say for the name of the user. So that will be for an input with an ID of name. And then we have that input thereafter of type text with an ID of name. Should be matching that value here for accessibility. And we also add another input where we fetch the address of the user. So we want to have the street, and that should also be of type text. However, I'll give it an ID of street. And I add a new input where I also want to get the postal code. So that will get an ID of postal and will also still be of type text. Technically, the postal code looks like a number, but it should be text so that we can also start with 0 without kind of treating this as a null value, which I don't want. So that will also be text. And then last but not least, let's also grab the city, which is also text. So a bunch of text data which we're fetching here. The name, the street, the postal code, and the city. And then we also need a button to confirm this. So I'll say confirm on that button. Now that we built this basic unstyled checkout component, we can go back to the cart, and here I will then import checkout from ./checkout, so that new checkout component, and render that here below the total amount. And for the moment, I will always render it. We'll later make sure that it only shows up once we click on order. If I now save this, we have that form here with the confirm button. Now, of course, there are a couple of styling issues, which we'll fix in a second. But before we fix those issues, let's make sure that this form only shows up when we click order, and that when it shows up, we actually get rid of these two buttons down there. And instead, we only show the confirm button and maybe also a cancel button here. And that we then also have basic functions that get triggered when we click those buttons. So let's make sure that this form only shows up once we did click on order. Now for this in the cart component, we have this order button, and currently it's not doing anything. So of course here we can add an on-click listener, the on-click prop, to trigger some function when that is clicked. So here I'll add a new function, order handler. And whenever this is clicked, I want to make sure that we show the checkout form. So we wire up the order button to the order handler function we just added. And then to show this checkout component conditionally, we need to use state. So let's import use state from React and then set up some state for this cart component. And here we could name the state is checking out or something like this. This sounds a bit weird. Let's maybe name it is checkout like this and set is checkout. And initially that's false because initially we're not in checkout mode. But I want to set it to true if we clicked on the order handler. So here I'll set is checkout to true then. And now we can use the is checkout state to conditionally render the checkout component. So we can check if is checkout is truthy and use this syntax, which you saw a lot in the course, to render checkout if is checkout is truthy. And with that, if we save this, initially there's nothing here. But if I click on order, we show that. Now we might be running into some space issues here if that gets longer and longer, but we'll work on the styling in a second. Before we work on the styling, let's hide these two buttons when we clicked on order, and let's also add a second button to the form therefore, which still allows us to cancel. Now to hide these two buttons, we of course just again need to render them conditionally, and I could therefore just add code where I check if is not checkout, and only if that's the case we render that div. But to keep the JSX code down there a bit more structured, I'll grab that div with those buttons and add a new constant here with my modal actions and store my div in there in the modal actions. And then it's the modal actions which I want to render conditionally if not is checkout, so that the JSX down there stays lean and we have that div with the actions up there. Okay, so now with that, these buttons are gone. Now let's add a new button to that form. So for this, in the checkout component, I'll add a second button where I say cancel, and important, this button will be of type button so that it doesn't submit the form. Only this button will submit the form. And speaking of that, I want to handle both button clicks. If we click the cancel button, I want to close the modal, and that therefore means that I in the end want to do the same thing as I did in the card component when this close button was clicked. There we triggered props on close, so in the end I want to trigger that same function now from inside the checkout component. Hence for the cancel button on click, I expect to get some function through props which I can forward this event to, and I will simply expect the on cancel prop here. It's our component, so we can expect whichever prop we want. And I will expect the on cancel prop, which means that now when we use checkout in the card component, we need to set a on cancel prop, and as a value I want to point at the on close prop value to forward that event even further. And now of course we have some props drilling here, so we're passing props through multiple levels of components, and hence we could consider using context instead for managing the modal visibility, but I will stick to passing down props here because I don't want to make that too complex here and kind of go into a totally different area and add another context. So I will simply pass down my props here. Now with that, if I save this, if I click cancel, this modal is again closed. Okay, so that works. Now when we click confirm, the form will be submitted. And here we then want to validate the user input and show errors, show some feedback if something is invalid. And of course, if it is valid, we want to submit it to the backend, to Firebase. So for the moment, therefore, I want to focus on doing something, on triggering some function. And hence in checkout.js, we can add a new function here, confirm handler, where we get an event object, and we will get that automatically because I bind this function to the onSubmit event on the form. And then you learned that we should call event prevent default to ensure that the browser default, which would be to send an HTTP request, is prevented, so that this request is not sent. And with that, this button will trigger this form submission and will therefore trigger this function. Now we need to validate the user input, and for that we need to read what the user entered, and we then want to show some feedback, and of course potentially, if everything is all right, send the card data to the backend. But step by step, in the next lecture, we'll work on validating this and on showing some feedback. Now before we add any logic, let's add some styling. For this attached you find three files. You find the checkout module.css file, which you should use to replace yours with it. You will find a slightly updated modal.module CSS file, which you can use to replace yours. And checkout.js. I also attached this file because there I changed the returned JSX code slightly. For example, I wrapped the buttons in an extra div. So you can either replace your checkout.js file with mine, or at least replace your returned JSX code with mine. And once you did all of that, you should have a form that looks like this. Now, this is scrollable to make sure that we always are able to squeeze everything onto this screen. And of course, as always, you can tweak the styling and change this. This is just some basic styling which does the trick and looks okay, I would say. Now, with that, if we again start from scratch, we can add something to the cart, click on order, and then we get our form here. And actually, this should not be cut off. So I will change height to 19 rem here on the form. Slight oversight from my side, but with that, we're good. Now let's make sure we do get the values the user entered. We then validate them however we want. And we then also either show an error message if something's wrong with the entered data, or we submit it to a server. Now let's start with getting the entered data. For this, we got various options, 2 main options to be precise. We can either listen to every keystroke, get the entered data and store it in some state and update that state with every keystroke, or we get it once the overall form is submitted. Now in the forms section I showed you both, and I showed you various ways of handling user input and validating it. I showed all of that in great depth there. Therefore here I'll keep it simpler. I will not get the values with every keystroke. Instead I will use a reference with useRef to get the values only once the form is submitted. So I'll import useRef from React, and then we can create a reference by calling useRef, and we'll get a reference for our name input, for example. So a name input reference which we get by calling useRef like this. And I'll do this 4 times to repeat it for the street input, for the postal code input, and for the city input. And now we need to connect those refs to the form elements here. And for that, we can use the special ref prop, which we set on the input elements to connect this first input to the name input ref, the second input here to the street input ref, the third input here to the postal code input ref, and the last input here to the city input ref. Now these refs are connected, and now we can use them to read whatever the user entered when the form is submitted. Now for this we got our confirm handler here, and here we can then get the entered name by reaching out to the name input ref .current. It's always .current. That gives you access to the actual value stored in the ref, in this case to the input element. And since we now have access to an input element, we can access .value because every input element object in JavaScript has a value property that holds the actual value entered in that input element. And we also repeat this for the entered street, where we then use the street input ref to get the value, and we repeat it. Whoops, that should be entered street. We also repeat it for the entered postal code to use the postal code input ref. And one last time, we repeat it for the entered city to use the city input ref value. And now we can validate this. Now, it's of course up to you which validation logic you want to apply. I want to keep it fairly simple. I want to check that all my values are not empty and that the postal code, let's say, is exactly 5 digits long. For this, I'll add a couple of helper functions here outside of the component function. And the first one is the isEmpty helper function, where I get a value and return true if value is empty. For that I call trim on value and then check if the length is equal to 0 or simply if the trimmed string is equal to an empty string. And the second helper function which I'll add here is the isNot5chars, whatever you want to name it, where I get a value and I also trim this and I then check if the length is not equal to 5, so if it's not 5 characters long. Now these two helper functions can be used to now validate those entered values. So we can add a new constant, entered name is valid, and that should be true if we can call isEmpty and pass in the entered name, and that then returns false, so if it's not empty. So entered name is valid if not is empty entered name. If the entered name is not empty, this is valid. And I'll repeat this for the street. So the entered street is valid, if not is empty entered street. And I'll repeat that for the city. So the entered city is valid, if not is empty entered city. And now for the entered postal code to be valid, I will check if not is not 5 chars for the entered postal code. And that can be a bit confusing to read. Not is not. We could also simply name this is 5 chars up there and check for equality, like this. And then say it's valid if is 5 chars. That's the simpler form of writing this. We could do something similar for is empty and check for the opposite, but I think that's not too tricky to understand. Now we got these 4 helper variables here, which hold true or false. And now we can check if the overall form is valid by combining all these values. Only if all 4 constants here have a value of true, the overall form is valid. And I'm doing this very explicitly step by step here to make it as easy to follow along as possible. So now we can check if entered name is valid and entered street is valid. Combine that with entered city is valid. And last but not least, with entered postal code is valid. And only if all 4 together are true, form is valid will be true. So if form is valid, we can now submit the card data, because here we know that we gathered valid data and we cannot proceed with that. But if the form is not valid, we want to show an error. And therefore that's what I'll actually check for here. I'll check if not form is valid, and then I want to set an error and give some feedback to the user regarding what went wrong. For that, I will first of all return here to not continue with code execution, because later I will submit the card data here, and I don't want to reach that code if the form is invalid. But before we make it to this if check, I want to update some state to give the user some feedback. And here I want to manage 4 pieces of state since I have 4 inputs. And therefore, again, we could use reducer to kind of combine that all, or to manage that with a reducer function in general, but I will stick to use state here. You'll learn about use reducer and all of that in the forms module though. Now we'll use state, and I will register a new state here with use state. And here, whoops, not like this. Instead, some use state with use state. And here we could use 4 individual state slices or 1 combined state slice. And I'll go for the 1 combined state slice to mix things up. So here I have my form inputs validity and a function to set the form inputs validity. And now that will be an object where I have a name field, a street field, a city field, and a postal code field. And now we need to give those fields some values. And I simply want to have true or false as values here, determining whether the field is valid or not. And initially I'll treat them as valid even though they technically aren't, but I don't want to show error messages at the beginning. Now we could work with the touched state in addition to the validity state as we did it in the forms module, but to keep things a bit shorter here, and since we don't have an as elaborate validation approach as we did in the forms module, I will stick to a starting value of true here. Now the goal is to update the correct field for the different inputs here when we submitted the form, to update those true values with the actual validity after we tried to submit the form. So for this, maybe before we even derive form is valid, I will set the form inputs validity state to a new object. And here I want to set the name field to entered name is valid, the street field to entered street is valid, and so on. So I'll use those inferred validities, which we infer here as new values for the different keys in this state object. So here we have the entered postal code is valid value. Now we don't need the function form of this state updating function for updating here, because I am overriding the entire state with a brand new object where I do assign new values to all my keys. And with that, we have information about the validity of the different fields. We can now utilize that in the JSX code down there. For example, to show an error message. Here for the name, we could check if form inputs validity dot name, so if we dive into the name field, if that is not true, hence the exclamation mark, then we want to show a paragraph where we say, please enter a valid name. Now, if we do that and save this, you see initially that's empty. But if I try to confirm this, I now get this error. And of course, we can now repeat that for all the inputs. So here we check .street and say, please enter a valid street. And here we do it for the postal code. So .postal code. And then we say, please enter a valid postal code, 5 characters long. And last but not least, here we check for .city and say, please enter a valid city. I also prepared some extra styles in the checkout module CSS file, where I have an invalid class, which we can add to these divs here if an input is invalid to show extra error styles. So here on the name input, for example, instead of just adding the control class, I'll set up a template literal here to always inject the control class into the string, but to also inject another class if that input should be invalid. So here we can check if form inputs validity.name. If that is true, I don't want to add any extra string to that classes string, but if it's false, I want to add classes.invalid here. With that, we add the extra invalid class to that list of classes if that input is not valid. And of course, instead of doing that inline here, we could also grab that code and add a new constant, name control classes, and store that value in that constant so that down there we just point at name control classes like this. That's an alternative way of doing that. And we can now also repeat that for the street by checking for form inputs validity.street. And we do that for the other inputs as well. And we have some code duplication here, but again, that's also something we talked about in the forms module. And we could, for example, reduce that by creating a separate input component, or reduce some other duplication by adding a custom forms hook, for example. For the moment here, I'll stick to this approach. And hence I'll add a postal code control classes constant where I check form inputs validity.postal code, and then add another constant, the city control classes, where we check form inputs validity.city. And now we just need to assign these constants to the different divs. So here for the street div, it's the street control classes constant, which we assign as a value for class name. Here for the postal code, it's the postal code control classes, which we assign as a value to class name. And for the city, it's the city control classes. And with those changes made, if we save this, if I confirm this, we get a bunch of error styles. And of course, if I enter something valid and I confirm this, it's not showing up for that input again. So you see that this now works. Now feel free to definitely turn this into a more elaborate form validation here. For example, by adding a custom form hook, or by also listening to the touched state and clearing errors as you start typing. We did dive into all of that in the forms section. I just didn't want to bloat this module again with all the topics covered there. Instead, the goal was to pull out the essence of that module and just add some basic form validation here. And therefore, with all of that, we can now also confirm this without errors if we enter valid values. And hence now, as a last step, let's make sure that those values are fetched and are sent to the backend. So let's now send a request once the form is submitted. Now this checkout component is already a pretty full component with a lot of code in there, and therefore I'll not add the request logic in there, but instead I want to kind of submit or send the submitted data back to the cart, where we then also have the cart data, which is good because we need that to send it to the server, to then send both the cart data, so the items in the cart, as well as the submitted user data to the server. Now, one important word here. On a server, you should typically never trust the data you get from a client, because validation as we built it here can always be circumvented. For example, I, as a visitor, could edit the loaded JavaScript code. It's not hidden from me, I can edit it. Attached you find an article and a video with more information on that. Therefore, you typically always want to validate incoming data on the server as well. Now here, we only have a dummy backend with Firebase, and whilst we could actually also add some server-side logic to that, that's simply not the focus of this course, since this course is about React, which is a client-side library. If you want to dive into server-side code, server-side validation, writing your own server-side code, I of course also got courses on this, for example my Node.js course. But that's just a side note. I just wanted to emphasize that you should not trust client-side data like this. You, for example, typically also would want to validate those submitted cart item prices with actual database data on the server. It's not something we do here, but I want to make you aware of that. So therefore, it's the cart component where that data should be submitted to the server. And for this, I'll add a new function in that cart component. Submit order handler, that could be the name of that function. And in here, I expect to get the user data as an argument, as a parameter. We already get access to the cart data through the cart context, so that won't be a problem. And therefore, all we now gotta do is make sure that this submit order function is called from inside the checkout component and that it receives that user data. So for that, I'll pass it to the checkout component through a prop. Let's say the on submit or on confirm prop, up to you, it's your component, where I point at the submit order handler. So on confirm is the prop name, hence in checkout, in this confirm handler, once we validated everything down here, we now want to call props.onConfirm. So that prop name we're expecting here in the cart component. We want to call props.onConfirm and now forward that user data, which should be an object because I'm not expecting multiple arguments for the name, street, city, and so on, but I am expecting just one argument here, the collected user data. So let's group that user data into an object here where we set the name equal to the entered name, not the validity, but just the name. Set a street field to the entered street, set the city field to the entered city, and set the postal code to the entered postal code like this. And with that, we pass the data from the checkout component to the cart component. In there, we now want to send the request to the backend, and we want to send both the user data as well as the cart data. Now for this, we can again use the fetch function and send a request to Firebase. So to our Firebase URL here, and then to a new node of our choice, for example, orders.json. You don't need to create it in advance. It will be created dynamically. And the important thing now is that this should be a post request. So we need to pass this configuration object as a second argument to fetch and set method to post. We then also need to add the body and set this to JSON stringify, since we need to send JSON data, and pass in all our data. And that's an object with the user data. So here we could set a user field and pass the user data we're getting here as a value for that field. And then maybe add a ordered items field. And that should then be our cart. Now for this, we have our cart context where we get our items. So we can then set cart context items as a value for the ordered items. And that's the data we're then sending to the backend. Now, just like this, without anything else, it should already work. We're not handling the response yet, we're not handling errors or anything like that, but we are sending a post request. So this should already work. If we save that, and I do have some data entered here, I do have some cart data, and I click confirm, that should have worked. And indeed, if we check the Firebase console, you should see an orders node now with a new auto-generated ID for this newly added item. And then in there we have user with the user data we entered and ordered items with the cart data we submitted. So that is working. If it's not working, definitely double check your code, compare it to mine, because that should now be working. Now, therefore, as a last step, I of course want to change the user experience a little bit. I want to clear what we see on the screen here if we clicked confirm and show a loading spinner and then a success message if the card was submitted. And of course, the card should then also be cleared thereafter. So let's handle this submission state. And for this, we need use state and then manage a new piece of state here in the card component. And that is the is submitting state and set is submitting. And initially that's false. But I want to set it to true as soon as the submit order handler gets called. So here I'll set is submitting to true. Then I want to wait for this fetch function to finish, and for this we can await this and turn this into an async function. Here we have no problem with that because this is not an effect function, but instead this is a regular function which gets triggered when we submit the form. So here we then await and we get back our response, and we could now use the response to check the status code and potentially throw an error, which we then would have to handle, to also show an error message. I will not do that here to keep this a bit shorter, and instead I'll assume that it always works. In reality, of course, and maybe as an extra practice, you might want to implement error handling as well, just as we did it a couple of minutes ago with the other fetch request for loading the meals, or in the HTTP module. Here, to save some time, I will not implement it. Instead, we submit this, or we set is submitting, then we await this, and therefore once this request is done and we got a response, we can set is submitting back to false. But now I want to make sure that we show some success message. And therefore I'll add another state, the did submit state, and set did submit. And initially that's also false, but this should be set to true as soon as we did submit our data. So here we can then set did submit to true once we're done sending that request. And now we can work with these two states in our component. To be precise, I want to swap the entire content of the modal when we're submitting and once we did submit. So I'll add a new constant which I'll name cart modal content. And in there, I'll store all that code here. Now, since I now have multiple sibling items here inside of that constant, I need to wrap that with react.fragment. So we want to wrap this because, as you learned, sibling JSX code is not allowed. And for this, of course, we need to import React from React. With that, we can wrap that all with a fragment. And now we got the card modal content, which I normally want to render here, like this. But I'll now define another constant, the isSubmitting modal content, and that's the content that should be shown if we are currently submitting. And here I'll just add a paragraph where I say sending order data. Now that should be shown if we are submitting. Therefore, I only want to show the card modal content if we're not submitting, hence the exclamation mark. If we are submitting, I want to show the isSubmitting modal content. Now, last but not least, we can of course also be done with submitting. So I'll add another constant, didSubmit modal content, and that's another paragraph where I say successfully sent the order. And we could of course then also say something like you will be contacted once we're done preparing your order or anything like that. Here I'll just say successfully sent the order, and that should be showing up if we did submit. Then the didSubmit modal content should be rendered. And therefore we should also tweak these two lines and only show the card modal content if we're not submitting, and we did not submit yet. Did submit like this. So if not submitting and not did submit, then show the card modal content. I always want to show the isSubmitting modal content if we are submitting. But otherwise, if we did submit, I want to show the didSubmit modal content, maybe if we are not currently submitting. Though in this app, we can't really be submitting and have submitted already. Nonetheless, having this extra check also won't hurt. I hope this logic is clear. With that in place, if we now save this, we got our card here. If I click order, I now need to fill in my data, otherwise I get errors. So let's enter something here. And if I now click confirm, watch closely, we see our two other states. isSubmitting and now the successfully sent the order state. And of course, we can now still close the modal by clicking somewhere else. We can, of course, also add a new button to the modal here if we want to. We can wrap this here into a fragment as well, so that we can have two sibling components, the paragraph, and then next to that, for example, a button. So here we could grab our modal actions div and insert this next to this paragraph, get rid of that order button and just keep the close button, and give this a class of button instead of button alt. And on click, this will then close the modal. So if we now save this, if I again order this, enter some data here, whoops, max and test street 1, 2, 3, 4, 5 and test. Now I can close this with this button. So now we're showing these different states. Now, as a last step, I want to clear the card once we did submit, because currently it's never cleared. Our items stay in the card. So to clear that card, we need to go to our card context, to the card provider to be precise, and there we'll need a new action. We do have actions for adding and removing single items, but now we need an action to clear the entire card. So I'll add a new if check in this reducer here, which we added here in this card reducer, and check for action.type being equal to clear. And if we do receive this kind of action, then I want to return a new state where the card is empty. Now for this, we can return the default card state simply, like this. And of course, therefore, technically, we could also omit this if check. If we do dispatch an action which is not handled by one of our other if checks, we would have returned the default card state anyways, but doing it like this is a bit more explicit. Now we need to make sure that this clear action can be dispatched, and for this we want to add a new function here, the clear card handler, where we don't expect any parameters, but dispatch a new card action where the type is set to clear, like this. And now on the context, we need a new function. So in card context.js, I'll prepare it so that we get better auto-completion, the clear card function. And in card provider, on this concrete card context object, which we're constructing, we now need to add this clear card function and point at the clear card handler, like this. And now from inside the card component, we can execute that. So here in card.js, when we submit our order in the submit order handler, once we're done here at the end, I want to use my card context and call clear card to clear the card once we're done submitting. So if we now save this one more time and go back, now if I order here and enter something, if I confirm this, now my card was cleared and it is empty. And of course on Firebase, so on our backend, we see all those orders. Now that is it for this module. Now we're leveraging a backend for fetching our meals and for sending our orders there. We did add a form with validation, which we have to fill out. And we therefore practiced the key concepts and aspects we learned about over the last course sections. Now, of course, there's a lot which you could fine-tune or change. As I mentioned, you can implement more elaborate form validation. You can definitely add more complexity to this project. But my goal with this project here was to dive into the essence of those previous sections so that we practice the core concepts taught in those sections. Again, I can only encourage you to dive deeper, build some custom hooks, experiment with this project, maybe build your own project as well. That's always a great practice to ensure that you get better and better with React. In this course, however, we got so much content and I don't want to waste your time. Therefore, I'll try to find the right balance between diving deep when I introduce a concept and then practicing the core takeaways and the core concepts in practical projects like this. And therefore, let's now move on and let's dive deeper into React.